hello, good morning everyone. Good morning. Hello. Hi Mohinder. Hi Yuv. Hello everyone. Good morning. Good morning RPM cracker. Bio ma'am will come around 1. She'll come in the afternoon. After chemistry you will have the biology class. Good morning Sheena. Okay, I'm good RPM, thank you for asking. How are you? How's your preparation going, guys? Good morning Ash. Good morning everyone. Good morning multiverse. Hare Krishna. Good morning. Hi Kanchana. Okay. Hi. Yes, hi Single 89. I read much, it won't be enough for me. Oh, you don't get, okay. See, don't get disheartened. You try your best, you give your best, okay? You prepare for it, you give your best, and then rest marks will come, you know. Don't chase the marks. You should chase your knowledge, that you understand it, you know the concept, and you are able to apply it in your exam, okay? Marks will come. So today we are doing a complete revision of science. So we'll start with chemistry, then biology, and then finish it with physics, okay? So today we will be covering entire science from chapter 1 to chapter 14. Help, what help you want? Hello Daksh. Okay, so let's start. So firstly we will be doing a revision. And then after that we'll solve questions, okay? So let's start with the first chapter. It's just a revision, okay? Do not worry, do not panic. You got this, okay? Whatever you have studied, it is going to come in your exams, okay? Nothing is going to come out of it, okay? I know you are scared because of the maths exam, but your English went well, that's what I heard. And so do not worry, your science will be easy if you learn it, if you know the concepts, if you are able to apply those concepts, okay? Some questions might be hard, that's CBSE's speciality. 1-2 questions they give, they are hard, but rest the paper will be totally doable. You did not do, didn't we do? Yes, we did complete chemistry, but today it's a little different. We are doing a revision. Hello Manu. So according to the CBSE's guidelines, there are 50% question that will be competency based. 50%, that means half your paper will be competency based. Now in this competency based, they count what we count. We count case based questions, we count application based questions, we count anything that is application related, not straightforward questions, okay? They comes under the competency category. I'm good. How are you? How are you all? Okay, so let's start our first chapter, chemical reactions and equations. Okay, now let's talk about chemical equation. What is a chemical equation? So a chemical equation is a process in which one or more reactant gets converted into product, right? What is happening in a chemical equation, chemical reaction actually? In reactant you have some bonds, those bonds get broken and new bonds get formed, and because those new bonds got formed we get a product, right? Whatever the bond formation was in reactants, that would not be same for the product. Okay, let me explain it by an example. example, if let's say this is a reactant AB, right? There is a bond between A and B. What will happen if the reaction continues? This bond will break, and we will get A plus B, right? So what is happening here? Bond breaking is happening here, okay? Sometimes the reaction can be opposite also, right? Let's say C plus D combine to give CD. So initially there was no bond between C and D, but now after the reaction happened, there is a bond between C and D. So bond breaking or bond forming both comes under the chemical reaction criteria, okay? All type of questions. Okay. Some out of the book related concepts there. Out of the book related concepts, no, there won't be question coming from out of the book related concepts, okay? Why? I don't know. I don't understand your question first of all. Not fine. Don't be like that. You will be fine, trust me. Okay, so let's quickly revise it so that we can solve lots of questions. I have added lots of questions, okay? Chemical reaction. What is chemical equation? So chemical equation is nothing but a shorthand way of writing a chemical reaction. How you write a chemical reaction? You write using chemical equation. Now chemical equation is of three type: word equation, where you write the name of the reactant and the product in words. Then after that you have skeletal equation. In skeletal equation you replace the words by their chemical symbol. You replace the word of the name of the reactant and product by their chemical symbols. Then you have balanced equation. Now what is a balanced equation? In a balanced equation, where the number of, firstly it follows law of conservation of mass. Second, the number of reactant is equal to the number of product, okay? The number of reactant and product is balanced, okay? For example, here magnesium combines with oxygen, we get magnesium oxide, right? But the reaction is not balanced. Here you see the reaction is not balanced. Why? Because we have two oxygen and only one oxygen on the product side. So what we will do, we will balance it. Now you see, my dear students, all the elements are balanced for this reaction, okay? That is a balanced chemical equation, right? Now what characteristic it has? It follows law of conservation of mass, that is mass can neither be created nor be destroyed, but it can only be transformed from one form to another, right? Second, the number of atoms remains same, that is the number of atoms on the reactant side and the number of atoms on the product side will be same. If you have 2 magnesium as reactant, you will get 2 magnesium in the product also, right? Both reactant and products are balanced. Okay, one more thing, if you want to get additional information from a chemical equation, what we do, we write the physical state of reactant and product. If it is solid, we write S. If it is liquid, we write L. If it is gaseous, it is gas, we write G. Okay, and if we have an aqueous solution, we write A, Q, right? For precipitation, we write this arrow, downward arrow, this show precipitation. Okay, now what are the characteristics of a chemical reaction? How do you identify if a chemical reaction is happening or not? So there are 5 characteristics, my dear kids. First is, whenever there is an evolution of gas, it is considered as a chemical equation, right? Second is formation of precipitate. So in a reaction, if precipitate formation is happening, that is also considered as a chemical reaction. If change in color, for example, that reaction you remember, right? Copper sulfate reacts with iron and we get iron sulfate and copper, that is a reaction showing change in color. So that is considered as a chemical reaction. Next, if there is change in temperature, exothermic reaction, endothermic reaction, right? There is a change in temperature. These kind of reactions, this process is happening, if temperature change is happening in a process, then it is considered as a chemical reaction. Change in state also, for example, when you burn a candle is solid, but you get light, you get carbon dioxide and wax liquid, right? So carbon dioxide is gas and wax is liquid, right? So there is a change in state, that is also called a chemical reaction. Okay, now tell me what chemical reaction is happening when we are burning a candle. What is the name of that chemical reaction? Okay, these are the different type of chemical reactions. Let's start by one by one. Combination means when two or more reactants combine to give a single product, that is combination. Then you have decomposition, which is the opposite of combination, in which single reactant breaks down into two or more products. A single compound breaks down into two or more products, that is decomposition. It happens in three ways: thermal decomposition, photolysis and electrolysis, right? Thermal means using heat we are decomposing, photolysis mean using sunlight we are decomposing, and electrolysis mean using electricity we are decomposing. Okay, next is displacement reaction. What is displacement reaction? It means when a more reactive element displaces a less reactive element from its compound, that is a displacement reaction, right? For example, here, as chlorine is more reactive, it will displace a bromine from its compound, sodium bromide, right? Similarly, you have heard of the reaction copper sulfate. Again, very common reaction. It has been asked multiple times. This is also an example of displacement reaction. We get iron sulfate plus copper. Okay, thermite reaction. You remember, thermite reaction is also an example of displacement reaction. Then we have double displacement reaction. So in double displacement, two things are getting displaced. Two ions will be getting displaced. So here, both the different atoms of group get exchanged. So you can say both the ions of the reactants get exchanged. Both the ions of the reactant gets exchanged. Here, barium chloride and sodium sulfate, we will get barium sulfate and sodium chloride. You see, there has been an exchange of ions here, right? That is a double displacement reaction. Now, my dear students, I don't considering the pattern and the papers that we are seeing from the previous paper, like CBSE English and maths, so straightforward definition I don't think they'll be coming. What they will be giving more, this kind of reaction they will be giving, and they will be asking you what reaction category it comes under, what type of reaction is this. Okay, straightforward definition won't be a part of it, but you should prepare obviously, but focus on the reactions. If they'll give you reaction, they will ask what kind of reaction is this and how will you balance these kind of reactions. Majorly that type of question comes from this chapter. Okay, next reaction is oxidation. What is oxidation? Oxidation means addition of oxygen or removal of hydrogen. If any of these things is happening, we call it oxidation, right? One more thing is there, loss of electrons is oxidation. Okay, loss of electrons is oxidation. Reduction means addition of hydrogen or removal of oxygen, right? Simple addition of oxygen here, addition of hydrogen, both are reduction. That is oxidation and this is reduction. And if in a reaction both oxidation and reduction are happening simultaneously, it is called a redox reaction. Okay. One more thing, oxidizing agent and reducing agent. Oxidizing agent and reducing agent. So oxidizing agent is an agent that oxidizes others and reduces itself. That oxidizes others and reduces itself. Okay. Good morning, Divyanshu. Good morning, Suhani. Hello, Abhay. So oxidizing agent is an agent or a substance that oxidizes others and reduces itself. If it is oxidizing others, that means it is okay, maybe it will go a little tricky, but try to understand it. Oxidation means loss of electron. If something is getting oxidized, that means some agent is there that is removing its electrons, right? Loss of electrons is happening, right? That is oxidizing agent. So who will accept those electrons? That oxidizing agent itself, and itself it will get reduced. What is reduction? Reduction means gain of electrons. Okay. Let me just repeat it one more time. So an oxidizing agent oxidizes others and reduces itself. Oxidation means loss of electrons. So that means it accepts electrons from that species and get reduced itself. Okay. So it gain electrons. What it does, it gain electrons and make the other substance lose electrons. Okay. That is oxidizing agent. So it provides oxygen and it gains electron. That is an oxidizing agent. For reducing agent, the story is opposite. It provides hydrogen, right? Reducing agent provides hydrogen, or what does reducing agent do? They reduces others and oxidize themselves. So that means they reduces others, that means they give electrons to others, and if they are giving electrons, that means they are losing electrons, right? So they give electrons, give/donate electrons. That is a reducing agent. Okay, I hope it is clear. Is it clear to you all? Okay, if it is clear, so let's move on to the next one, which is redox reaction. These kind of redox reaction we see in our everyday life. For example, corrosion is one. Okay, good. See, if some high level question, if you think that is going to come, that will come like this only. From that reducing agent, oxidizing agent, oxidation, reduction, they will confuse you. Question from this has come before also, and from this year if they are inducing competency based questions, then you should be prepared regarding these. Okay, if you know the concept, you can answer it. Yes, there will be questions, don't worry, I have compiled questions also. Okay, now see, there are two phenomena that are related to redox reaction in our everyday life, right? Redox means where reduction and oxidation is happening simultaneously. For example, corrosion. Corrosion is a phenomena which means deterioration of metal. So in corrosion, what is happening, my dear students? Corrosion means metal. You have a metal, right? Let's say you have iron. It is in its free state. Now this gets converted into its either oxide, sulfide or hydroxide. Oxide, sulfide or hydroxide. That is called corrosion. That is called corrosion. What is corrosion? Deterioration of metal by the action of air, moisture, and the metal gets converted into its respective oxide, hydroxide or sulfide. Okay, that is corrosion. Okay, now how do you prevent corrosion? By applying paint. You apply a layer of paint so that the metal does not get corroded. Applying oil or grease, again it cuts off the oxygen supply. You need air, and what do you need? You need air and moisture for corrosion to happen, right? Galvanization. What is galvanization? It means applying a coating of zinc on iron articles so that it does not get corroded, right? Coating with epoxy, acrylic. One more thing is there. Let me just clear it. Anodizing. So anodizing is done for aluminum articles. What you do actually, you have aluminum article and there you apply basically you do electrolysis, you pass electricity through a solution, make cathode and anode, right? And you you form thick layers of aluminum oxide. Thick layers of aluminum oxide on any aluminum article to prevent it from getting corroded, right? That is anodizing. Yes, destruction of layer of metal, that is corrosion, correct. Okay, so aluminum coating aluminum articles with a thick layer of aluminum oxide, that is called anodizing. Okay, next process is rancidity. What is rancidity? It is the oxidation, slow oxidation or oxidation of oily and fatty foods. Okay, when you have oily and fatty foods like chips, oil, ghee and any stuff you made out of ghee or oil, okay, what happens? They slowly oxidize in presence of air. We have oxygen, right? And if you leave them out, they will get oxidized. That's why it is called oxidative rancidity, right? And it changes their smell, it changes their taste, right? They are not safe to consume anymore. That is called rancidity. How do you prevent rancidity? By adding antioxidants. These antioxidants again remove the oxygen. Antioxidants, right? They remove the oxygen and prevent the rancidity. Then also you flush with nitrogen, removing the oxygen with nitrogen, right? That is also one way. Using airtight containers. When you use airtight containers, again you cut off the oxygen supply. As long as oxygen is not there, there will not be any rancidity. Next, keeping in refrigerator. When you keep in refrigerator, you are decreasing the temperature so that the bacteria won't act on the substance. Okay, and that's how you prevent rancidity. So we can say acid and base. There are few characteristics actually, Alex, right? So the characteristics are an acid gives hydrogen ions, a base gives OH negative ion. Plus you can differentiate on the basis of physical and chemical properties. Basically you can do physical only. So in physical properties you can differentiate on the basis of the type of ions they are giving. Acid gives hydrogen ions, bases give hydroxide ions, right? Acids are sour in taste and bases are bitter in taste. Okay, acids turn blue litmus red, bases turn red litmus blue. Then you have indicators also, right? Phenolphthalein indicator, methyl orange. We'll deal with them one by one. NO3. Hi Shazia. NO3 what? Anodizing or displacement, it is an oxidation reaction, no? It is an oxidation reaction. Aluminum is getting converted into its oxide in presence of oxygen, right? It is oxidation. Hi Vijaya. Okay, good morning Ashleisha. But NO3 nitrate with reaction with H2O, yes. H2OH. Hi Shazia. Nitrate as in, what is your doubt? Nitrate, nitric acid are you asking? Nitric acid or nitrate, what are you asking? Yes, there are questions regarding PYQs, don't worry. So anodizing and galvanization. Anodizing means you apply thick layer of oxygen, thick oxide layer. We deposit. What do? We deposit thick layer of oxide on any aluminum article. That is anodizing. A anodizing, A aluminum, right? That is anodizing. Okay. Simple. They won't be asking you the process, trust me. If anything, the definition is necessary in this one, that what is there in anodizing, what are we depositing? We are depositing a thick oxide layer. But if you think about it, right, oxidation is called corrosion, no? But to protect it, because that oxide layer is thick and it is dense, it is thick and dense, that's why it protects from the further contact with oxygen. That is thermite. I'll explain, don't worry. Next is galvanization. In galvanization, you coat any iron article. Galvanization is mainly done for iron articles. So if you have any iron article, you coat it with a layer of zinc. Why? Because zinc is more reactive than iron. We know that from the reactivity series, right? Now, as zinc is more reactive than iron, what will happen? When air and moisture is there, what will happen? Zinc will get corroded and your inside iron will be safe. Zinc will get corroded, your inside iron will be safe. And that is galvanization. That is galvanization. Potassium nitrate, good question. Hey, hold on a minute. Potassium nitrate. Now you see, my dear students, potassium nitrate is a salt. What it is? It is a salt of potassium hydroxide and nitric acid. Both are what? Strong base and strong acid. That means it is a neutral salt. That means it is a neutral salt. It is a salt. Alex? It is a salt. It is a salt formed by the combination of a strong base and strong acid, right? So it will be a neutral salt. You know from the name, no? How is it formed? You know it from the name. You write the formula there, you can see it is made up of potassium and nitrate, right? Potassium came from potassium hydroxide. Nitrate came from nitric acid, right? I hope it is clear. It is a neutral salt. Let's start with our next chapter, acid, bases and salt. Give another example of, okay, we'll do examples in this one, don't worry. Okay, let me do some examples here only. If you have Now see, this is a strong base, this is a strong acid, we know that, right? This is a strong base, this is a strong acid. What will happen if you combine an acid and base? That is a neutralization reaction. We will get salt and water, right? We will get salt and water. Again, listen, it has OH, right? OH, it is giving OH negative. When you dissolve a base in water, it will give hydroxide ion. It will give hydroxide ion. Clear? That means it is a base. Now here HCl is an acid. Why? Because if you dissolve it in water, it will give hydrogen ion. It will give hydrogen ion, right? Somewhere you will see hydronium. Why? Because H positive combined with water and we will get H3O positive. Okay, either is fine, don't worry. Now see, a strong base and strong acid combined, we get a salt and water. Now this salt will be neutral. Why? Because the strength of acid and base is equal. The strength of acid and base is equal. If either one of these is strong, what will happen? That will predominate in salt. For example, here, ammonium hydroxide, it is a very weak base. And if you combine it with a strong acid, this is what you will get, NH4Cl and OH from here and H from here, because acids give H positive, bases give OH negative, and when you combine H positive with OH negative, you will get what? Water, right? Okay, now see, as the acid was strong and the base was weak, what will happen? This will be an acidic salt. This will be an acidic salt. Clear? Why? Because the acid part is strong here. That's why the salt will be acidic in nature. Alex, I hope your doubt is clear now. That comes from your 9th class. You remember that chart from your 9th standard book? There was a chart, no? Ions, charges, something like that. I'll show you later. There was a chart from your 9th class book. I'll show you, don't worry. From there you identify cation and anion. Anion are negatively charged, cations are positively charged. That was 9th class basic. You don't remember it? Okay, let's start with acids and bases. What are acids? Acids are sour in taste. They turn blue litmus red. They give hydrogen ion. They conduct electricity in aqueous solution. Why? Because they have H positive ion. Due to these hydrogen ions, they conduct electricity. They have a pH less than 7. Break down the compound, because majorly the type of compound that will be given to you, they will be, for example here C, break down it into compound, the respective ions, CH3COOH, what could be there, we know it may be made up of, because it is an acid, it will give H positive, so this H will be coming from here only, right, OH, so CH3COO negative and H positive. Clear? This is how you break it up. H2CO3, it is made up of what? It is a carbonic acid, right? So you can break it as H positive and 2H positive, two hydrogens are there, 2H positive, and CO3, 2 negative. You should remember these complex polyatomic ions from your 9th class book, right? That's how you break it up. You see, this is H2CO3, 2H positive and CO3, 2 negative. Similarly here, you have Na positive and CO3, 2 negative. How many Na positive? 2 Na positive, Na2. NH4OH, again you break it down as NH4 positive, because ammonium gets a positive charge and OH is always negative, OH negative. That's how you break it up. You guys teach me how to be a teacher, no? That's so nice. I hope your doubt is clear. Okay, now let's see. We have two type of acids, strong acids and weak acids. Strong acid dissociate completely in aqueous solution. They will dissociate as H positive. They will dissociate immediately to give H positive ions, right? Then weak acids, they dissociate partially or incompletely. That means if you give 100 molecule, they will dissociate only 5 molecule will dissociate, and rest 95 will be as it is. Okay. Next is bases. Bases are bitter in taste. They turn red litmus blue. They give hydroxide ions in aqueous solution, and they have a pH greater than 7. Strong bases and weak bases. Strong bases are those bases which dissociate completely in aqueous solution. So when you dissolve them in aqueous solution, they will dissociate as Na positive and OH negative. Then you have weak bases. Weak bases dissociate partially or incompletely in aqueous solution. For example, NH4OH, Na2CO3. Okay, strong, if 100 molecules of strong acids or strong base are there, all the 100 will dissociate, right? But if you have 100 molecules of a weak acid or a weak base, only 3, 4, 5, only 4 to 5 will dissociate. Rest will be same in the undissociated form. Okay. Now, what are the chemical properties of acids? They react with metals. When acids react with metals, we get salt, and remember, hydrogen gas is released. And what happens when acids react with metal carbonates or metal bicarbonates? So you see, in carbonate or bicarbonate, hydrogen carbonate, we have a carbonate. That means carbon dioxide gas will be there. So when acid react with metal carbonate or metal hydrogen carbonate, what will happen? We will get salt plus carbon dioxide plus water. Okay, that happens with both metal carbonate and metal bicarbonate. Now, how do acids react with metal oxides? Now, metal oxides are basic in nature. Why are they basic in nature? Because when you combine a metal oxide, let's say calcium oxide here, if you combine a metal oxide with water, we will get a base. That's why metal oxides are basic in nature. This is considered basic in nature. Similarly, if you have an acid, CO2 let's say, or let's say SO2 you have, no, CO2, we will do SO2. If you have a non-metallic oxide, this is non-metallic oxide, right? And if you combine it with water, what will you get? You will get an acid. You will get an acid. That's why non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. Okay. Now, if base and acid reacts, with acid and base reacts, because metal oxide are basic in nature, if they react, what we will get? Salt and water. We will get salt and water. Okay. Now, what are the chemical properties of bases? What reactions are shown by bases? So bases also react with metals, but not all metals, because bases and metals have the same nature. Metals are also basic in nature, we know that, right? Because if you combine metal with oxygen, you get metal oxide, and metal oxides are basic in nature, right? In general, metals are basic in nature. Okay, but there are some exceptions. You have 3 actually: zinc, aluminum and lead. These 3 metals are there. These 3 metals are there which are amphoteric in nature. Which are amphoteric in nature. Amphoteric means they react with both acids and bases. So when base react with these metals, zinc, aluminum, iron and lead, okay, what will happen? We will get salt and hydrogen gas is released. We will get salt and hydrogen gas is released, right? Remember the gas, it is hydrogen gas. Okay. Why? Because here we have a base and this metal is amphoteric. That means one time it will act as a base, one time it will act as an acid. Here if base is there, these metal will act as an acid. If you have a base, then these metals will act as an acid, and acid-base reaction will give salt and water. We know that, right? Now, how do bases react with non-metallic oxides? Again, non-metallic oxides are acidic in nature, and when acid and base react, we get salt and water. We get salt and water. Then how do bases react with acids? That's a neutralization reaction. We'll study that in salt. Acid base gives salt and water. Okay. pH scale, this is a scale which tells us about the concentration of hydrogen ions. Okay, pH scale tells us about the concentration of hydrogen ions. It is equal to negative logarithm of H positive. Okay, it tells us about the concentration of hydrogen ions. If hydrogen ion concentration is more, if hydrogen ion concentration is high, pH will go to the acidic side. pH will go below 7. If the hydrogen ion concentration is less, pH will go above 7. I hope it is clear. pH, if hydrogen ion concentration is more, the pH will go below 7. If hydrogen ion concentration is less, the pH will go above 7. Okay, that's why above 7 you have bases and below 7 you have acids, because acids have high H positive concentration and bases have high OH negative concentration. Okay, now the indicators. You have 4 indicators. Litmus paper in acidic medium, blue litmus turns red, and in basic medium, red litmus turns blue. Then you have phenolphthalein. In phenolphthalein, my dear students, it is colorless, but in acidic medium it is colorless. In basic medium it is pink colored. Okay, methyl orange, again methyl orange turns red in acidic medium and yellow in basic medium. Okay, so red in acidic medium and yellow in basic medium. Then olfactory indicator. And what happens when methyl orange is just orange in color? What pH is that? When methyl orange is just orange in color, that means the pH is neutral. Or 7. Okay, at neutral pH, methyl orange is orange in color, or else it is red in color. For with acids it is red in color, with bases it is yellow in color. Okay, now last olfactory indicators. You have 2 olfactory indicators, onion and vanilla extract. So onion, my dear students, question types. Okay, what question you are asking? Question types. What type of question will come? Are you asking that? Olfactory indicators. We have 2, onion and vanilla extract. Both retain their odor in acidic medium. If the medium is acidic, or if you have an acid, they will retain their odor. Their odor won't be lost. They will retain their smell. But if you place them with bases, or if there is a basic medium, they will lose their odor. Okay, that is for olfactory indicators. Now salts, again they are the neutralization product of acids and bases. Between acids and bases, 3 types are there: acidic salt, basic salt and neutral salt. Acidic salt, basic salt and neutral salt. So acidic salt is formed when you have a strong acid and a weak base. Basic salt is formed when you have a strong base and weak acid. And neutral salt is formed when you have a strong acid and strong base. If we have weak acid and weak base, what type of salt we will get? Weak acid and weak base. Now there are some common salts out there. What are those common? Some salt we have actually in this chapter. Let's discuss them one by one. The first is sodium chloride. How do you synthesize sodium chloride? Neutralization reaction, right? But that is not entirely true. How we actually synthesize it? By using from the seawater, right? You extract it from seawater, have lots of heaps of sodium chloride. So what do? We take seawater, or from seabeds you just you have salt beds. So from salt beds you extract it, evaporate the water, then you will have NaCl, purify and everything, and add iodine to it, and that's how you use it in our for our daily purposes, right? Because if we use this, we will die. Why? Because it is a strong acid and a strong base. Both are corrosive, and obviously you can't. Wait, we'll go to the question. Why? What's the hurry? I'm just revising it. I'm warming you up so that you know how to answer those questions, okay? Hi Doraemon. I miss Doraemon too. Okay. Now next salt is caustic soda. What is caustic soda? It is sodium hydroxide. Okay. How do you synthesize it? By the process called chlor-alkali process. It is synthesized by process called chlor-alkali process. Now what is chlor-alkali process? That means the chlor-alkali process is when electricity is passed through an aqueous solution of sodium chloride. So we have a brine. What is brine? Brine is an aqueous solution of sodium chloride. So when we pass electricity through it, it decomposes to form sodium hydroxide. Chlorine gas and hydrogen gas is also released. This is released at anode, and hydrogen gas is released at cathode. That is your caustic soda. Next salt is calcium oxychloride, okay, or bleaching powder. So calcium oxychloride or bleaching powder, my dear students, this is the formula CaOCl twice. This is the formula of bleaching powder. Now how is bleaching powder formed? It is formed by the action of chlorine on dry slaked lime water. Dry slaked lime, actually you have the slaked lime, you dry it and you pass chlorine gas through it, and you get calcium oxychloride plus water. That is a reaction, okay. Then what is the bleaching agent in case of, what is the bleaching agent in case of calcium oxychloride? The bleaching agent is chlorine. The bleaching agent is chlorine. And how do you activate the bleaching agent? By adding dilute acid, okay. That is bleaching powder. Next is baking soda. Baking soda is sodium hydrogen carbonate. We synthesize it by this process. We take a brine, again aqueous solution of sodium chloride, and we put ammonia to that solution and pass carbon dioxide gas. And what we will get? We will get sodium hydrogen carbonate or baking soda plus ammonium chloride, okay. Now the next step, this whole reaction is a part of this process called Solvay process. Solvay process, okay. The first step is this. In the second step, you take this sodium hydrogen carbonate and you heat it. If you heat sodium hydrogen carbonate, you will get sodium carbonate, okay. And if you add 10 water of crystallization to this sodium carbonate, we will get washing soda. I hope it is visible. This is washing soda. These three steps makes the whole Solvay process. Okay. Now what is baking powder? Baking powder, some applications are there. Baking soda is used in kitchens also to make pakoras, right? And it is also used in soda acid fire extinguishers. So soda means baking soda, sodium hydrogen carbonate, and acid means sulfuric acid normally we take. Why? Because when acid and base combines, when it is a hydrogen carbonate, carbon dioxide gas will be released, and because large amount of carbon dioxide gas is released, that's why it is used as a fire extinguisher, okay. Next is baking powder. Baking powder is a mixture of baking soda and an edible acid. Normally the acid is tartaric acid. So what is the difference between baking soda and baking powder? Baking soda is sodium hydrogen carbonate. Baking powder is a mixture of baking soda and tartaric acid. That is baking powder. Okay, now see, it is used, both are used for baking purposes, but when you don't want the bitterness, baking soda has a bitterness. Why? Because it is basic and bases are bitter, so it has this bitterness. When you don't want the bitterness, you use baking powder. So mostly we use baking powder, okay, but for fluffing something out, we use baking soda. Next is washing soda. Again, we have synthesized washing soda. This is the last step of it. So sodium carbonate decahydrate. It has 10 water of crystallization. It is used to remove the permanent hardness of water, and it is used as a cleansing agent. Okay, which salt is used as a disinfectant? Answer me. Which salt is used? We discussed till now which salt will be used as a disinfectant to disinfect water. Yes, whatever your doubt is, do tell me. Now, last one is plaster of Paris. The last one is plaster of Paris. Okay, so in plaster of Paris, this is the formula: calcium sulfate dot half H2O, calcium sulfate hemihydrate. If you take gypsum, what is gypsum? This is gypsum. Calcium sulfate dot 2H2O. Gypsum is calcium sulfate dot 2H2O. Baking powder. No, they will not. They will ask the formula of baking powder, as in what is baking powder made up of. For straightforward question, baking powder is made up of what? Not actually straightforward question. They will ask it in a case-based question, as in you have synthesized baking soda and then we added an acid to it. What is the name of the compound form? So then you will say that that is baking powder. So baking powder, they won't ask the formula or the reaction. What they will ask, what it is its composition. If you are aware of the composition, you can answer the question. That baking soda is nothing. That baking soda is nothing but mixture of, you write just mixture of baking soda plus any acid. You can write edible acid, so we write tartaric acid. Okay, this is the constituent of baking powder. Okay, they won't ask the reaction, don't worry. The question will be framed in such a way to test your knowledge. Okay, and if we heat gypsum up to 100 degrees Celsius, if we heat gypsum up to 100 degrees Celsius, it loses 3.5 water of crystallization, and what do we get? We get calcium sulfate dot half H2O, or plaster of Paris, right? It is used to support the fractured bones. It is used for making toys, material surfaces smooth, right? Any dolls you want, any statue, they are made up of plaster of Paris. Okay. Yes, what are your questions? I'm giving you 2 minutes to ask me the questions, and we'll start the next chapter, which is metals and non-metals. Okay. Will they ask the meaning of water of crystallization? Do you not know the meaning of water of crystallization? So water of crystallization, I don't think they'll ask the meaning exactly. What they will ask, as the questions are getting better, so they'll ask the water of crystallization in different type of salt. For example, they'll ask how many water of crystallization are in gypsum. Okay, tell me how many water of crystallization are there in washing soda, or how many water of crystallization are in iron sulfate or in copper sulfate. Like this they will ask, MCQs type. Okay, any other doubt? You're just telling 2. Gypsum has 2. Washing soda has how many? 10, right? And iron sulfate has 7, and gypsum has, copper sulfate has 5. 7. It has 7 water of crystallization. There was one more. Just let me check. What was the name? I've read one more salt name that was like came once in CBSE. What was that? Oh, that is called. There is one more name for this. We call it blue vitriol. Blue vitriol. Yeah, this is called blue vitriol. That is the name of copper sulfate. So instead of copper sulfate, they can give how many water crystallization are there in blue vitriol. Where are the questions? Oh my god, heart attack. Okay. Any doubt you have? Hello? Yes, it does have 10 watt of crystallization. You've no ma'am, what? Okay, so I think you don't have, I've paused for your questions only because you were saying ma'am we have questions, ma'am we have questions, but now you don't. Okay, let's remove it. You don't have, the time is over, but just remember these things, that water of crystallization, they will ask how many water of crystallization are there, or they'll give which among the following salt has 5 water of crystallization, and they'll give you these salts, 4 salts. Then you know that copper sulfate have, but instead of copper sulfate they will write blue vitriol. Then you will get confused. I don't know. Then now, you know now that blue vitriol is copper sulfate and it has 5 water of crystallization. Okay, is it clear? Now let's start with physical properties of metals. What are the physical properties of metals? They are lustrous, they are hard, they are good conductor of heat and electricity, they produce a sound, you can draw them into sheets, which is malleable, you can beat them into sheets, which is malleable, you can draw them into wires, which is ductile. Okay. There are some exceptions to it. What are the exceptions? Sodium and potassium. They are metals, but they are extremely soft. You can cut them with a knife. Mercury is a metal, but it is a liquid at room temperature, right? Gallium, cesium, they are metals, but they have really low melting point. You can melt them on the palm of your hand. Then similarly for non-metals, the properties are they are soft, they are brittle. Brittle means you can make if you hit them you can make powder, right? They are very soft, right? And if they can be broken down with a hammer or something. Then they are dull, bad conductor of heat and electricity, right? This is not that important. Iodine is lustrous. Exceptions, these are the exceptions for non-metals. Iodine is a non-metal, but it is highly lustrous. Diamond, which is made up of carbon, which is a non-metal, but it is really hard and has high melting and boiling point, one of the hardest substances on our planet. Then graphite, which is also made up of carbon, it is extremely soft, yeah, but it is a good conductor of electricity. That is the exception. It is a good conductor of electricity. Now, chemical properties of metals. Before we do the chemical properties, I need you to do one thing, which is the reactivity series. Yep, the reactivity series, which is very important. Okay, so please stop calling me a careless zebra. Instead, try learning how copper saves gold, platinum. This is the decreasing order of reactivity. Decreasing order of reactivity means that if you go down this series, the reactivity of metals will decrease. That means the metal lying above it, for example in magnesium and zinc, as magnesium is lying above zinc in the reactivity series, that means magnesium is more reactive than zinc, right? Similarly, as aluminum is lying above tin in the reactivity series, that means aluminum is more reactive than tin. Why does it matter? It will matter for the displacement reactions, because we know a more reactive metal will displace a less reactive metal from its compound. Okay, so if they are lying above the reactivity series, they are more reactive, they will displace the other metal from its compound. That is displacement reaction. Now the first reaction is metals react with oxygen, we get metallic oxide. Now these metallic oxide can either be basic in nature or can be amphoteric, right? Amphoteric, you don't have to worry, three are there: zinc, aluminum and lead. Remember these three are your amphoteric. These metals are amphoteric in nature. Rest all are basic. So basic or amphoteric, that is metals, right? These are all the oxides. Why have we called them basic? Why? Again, if we add water to any metallic oxide, any metal oxide, we will get a base. Now how do metals react with water? So metal reacts with cold water, hot water, water vapors. Some metals which are very reactive, highly reactive, they will react with cold water. Sodium, potassium, and we will get metal hydroxide plus hydrogen gas, and lots of heat is also released vigorously. These react vigorously. Sodium reacts vigorously with water. Potassium reacts violently with water. Make whatever of it is, they actually react in such way that you will get a bomb explosion, a little explosion there. So why? Because lots of heat is released, and this heat, when comes in contact with hydrogen, it catches fire instantly. Then some metals, they also react with cold water, for example calcium, but they do not react vigorously. Why? Because they are less reactive. Right? Sodium, potassium, you have what? Please stop calling me. So after potassium, sodium, we get calcium. So calcium is a little less reactive, right? And if it is little less reactive, then again we will get metal hydroxide and hydrogen gas, but the hydrogen gas will not catch fire. Why? Because this reaction is a little less exothermic. Why? And one more thing, the calcium starts floating on air. Why? Because these hydrogen gas bubbles, they surround the calcium metal and make it float. So they will start floating on water. Okay. Similarly for magnesium, as magnesium is a little lesser reactive, it is after calcium, no? So it is less reactive than calcium, so it will react with hot water. What are we doing actually here? So as if any metal, any element is more reactive, they will react in any condition. Normal room temperature also they will react. Okay, but if they are less reactive and you want them to react, what we will do? We increase the temperature. So here, as from cold water to hot water, we increase the temperature, and because of that the reaction will happen. We will get metal hydroxide, and again hydrogen gas is evolved, and this hydrogen gas make the magnesium float on the surface of water. Okay. Next is some metals react with water vapors. Now water vapors have a temperature greater than 100 degrees Celsius. So you are increasing temperature above 100 degrees Celsius. Aluminum, zinc, iron, right? And in this case you will get metal oxide. Why metal oxide? Because at temperature greater than 100 degrees Celsius, only oxides are stable. Metal oxides are stable. Okay. Now you have metals like lead, copper, silver, gold. They do not react with hot water, cold water, water vapors. Okay. Now the reaction of metal with dilute acids. So for example, if you have sulfuric acid or hydrochloric acid, all metals react in same way. We have read in acid, bases and salt. What? Metal plus acid. Salt gives salt plus hydrogen gas, salt and hydrogen gas, right? This is the reaction. Simple, right? But depending on the acid, it changes. Depending on the acid, the product changes. For example, with sulfuric acid and hydrochloric acid, the reaction is this, but with nitric acid, the reaction is slightly different. So any metal plus nitric acid what will happen? We will get again salt plus water. Salt plus water. Okay, why water, not hydrogen? Because nitric acid is a strong oxidizing agent. Nitric acid is a strong oxidizing agent, and oxidizing agent, what will they do? They will oxidize this hydrogen to water. They will oxidize this hydrogen to water, right? And that's why we do not get hydrogen gas. Okay, what we get? We get water. For magnesium and manganese, the story is different, as these are the only exceptions that react with dilute nitric acid and give salt and hydrogen. Salt and hydrogen. Okay, other metals do not evolve hydrogen gas when reacting with nitric acid. Then you have aqua regia. What is aqua regia? It is 1:3 mixture of concentrated nitric acid and HCl. It is 1:3 mixture of concentrated nitric acid and HCl, which is 1 part concentrated nitric acid, 3 part concentrated HCl. The purpose of making it is to dissolve silver, gold, platinum. The purpose of making it is to simply dissolve silver, gold, platinum. Okay, then displacement reaction of metal, in which a more reactive metal displaces a less reactive metal from its compound. Zinc is more reactive than iron. From the reactivity series, it will displace iron from its compound, and we will get zinc sulfate plus iron. One more reaction is there, thermite reaction. Let me use black. Okay, thermite reaction. It is a very important reaction for this reaction is used for joining the broken railway tracks. This is the reaction. Aluminum combines with iron oxide and we get aluminum oxide plus iron. Right? Now this aluminum solid, iron oxide was gas. Hold on a second. Plus heat. Lots of heat is also released. Reaction is highly exothermic. Reaction is highly exothermic. So much heat is released that this iron is molten, liquid. This iron we get is molten. Okay, now the reaction is so highly exothermic, so much heat is released that this melts the iron. Okay, it was supposed to be solid, but it comes melted, and this is used to join the broken railway tracks, You don't have any doubts, I think. Okay. Physics. Okay, then you have non-metals. Non-metals also show reactions with oxygen. They react with oxygen, we get non-metal oxide. Non-metallic oxides are acidic in nature, because when you combine them with water, we get acid. Non-metals do not react with water or acid. Why? Because all these three have same nature. Non-metals are also acidic in nature, right? Water also behaves as an acid. Both needs electron. All of these needs electrons. Non-metals are electron acceptors. Water or acid also needs electrons, right? That's why they do not react with. That's why non-metals do not react with water or acids. Then non-metallic oxides are of two types: acidic oxides and neutral oxides. Acidic oxides mean, okay, oxidizing agents give electron or gain electron. Oxidizing agents actually gain electron. They gain electron. I told you, no? Oxidizing agent gain electron. Reducing agent lose electron. Okay. Non-metallic oxide can be acidic or can be neutral. Acidic, we have carbon dioxide, nitrogen dioxide, sulfur dioxide, right? And neutral, we have carbon monoxide, nitrogen oxide and water. These are our neutral oxides. Okay, they are neither acidic nor basic. Next, when metals and non-metals react, we get Ionic compounds. What are ionic compounds? They are formed by transfer of electrons. Sodium has one extra electron. If it loses it, it completes its octet. So it loses that electron, and this electron is accepted by chlorine because it also needs one electron to complete its octet, and we get Cl negative. This is a cation and this is an anion, and there is a bond, there is a force of attraction between these cations and anions. Okay, this force is called the ionic bond. This force is called the ionic bond. What are the properties of ionic bond? Ionic bond. So ionic compounds are those compounds that have ionic bond in them. Okay, so they are brittle solids. They have high melting boiling point. They are soluble in polar solvents. Why? Because they have charges, right? They are made up of cations and anions. Polar means they have charges. Polar also means charges. Polar also means charges, right? So that's why they are only soluble in polar solvents. Ionic compounds are only soluble in polar solvents because they have the same nature. Both have positive, negative. Both have these anions, cations, right? Okay, electrical conductivity, they are good conductor of electricity in molten or aqueous state, not in normal, because in solid state they do not have free ions, but in case of when they are melted or they are present in water, they have ions, and due to these ions they will conduct electricity. Metals, minerals and ores, we know what are minerals. They exist in naturally occurring inorganic substance that exist on our earth crust. Ores are those minerals from which any metal can be extracted financially, conveniently, economically, right? You can extract any metal, right? Then you have enrichment of ore. Enrichment means you remove the gangue particles. What is gangue? All these dust, rocky particles, any impurities that are present in your ore, they are called gangue. And removal of gangue particles is called enrichment of ore. Now, how do you separate? This is the activity series: high reactivity, moderate reactivity, low reactivity, right? Only these three categories we deal with. Least reactive, they exist in their free state only, right? So if you extract gold or platinum, they will come in their free state only from any mine or anywhere you extract them, right? Because they are very low reactive, not reactive actually at all. They will exist in their native state only. They will exist as gold only and platinum only, right? No compound formation. Now, this is the way you separate them. If metals are of high reactivity, we use electrolysis, then you get pure metal. If they are of medium reactivity, they will either exist as carbonate or sulfide ore. If they are present as carbonate ore, we do calcination. Calcination means heating in absence of oxygen, absence of air, right? And that after you get oxide of metal. Roasting means heating in excess air. That is roasting. For sulfide ores, we do roasting. For carbonate ore, we do calcination, and that's how we get oxide of metal. And then again we do reduction of that, and that's how we get our metal. Then you pure it in something. Metals of low reactivity, they exist as their sulfide ore. Again, for sulfide ore, you always use roasting, and after roasting get pure your metal, then you do metal refining, right? Okay, before we begin that, I want some space somewhere. Okay, I'll do here only. We have techniques called electrolytic, reduction and electrolytic refining. So the basic difference is it is used to extract metals. It is used to extract metals from their molten chlorides, from their chlorides. And this technique is used to purify metal, purify metals. So you already have the metal and you are just purifying it. From chlorides, what kind of metal? Sodium, potassium, magnesium, calcium, and you purify copper, zinc, silver, these metals you purify here. Okay, so metals of high reactivity, you do electrolytic reduction to extract the metals from their chlorides, and electrolytic refining means you are using it for refining these metals, purifying these metals, and these both processes are done using electricity. Using electricity. Here you have again anode and cathode, and you have an electrolyte also. So anode is made up of impure metal, the metal that you want to pure, impure metal. Cathode is made up of pure metal. Electrolyte is a soluble salt solution of that metal. Now what happens when you pass electricity? The anode breaks down, the impure metal breaks down, dissolve in the electrolyte, in the soluble salt solution of that metal, and from the salt solution, from the electrolyte, an equal amount of that metal deposit on the cathode. So with anode disappear with time and cathode gets thick with the pure metal depositing on it. In here you have anode and cathode both made up of same material. Anode and cathode both made up of same material, which is graphite. Any inert material. We use graphite sometimes, but any inert material is used. Okay, after that what happens, you have the solution. The solution is of molten chloride. So if you have sodium chloride, if you have potassium chloride, you just melt it. The molten chloride solution is there, and when you pass electricity, this solution, from this solution, something will move to the anode, something will move to the cathode. And what is it? At anode, chlorine gas is deposited at anode, and at cathode, sodium metal is deposited at cathode. Okay, this is the reaction. So you have a solution. In that solution you have molten chloride, right? And when you pass electricity, you have two rods dipped in that solution, anode and cathode, both made up of same material. When you pass electricity through that solution, what will happen? Chlorine gas will deposit on the anode and sodium will deposit on the cathode, and that's how you get your sodium metal. Because this method is used to extract metal. This method is used to extract metal like sodium, potassium, magnesium. Okay, is it clear? So many comments, but they're all just talking. Hi Pavni. Is it clear? Say your doubt. Yes, what doubt you have? I will finish carbon and its compounds, then I'll give you break, and then we'll start with the questions. Let me, okay. Hi Renu. How to remember reactions? In the live also, there's an attached PDF in the description of this live. You can download there, or there are around 40 reactions. Okay, and remember those reactions. And how do you memorize them? You memorize them by writing them down, because if you just read it or learn it, you won't remember anything. What you need is, you need to actually write them down using your own hands, and you can see the product formation. If you can make the product by yourself, then you'll be able to do any reaction. Which chapter? This one. Okay, we'll talk. I'm detailing only. Yep. Oxides of top reactivity series, why can't we use carbon? Good question, Ayush. But see, you see at the reactivity top of the reactivity series, you have sodium, potassium, magnesium. And if given a choice between carbon and oxygen, they will react with oxygen. Why? Because they have more affinity for oxygen. Because they have more affinity or more interest for oxygen. Okay? They will not react with carbon. Have you seen any carbon compound with sodium, potassium, magnesium? No, na? You have seen magnesium oxide, potassium oxide, sodium oxide, right? Why? Because these metals react strongly with oxygen rather than carbon. So they do not react. If they are already in their oxide form, they will not react with carbon. So that's why we do not use carbon, because these metals have high affinity. You can use the word affinity, which means or they react strongly with oxygen. If you don't remember the word affinity, say these metals react strongly with oxygen and thus they do not react with carbon, and we cannot, that's why we cannot use carbon to reduce them. Okay, let's start this chapter, carbon and its compounds. So again, carbon, it has atomic number 6, right? Number of protons 6, number of neutrons 6, number of electrons is also 6. The mass number is 12 for carbon. Okay, it forms covalent bond. Why it forms covalent bond? Because it cannot lose 4 electrons. Why? Because losing 4 electrons, it needs very high energy, and that is not feasible for it. That is not energetically feasible. That's why carbon does not lose 4 electrons. It also does not gain 4 electrons to complete its octet, because what is the electronic configuration? 2, 4, right? Because if it gains 4 electrons, that means it will have 6 protons trying to balance 10 electrons. That is not something, that is not an ideal situation. These electrons will repulse in between them. There will be a lot of repulsion among them, and also the protons cannot attract the electrons. Okay, and that's why what they do not lose 4 electrons, they do not gain 4 electrons. What they do, they share these 4 electrons and form covalent bond. Single covalent bond, double covalent bond, triple covalent bond, right? Single means when 1 electron is getting shared, and when 2 electrons are getting shared, we get a double covalent bond. If 3 electrons are getting shared, we get triple covalent bond. Yes, carbon make covalent bond because both situation, losing 4 electrons and making a duplet, or gaining 4 electrons and making an octet, is not ideal for it. Okay, both process are highly energetically unfavorable. Lots of energy is required. Okay, that's why it does not form covalent bond. That's why it does not form anion or cation, and it forms covalent bond because it wants to complete its octet. Carbon wants to complete its octet. So what it does, it shares its 4 electron with other atoms, right? And form covalent bond. Covalent bond have low melting boiling point. Why? Because they are very weak bond, poor conductor of electricity, because there is no electrons. They are just sharing electrons. There is no cation or anion there. They are insoluble in water because they are non-polar. They are non-polar, they do not have any charge, so they cannot solubilize in water. They are soluble in organic solvents like them. Then you have 3 allotropes of carbon. Allotropes have different structural arrangement, but same, they are made up of same element but have different structural arrangement, right? And they show different physical properties. They have same chemical properties but show different physical properties. Diamond, graphite, fullerenes, right? Diamond is a ionic bond is formed by transfer of electrons, formed by complete transfer of electrons between 2 atoms. It is stronger than covalent bond. Actually, metal with non-metal, if you have metal and you have a non-metal, metal and non-metal will form ionic bond. And non-metal and non-metal will form covalent bond. Clear? Again, diamond is extremely hard because it has 3D network in which all the carbon atom is bonded to 4 other carbon. Each carbon is tetravalent, right? It is very hard, one of the hardest substances. It is not a good conductor of electricity. But graphite, it has these hexagonal layers. Graphite has these hexagonal layers in which each carbon atom is bonded to 3 other carbon atoms, right? And since there is one free electron, and because of that it is a good conductor of electricity. It is soft because these hexagonal layers have these van der Waals interaction, or weak forces, you can say, weak intermolecular forces between these 2 layers, and due to that they are very weak. If you just hit them once, they will slide straight away. They are soft and will slide straight away. Fullerenes, again, Buckminster fullerenes, just the name is important. It is neither too hard nor too soft. Then you have hydrocarbons. We have saturated hydrocarbons, unsaturated hydrocarbons, and we have cycloalkanes. Okay, saturated hydrocarbons are those hydrocarbons. Firstly, what are hydrocarbons? Compounds that have carbon and hydrogen atom. Saturated means they have only carbon-carbon single bonds. Only carbon-carbon single bonds, like alkanes. Unsaturated means they have carbon-carbon double bond or carbon-carbon triple bond, like alkenes and alkynes. Okay. The general formula is as follows: CnH2n plus 2, CnH2n, and CnH2n minus 2. For cycloalkanes, they are saturated. Why? Because yes, they have a ring, but all the carbon-carbon bonds are single. Okay, that's why cycloalkanes are saturated hydrocarbons. Next is homologous series. Okay, a homologous series is a series of organic compounds that have same functional group, same general formulas, same chemical properties, gradual change in physical properties, and each successive member differ by a CH2 unit, 1 carbon 2 hydrogen, which is 14 atomic mass unit. Okay, CH2 difference. Now, some include some member of homologous series. For example, alcohol is one homologous series. Then you have aldehyde, then you have ketone, then you have carboxylic acid, and what else is there? We have alkane is one homologous series. Alkene is other homologous series. Alkyne is also one homologous series, right? These all are the homologous series given in your syllabus. Now, how do you name any hydrocarbon? So, simply put, let's start with an example and we go step by step from there. So, let's say we have this. Okay, let's start here. We start by naming the longest carbon chain. So this is the longest. This looks like the longest, no? We'll count it, the number of carbon. It has 5 carbons, right? But if we count this way, let's go this way, and if we count it this way, 1, 2, 3, and this will be 4. So obviously 5 is greater than 4. That means this is the parent chain. This is the parent chain. Now you'll start by naming the substituent first. The substituent is this group. What is the substituent? The substituent is this group. What is this group? This is methyl. And at what position it is attached? At 3 position, 3 methyl. And then how many carbon are there in the parent chain? 5 carbon. For 5 carbon, what is the root word? For 5 carbon, the root word is pent. So you will write pent. And then what is the functional group? All the carbons are singly bonded. That means it is an alkane. So you add the suffix, which is ane, right? For some metals, some functional groups you have suffix, for some you have prefix. You see here for halogens you have a prefix, which is halo. For halogens the prefix is halo. Okay. For example here, For alcohol, the suffix is -ol. For ketone, it is -on. For aldehyde, it is -ale. For carboxylic acid, it is -oic acid. For alkane, -ane. Alkene, -ene. Alkyne, Y and E. Okay. Okay. Now, what are the chemical properties or chemical reactions of carbon compounds? The first is combustion, which means addition of oxygen, but the supply is not limited. This is the unlimited supply of oxygen. If you give unlimited supply of oxygen to any hydrocarbon, which is carbon hydrogen compound, what will happen? We will get carbon dioxide plus water plus heat and light. Right? Second reaction is oxidation. Oxidation means addition of oxygen but in a controlled manner. You are not giving the unlimited supply. You are providing oxygen in a controlled manner. Okay. So for if you add oxygen to ethanol, these are the oxidizing agent, alkaline K-4 or acidified K2Cr2O7. What we will get? We will get acetic acid, ethanoic acid. Third reaction is addition reaction. It is shown by saturated compound. Why saturated compound? Because saturated compound have single bonds. All the bonds are single bonds, right? Unsaturated compound. Addition reaction is shown by unsaturated compound. Unsaturated compound have double or triple bond. So there is a possibility you can break one of the bond and add something here. If you break this bond, you will add some 2 atoms here. Okay, that is addition reaction. This reaction that is used is hydrogenation reaction. Hydrogenation reaction, right? Ethene, you have ethene, it gets converted into ethane. Then you have substitution reaction. It is given by saturated compounds. Saturated compounds means they have only single bond, only carbon-carbon single bond. In here, one atom comes and substitutes the other atom. Chlorine came and substituted one hydrogen. Okay, we get CH3Cl. Okay, that is substitution reaction. Substitution given by unsaturated, yes. Let me just see how many we have. 3, 4. Okay, 4 we have. Then we'll be done. Ethanol and ethanoic acid. How do you distinguish between ethanol and ethanoic acid? You use the test. What are the tests? Ethanol, litmus test. Ethanol does not give any color change. Ethanoic acid will turn blue, litmus red. Sodium carbonate, sodium bicarbonate test. So ethanol again do not show any reaction with sodium bicarbonate, but ethanoic acid, it shows reaction. It gives carbon dioxide gas, brisk effervescence of carbon dioxide gas. Okay. Next is properties of ethanol and ethanoic acid. Combustion. Ethanol show combustion reaction. That means if you add oxygen, you will get carbon dioxide and water. They react with sodium. So if you add sodium gas to sodium metal to ethanol, what we will get? Sodium ethoxide and hydrogen gas. Now this is a test that you can use to check if there is ethanol present or not. Now oxidation of ethanol, we have just studied it. If you add an oxidizing agent, we will get ethanol to ethanoic acid. If you have propanol, we get propanoic acid. Butanol, we get butanoic acid. Dehydration means removal of a water molecule. So if you remove a water molecule from an ethanol, if you remove HOH, one water molecule from ethanol, we will get ethene. This is ethene. Similarly, for ethanoic acid, it does react with sodium in same way. We get sodium acetate plus hydrogen gas is released. Hydrogen gas burns with a pop sound, right? Then you have they react with sodium hydroxide. Again, acid plus base, we get salt and salt and water. Salt is sodium acetate. Now again, reaction with sodium carbonate bicarbonate, we will get salt, water and carbon dioxide. This is a characteristic reaction. That means it is used to test if we have ethanoic acid or not. Second, then you have esterification reaction. Very simple. Any alcohol and acid. Any alcohol and acid combine in acidic medium. Any alcohol and acid combines in acidic medium, and we get ester and water. We get ester and water. That is esterification. Now if you reverse this reaction, we get saponification. That means if any ester react with base, an ester react with base, we get the sodium salt of carboxylic acid, ammonium or sulfonate salt of long chain carboxylic acid, they work fine in both. Now for soap and detergent, the figure is this is the soap molecule. They have a hydrophobic tail, that means a water fearing tail, and a hydrophilic head, which means a water loving head, right? And that means a water loving head and a water fearing tail. Okay, this is micelle, my dear students. This is micelle. What is micelle? So micelle is a structure formed when you have a soap molecule which has a hydrophilic head and a hydrophilic tail. This is hydrophilic head and a hydrophobic tail. So what will happen? The hydrophilic head will go towards the water and the tail will attach itself to the oil or dirt particle. If it attaches itself to the oil or dirt particle, we get this structure that is called micelle. That is called micelle. This is the impurities. Okay. So what will happen? What will happen here? So this is micelle. Once the micelle is formed, you agitate it. You agitate the cloth, or you physically beat it. What will happen? This micelle and add excess water. So physically agitation you do. After agitation, you add water, excess of water, and it will wash away. This micelle will wash away. So all the impurities is washed away, right? This is the impurity. The soap molecule aligned itself in such a way that the hydrophobic tail was attached to the oil particle, and the hydrophilic head was pointing towards the water, and then we agitated it and we washed it away with excess of water. Okay, now before we start the question, we'll have a 5-minute break. Not 5 exactly, let's have an 8-minute break. Class, I'll write it, we'll start at 11:40. Okay, meet you all at 11:43, okay? Let's have a little break before starting the questions. Hello everyone. Let's start with the questions now. Are you ready? Okay. Let me see. You guys were chatting, I saw that. Okay, let's start. Okay, the questions will be, I'll mix match, okay, because I think case-based questions are there. So we'll start with the case-based questions, then we'll do MCQs, then little assertion reason questions. Okay, everything is there. Good morning, it's afternoon. Why are you so late? Okay, let's start with the question without any delay. This is the first question. Very easy, very simple. A metal M is there which reacts vigorously with water. So we already know that metal M is sodium, right? Okay, it forms a solution S and a gas G. So when sodium reacts with the water, it forms a solution S and a gas G. Solution S and a gas G. This is the gas, no? Hydrogen is gas, so this will be gas G and this will be your S. Okay, now this S turns blue litmus, red litmus blue. No worries. This S turns, let me just on in the comments. Yep. Right? This S turns red litmus blue. That means S is basic. Yes, sodium hydroxide is basic. Gas G is lighter than air and burns with a pop sound. Yes. So this is the reaction, my dear students. Right? So that means the metal M is sodium, the S is sodium hydroxide, and the gas G is hydrogen. See, that's how you do the case-based questions, okay? Okay. Let's start with the next question. Okay, so big, no? But it is talking about this process called electrolytic refining. So we just need to tell what is the cathode and anode if you are refining copper. So if you are refining copper, the cathode will be the impure copper. Sorry, the cathode will be the pure copper rod. Pure copper. And the anode will be the impure copper. Clear? Solution that we use is any soluble salt solution of that metal, any soluble salt solution of that metal, which is copper sulfate in this case. Okay, next, how do you refine copper? When you pass electricity, the anode will break down, it will dissolve in the electrolyte in the solution. From the solution, an equal amount of copper will deposit on the cathode, right? So at cathode you have the pure metal, at anode you have the impure metal, in the electrolyte you have the copper sulfate. Again, we have zinc. If we dissolve it in zinc and silver, and if we dissolve it in a copper sulfate solution, both the beakers have copper sulfate. So what will happen? As zinc is more reactive than copper, it will displace copper and we will get zinc sulfate and copper. But silver is not reactive. Silver is not more reactive than copper. So what will happen here? No reaction. No reaction happen in this case. Okay, we have this table. From this table you have to tell the most active metal. The most active will be the one which is the highest, which is lying at the top of the reactivity series. So you see here we have A, which is more reactive than copper, B, which is more reactive than iron, C, which is more reactive than silver, and D is not reactive at all. The most active metal will be B. Why B? Because B is more reactive than iron, and among these copper, silver, iron, we know iron is the most reactive, right? So that's why the most active metal is B, least reactive is D. Order will be, you start with the D, then after that silver or copper, which is more reactive, which is less reactive, silver or copper, which is less reactive. Silver is less reactive, so that means C, and then you have copper, which is A, and then finally B, which is the most reactive. Then you want to store zinc sulfate and silver nitrate. So if you want to store them, the solution, the beaker should be of such material which is less reactive than these, because if it is more reactive, if the metal vessel is more reactive, it will displace zinc and it will displace silver nitrate. So then what is the purpose of storing if it is not silver nitrate or zinc sulfate at all? So we'll store it in a container that is made up of metal which is less reactive than zinc and silver. Which is the metal? That metal is D. That metal is D here. Metal high up in the reactivity series, very reactive. Again, why cannot, one question was there now, why can't we reduce oxygen of oxides of sodium by using carbon? Because the reason is because, let me write here, sodium has more affinity for oxygen. Because sodium has more affinity for oxygen than carbon, and that's why we cannot reduce sodium using carbon. Why? Because if given a choice between carbon and oxygen, or sodium will always choose oxygen. Sodium will always choose oxygen, okay, and we will get sodium oxide. Okay, clear? The extraction of sodium from molten sodium chloride, first step, let me write it. The first step is melting of chloride. Second step involves passing of electricity. If you pass electricity, what will happen? Then what will happen? At anode we will get chlorine. At anode we will get chlorine gas. If you want, I can write the reaction here. We will get 2Cl negative and it will convert into Cl2 plus 2 electrons, right? And at cathode we will have Na positive, and this Na positive will combine with the electron and we will get Na. This is the reaction happening at cathode. So at cathode, Na will be there, sodium will be there, okay, and that is the reaction only. These are the three steps there. Carbon is used as a reducing agent. We know we have zinc oxide. If we add carbon to it, we get zinc plus carbon monoxide. Here it act as a reducing agent. Reducing agent reduces other and oxidizes itself. So carbon reduced zinc. From zinc oxide we get zinc. Now the removal of oxygen, that means it got reduced, and carbon added an oxygen, that means it got oxidized, okay. And why we use molten sodium chloride, not aqueous sodium chloride, when we are doing electrolytic reduction? One thing only, because molten sodium chloride has Na positive and Cl negative. In aqueous sodium chloride, we will have H positive and OH negative also. So what will happen, my dear students? Na positive and H positive will compete for the cathode position. Na positive and Na positive and Na positive and H positive will compete for the cathode position, and we do not know what we will get then, okay. We will get hydrogen in place of sodium, and we want sodium because we are extracting what? Sodium. Because we are extracting what? Sodium. We don't need sodium only, right? Okay. So that's why we do not use aqueous sodium chloride. Why? Because the hydrogen ion will compete with the sodium for the cathode position, and in place of sodium we will get hydrogen. Alloying, again, chemical formula of chemical name of rust. Chemical name is hydrated iron oxide. And the formula of rust is Fe2O3.XH2O. Galvanization, alloy. What are alloy? Made up of metals or metals? Combination of. Alloys are homogeneous mixture of metal or metal with a non-metal. Why we do alloying? Alloying is done to improve the properties of metal, because some properties might not be there in your metal. So we want to improve the property of metal. That's why we do alloying. And one more thing, alloys have lower melting point. Alloys have lower melting point than the constituent metals. Now, one example of metal alloy, brass, bronze, and one example of a metal non-metal alloy, that is steel. Steel is iron plus carbon, that is steel. That is an example of metal and non-metal alloy. Next question. Metal M is used in making ornaments. Gas Y2 is used in making bleaching powder. We know the only gas that we need for making bleaching powder is chlorine gas, right? We know that gas is chlorine gas. And ornament making, we have seen that silver, no? We have seen silver for ornament making. So if metal salt will be AgCl, the metal salt will be AgCl. When you expose it to sunlight, it splits up to form metal M. Metal M will be Ag and gas will be chlorine. The salt itself is used in black and white photography. This salt, yes, silver chloride is used in black and white photography. So the gas is chlorine. The metal salt is AgCl, and you can precipitate it using, if you have AgNO3, and we have one more, KCl. Yes, if you have AgNO3 and KCl, if you mix them, we get AgCl plus KNO3. That's how you get your salt AgCl. Take place when salt is exposed to, this reaction is when your AgCl salt is exposed to sunlight. Sunlight is represented by this symbol called Hν, right? So if it is exposed to sunlight, the reaction is photolytic decomposition. The name of the reaction is photolytic decomposition, and the product are silver plus chlorine gas. Silver plus chlorine gas. Yes, correct, Hemant. Okay. Any doubts you have? Yes, you can ask me. No problem in that. When you have a metal compound, black metal compound, remember it is a black metal compound. So we know that could be copper oxide because we have read that, right? Copper oxide is black in color. If treated with a colorless gas Y2, then metal X and another compound Y2O are formed. It looks like no water, no? So that means it either reacted with what? Hydrogen, and we got copper plus H2O. And this metal X does not react with dilute acid. Yes, it does not. Gas Y2 can also be prepared by the action of dilute acid and active metal. So we know when metal and acid react, we get salt and hydrogen gas. We get salt and hydrogen gas. Okay. So here hydrogen gas, Y2 is hydrogen gas. Okay. Compound Y2 is liquid at room temperature, and it is the reason that anhydrous copper sulfate is blue. The copper sulfate blue is because of these 5 water of crystallization. So that means this Y2O, this is Y2O. This is Y2O. We know the answer now. Metal X is copper, Y2 is H2, XO is CuO, Y2O is H2O, right? And this is the reaction that it is talking about. See, logically, if you answer it, I know it is not, you won't write the answer like this, you will write in full sentences, right? But if you read the question properly, you will get the answer. Okay, so should I not come and look at the comments? You don't have any doubts? Yeah. Okay, you don't have any doubts. Let me just continue then. Gas A, major cause of global warming. That means the gas A might be carbon dioxide, right? And it combines with hydrogen oxide. Hydrogen oxide in the presence of any environmental factor and a green material D and form a 6-carbon compound. 6-carbon compound plus oxygen gas is released. So that means the component is sunlight and chlorophyll. Sunlight and chlorophyll, right? Gas F is necessary for breathing. So that means this is gas F, this is the compound E, this is your gas A, and this is the hydrogen oxide B. So this is the overall reaction, and the reaction is, name of the reaction is photosynthesis. Again, photosynthesis is exothermic or endothermic? Tell me. Photosynthesis reaction is exothermic or endothermic? You guys are just talking. B is water. Yes, B is water, correct. So the reaction is exothermic or endothermic? Tell me, photosynthesis is exothermic or endothermic? No, it's not. Photosynthesis is endothermic. Always remember it, photosynthesis is endothermic. Why endothermic? Because sunlight, you are providing sunlight, energy is getting absorbed, and because of that reason, it is endothermic. CaSO4.5H2O. Gypsum is 2H2O, right? CaSO4.5H2O. Next question. A white metal is taken in the form of ribbon. This is not a salt. Nope, it is not a salt. Hold on a second. My net is not working. Just give it a minute. Okay, so a white metal is in the form of a ribbon. You ignite it, it burns with a dazzling white flame. I don't know about you, but I know only one metal burns with that dazzling white flame. That is magnesium. That is magnesium, right? So when you burn it, magnesium ignites, burns in air with a dazzling white flame. We get magnesium oxide. Just balance it. Okay, so magnesium oxide is this powder. This is the white powder Y. This is X, right? And metal X combines with oxygen to form powder Y, and water is added to powder Y, dissolves partially to form another substance. When you add water to magnesium oxide, now this is a metal oxide. Metal oxides are basic in nature. So what will happen? So I think that was your doubt. CaSO4.5H2O, that is not a salt. Okay, we only know calcium sulfate.2H2O, that is gypsum. Okay, so when magnesium oxide combines with water, we get a base, which is magnesium hydroxide. Magnesium hydroxide. Clear? These are all the reactions. Substance Z. This is substance Z. And you use it for treating indigestion. It is a good antacid. It is a good antacid. Next question. So big, no? But we know the substance P that we used for flooring, it is calcium carbonate, right? Because that is normally used for construction. When you heat it strongly, it decomposes to give calcium oxide plus carbon dioxide, right? The gas Q, this is solid Q, this is R, this is P. Now this solid Q, which is calcium oxide, reacts with water. Calcium oxide reacts with water and form what? A substance S. So the substance S will be calcium hydroxide, and lots of heat will be released, Now, when gas R is passed, what is gas R? Carbon dioxide is passed through a clear solution of substance S. This is substance S. If you pass a carbon dioxide through a clear solution of calcium hydroxide or your lime water, it will turn milky. It is in calcium carbonate. Now it is saying that P and this substance is T. P and T are the same substances. So you see P and T is same, no? That is P and that is T, right? Okay. A white shirt has a yellow stain of curry. When soap is rubbed on this during washing, a yellow stain turns reddish brown. So my dear students, I don't know about you, but I do know that turmeric, it is in acidic medium and in basic medium, how it behaves. In basic medium, it is reddish brown. In basic medium, it is reddish brown. Okay. On rinsing the shirt with plenty of water, again, if the medium is neutral, it is yellow colored. Again, the color will be yellow. The natural indicator in curry stain is turmeric. Reddish brown turns yellow again. Nature of soap. So that means the soap was basic. Basic nature of soap. Correct. Chlor-alkali process. So in acid also it is yellow colored. Okay. Next question. We are given 3 test tubes, test tube A, test tube B and test tube C. Okay. One of these test tube contain, let's say this contains distilled water, and the two other contain, this contains acidic solution, this contains basic solution, and you are given only blue litmus paper. So how will you test it? So firstly, if you put blue litmus paper into this acid, it will turn red colored, right? And if you put red colored litmus paper in base, it will turn blue colored. For this distilled water, as it is neutral, no color change will be observed. No color change will be observed. See, that's how you analyze these kind of questions, my dear students. Acid turn to red, yes. Hydrogen anode, okay, what is going on? Okay, next question. The pH values are given here, which is weakly alkaline, neutral, acidic, basic. Okay, weakly alkaline, D, neutral will be C, as strongly acidic A, strongly alkaline E, weakly acidic B. Very easy. These kind of questions are very easy, no? D. What are you typing D for? That is, okay, yeah, weakly alkaline is D, correct. Solution A turns indicator blue to purple, whereas solution B turns universal indicator orange to red. Okay, blue to purple and orange to red. So tell me action of solution A on litmus. Solution A, that means solution A is basic and solution B is acidic based on the color change. So solution A will turn blue litmus, basic no, so it will turn red litmus, blue, and solution B will turn blue litmus, red. Name any 2 substances which can give solution like A. So any base, sodium hydroxide, potassium hydroxide. Any solution like B, B is an acid, so HCl, H2SO4. And when solution A, which is a base, react with solution B, which is an acid, what do we get? Salt plus water. That is neutralization reaction. That is neutralization reaction. Hydrochloric acid reacts with metal X and to form a gas Y, which burns with a pop sound. That means you have a metal again plus acid. In this case, it is HCl. The product formed is salt plus hydrogen gas. Salt plus hydrogen gas. Now, only because hydrogen gas burns with a pop sound. Sodium hydroxide solution also reacts with the same metal. So we have NaOH also, that is reacting with the same metal. So that means the metal is reacting with both acids and bases. That means the metal is amphoteric. And we have only 3 metals that are amphoteric. We have zinc, aluminum and lead. Let's take any one of these. Let's take zinc here, for example. So when zinc reacts with HCl, we get zinc chloride plus hydrogen gas. And when zinc reacts with sodium hydroxide, we get sodium zincate plus hydrogen gas. Clear? These are your reactions. A compound which is prepared from gypsum has the property of hardening when mixed with a proper quantity of water. Identify the compound. So this is gypsum, calcium sulfate dot 2H2O, and the only substance we know that is formed from gypsum is POP, which is calcium sulfate dot half H2O. Okay, identify the compound X. This is compound X. Chemical equation for its preparation again. If you heat gypsum around 100 degrees Celsius, or you can say 373 Kelvin, what will we get? We will get calcium sulfate dot half H2O and 3.5 water of crystallization. 3/2 water of crystallization will be lost. This is used in hospital for treating fracture, bone fractures. Yep, to set up fractured bones. Correct. No one. What's your name? No one. Yes, forms. Hey, one more thing, tell me, if we heat it greater than 100 degrees Celsius, if we heat gypsum at temperature greater than 100 degrees Celsius, what will happen then? Tell me what will happen then. So many comments. Hi, Rafi. Dead burnt plaster, correct. So what is the formula of dead burnt plaster? This is, it loses all the water of crystallization and we get calcium sulfate. This is dead burnt plaster. One more thing, my dear students, when you are doing these case-based questions that will surely come in your exam, do not get frightened by looking at the statement. It looks so long. Just sit down. You are sitting down obviously. Just read it once, just read it twice, and then you will know. After reading it 2 times, you will definitely know something in that. There are hints given in these case-based questions, right? That's why the statement is so long. The longer the statement, the more hints are there. The more hints and double confirmation thing. You can confirm it in the next line only that, yeah, this is what I was thinking about. This is what I was thinking about. This metal or this salt will be there. And yes, it confirms it. The next statement will confirm it, okay? So do not worry whenever you are reading these kind of questions. Next question. It has strong sense of chlorine and it is used for disinfecting drinking water. Instantly, bleaching powder comes to my mind. Bleaching powder. Identify the substance, chemical name and chemical reaction. Again, the chemical name is calcium oxychloride. Chemical name is calcium oxychloride, and if you take calcium hydroxide and pass chlorine gas through it, we will get calcium oxychloride. Plus H2O. When chlorine and sodium hydroxide being produced during the electrolysis of brine are allowed to mix, name this chemical and write its uses. So when chlorine gas and sodium hydroxide combine are produced during the electrolysis of brine, if you allow them to mix, you get this. Sodium hypochloride you get. Yeah, this is what you get. This is again, this is a form of bleaching powder only. This is a form of bleaching powder only. You have calcium oxychloride. This is sodium oxychloride. This is also bleaching powder. An organic acid, which is acid. Remember the thing that is written here is acid. Yes. No. Okay. Now see. For this question, you are given an organic acid X, which is a liquid. Okay, so an acid is there. Okay, and the formula is C2H4O2. C2H4O2. This is the only acid, no, that we have studied in our books, and it has C2H4O2. On warming it with methanol in presence of a few drops of concentrated sulfuric acid, an acid combines with an alcohol in an acidic medium. This is an esterification reaction, right? This is an esterification reaction. So what will we get? We will get an ester. We will get an ester. So when you are making ester, remember, from this, the OH from this and the H from this, they combine and form a water molecule, and that water molecule is lost. Whatever is left, you just add it. Okay, if you have any problem visualizing it, just see it like this. Same, no? So what will happen here? OH, H, this combine and forms water. So H from the alcohol and OH from the acid. H from the alcohol and OH from the acid. They combine, and what will we get? We will get CH3CO, then from here O, CH3. This is an ester. This is an ester. Okay, that is the reaction, right? Called esterification. It's called esterification, right? That is the reaction. I'll complete here also. So we will get CH3, COO, CH3 plus H2O. What is the name of this ester? It is methyl ethanoate. Methyl ethanoate. Okay. Next question. Balance the following chemical equation. Let's try to balance it one by one. Let's start with the first one. So we have, always remember, when you are balancing these kind of reactions, start with the metal, then non-metal. That is the balancing sequence. Start with the metals first, then do the non-metals, and then after that hydrogen, and then you balance the oxygen. So let's start from the first equation. HNO3 CaOH twice, I know. NO3, we have one HNO3 on the reactant side and 2 HNO3 on the product side. So I can just take it as a 1, and what I'll do, I'll just multiply 2 HNO3 plus CaOH whole twice will give CaNO3. Okay, done. So we have, again, NO3 is balanced. Now let's see the calcium. Calcium is also balanced. Let's check the hydrogen and oxygen then. we have 2 hydrogens. We have 2 plus 2, 4 hydrogens on the reactant side. On the product side, we have only 2 hydrogens. 2 here, 4 on this side. So that means we'll multiply it by 2. Let's multiply it by 2, right? Now the hydrogen is balanced. Now let's check the other atoms. 6, 8, 6, 8. Everything is balanced. Everything is balanced. Okay, done. Now the next one, NaOH, H2SO4. This is very easy. You see only the sodium. The sodium is unbalanced, so we'll do 2 NaOH. Sometimes after just looking at the reaction, you will have an idea. Now just check after sodium, after checking sodium first. Now sodium is balanced. Let's check the sulfate. Sulfate is also balanced. Now let's check the hydrogen. 2 and 2, 4 hydrogens here, but there are only 2 hydrogens. Here see 2 and 2. That means hydrogens on the reactant side are 4 and on the product side we only have 2. So what we'll do, we'll multiply it by 2. Add 2 here. Now you see this is balanced. Check the oxygen. 2 oxygens here and 4 here. So that means 6 oxygen, right? And here we have 4 plus 2, which means 6 oxygens. So that means oxygen is also balanced, right? So this is your balanced chemical equation. Let me erase the extra part. Yep, this is your balanced chemical equation. Clear? Next question. Let's do some MCQs first, because I know you guys are not paying. Some are paying attention, others are just here for chatting. Slowly. You want me to go slowly, huh? You guys should study, but what you are doing here, doing shairi and all. Okay, let me skip to the good part. Where are the questions? MCQs. Here. Yep, let's start with this one. Tell me the answer of this one. Butanol is a 4-carbon compound with the functional group. What is the functional group of butanol? Guys, everyone, please be attentive today, because it is going to be a really long live. We will be doing biology, we will be doing physics, chemistry is almost done. Okay, so yes, see. Butanol has which functional group? Ketone. Correct. C. Hemant answered C. Before that, Ashfi also answered C. Okay, so in butanol, the functional group, firstly, what is butanol? This is butanol. This is butanol. Okay, the functional group is ketone. Correct? Yes. So everyone who answered C, Ansh, okay, correct. The correct answer is C. Next question. While cooking, if the bottom of the vessel is getting blackened on the outside, what does it mean? What does it mean? If the vessel is getting blackened on the outside, what does it mean? That means the food is not cooked completely. No, that won't affect the outside, obviously. Then here the fuel is not burning completely. Yes, the fuel is not burning completely. Not C, student. See, when the fuel is not burning completely, we will get yellow sooty flame, right? Would we call that yellow sooty flame? This sooty means black. Okay, this sooty means black colored coating, not black color. Yes, yellow sooty flame. Okay, so the correct answer is option B. Yes, now you are answering, now you are attentive. Yep, wake up. Okay, give a test used to differentiate between saturated and unsaturated. We have bromine water test. Bromine water test. Okay, so if you add bromine water is reddish brown in color. Bromine water is reddish brown in color. And if you add bromine water to a saturated compound, there will be no color change. It will still be reddish brown. Bromine water will retain its color, no color change. But what will happen if you add bromine water to a unsaturated compound? Unsaturated compound means they have double or triple bond. Unsaturated compound means they have double or triple bond. So if you add bromine water to its unsaturated compound, what will happen? The color disappears. The color disappears. That means, what does it mean? That means the unsaturated compound made the color disappear. Yes, bromine water test. Flame test is also there. Yes, correct. With flame test, unsaturated compound will give yellow sooty flame. And saturated compound generally give blue flame. Good. Okay, let's look for the next MCQ. Where is the MCQ? Here. Okay. Which of the following method is suitable for preventing iron frying pan from rusting? Which is the suitable method? D. Not D exactly. C. That is correct. C. Yes, we can apply grease, but you are cooking, no? It is an iron frying pan. You are using it for cooking purposes. You are cooking and then every day you are washing it. Will the grease stay there? Will the grease stay there? No, right? Paint, if you apply paint, again the paint coating will chip away. Plus, if it's edible, if you are making something to eat out of it, obviously you won't apply paint to it, right? Coating of zinc, yes, galvanization is one. Galvanization is one because we normally use zinc vessels to eat. That is normal. So the correct answer is option C. Who answered C? Yes, Ashfi answered C. And most of you answered D. Yes, okay. Next question. What happens when dilute hydrochloric acid is added to iron fillings? Iron fillings plus dilute hydrochloric acid. Metal plus acid. We will get a salt plus hydrogen gas. Which salt we will get? Tell me the answer for this one. Which salt we will get? Hydrogen gas is there, correct. A. Pavani answered A. Iron chloride. Yes, the salt is iron chloride. FeCl2. That is the salt, iron chloride. Okay. Iron chloride plus hydrogen gas. So the correct answer is option A. The correct answer is option A. And not FeCl, FeCl2. FeCl2. Okay. A solution reacts with crushed egg shells to give a gas that turns lime water milky. So that means the gas is carbon dioxide because only this gas turns lime water milky. So just tell me the solution contains what? The solution contains what? NaCl, HCl, LiCl, KCl, what does it contain? Crushed eggshells. So crushed eggshells have calcium carbonate, right? And what will react with calcium carbonate? Okay, so if you are answering no, B. Pavni answered B. Okay, so if you are answering these kind of questions, just see the options first of all. You have NaCl, you have LiCl, you have KCl. These three are salt. These three are salts. Only one is acid. This option is different, totally different from the rest. So that means this might be the correct answer, right? But we also know when calcium carbonate. Yes, we have calcium carbonate there. And then what will happen? We will get calcium chloride plus carbon dioxide. Calcium chloride plus carbon dioxide plus water. This is the reaction that will happen, okay? So the correct answer is B. Yes, the correct answer is B. Correct, Ashvi. Who else answered B? HCl. Hemant answered HCl. Okay. Next question. Not this one. Let's do the MCQs first. Which of the following type of medicines is used for treating indigestion? For treating indigestion. Calcium oxychloride. Correct. Ashvi is prepared. He is the only one studying, yeah? C. Tanmay answered. The Tanmay is telling something else. Yes, antibiotics are used to treat inflammation, right? For any bacterial infection you have. Analgesic for treatment of fever. Antiseptic, disinfectant. Antacid, that is the only one that is used for treating indigestion. For treating indigestion. C. Correct. So many, now you are answering C. Correct. Next question. When aqueous solution of potassium iodide and lead nitrate are mixed, an insoluble substance separates out. Chemical equation. Correct chemical equation. Okay, so the correct reaction between lead nitrate. Firstly, check where we have the correct formula of lead nitrate. In 2 and 3, only these options have the correct formula, right? Now see the balanced equation. Where is the balanced equation? This is the balanced equation. No, potassium is balanced, but here the potassium is not balanced. See, in the third reaction, 1 iodine is on the reactant side and 2 iodine on the product side. This is not balanced. But here you see 2 iodine on the product side and 2 iodine on the reactant side. And rest all the elements are balanced. So the correct equation is 2. Yes. Correct, Pavni. Yes, Hemant, finally. Proton brain. Now you're going to. Okay, next question. When sodium bicarbonate reacts with the dilute hydrochloric acid, the gas evolved is when sodium bicarbonate. This is sodium bicarbonate. And when it reacts with dilute hydrochloric acid, what is the gas evolved? You see, by these reaction only, you know this is base, this is acid. You will get a salt. Salt is sodium chloride, but there is hydrogen also, oxygen also. We'll get one water also, right? Carbonate is there, CO3. That means I can get carbon dioxide, right? So the answer is which gas is evolved? Carbon dioxide. Yes. Someone is asking C. Yes. Carbon dioxide as it turns the lime water milky. Lime water milky. Next question. Sodium hydroxide is termed as an alkali while ferric hydroxide is not. What is an alkali? Alkali is water soluble bases. Water soluble bases are alkali. Water soluble bases are alkali. So tell me, why is sodium hydroxide an alkali while ferric hydroxide is not? Be correct. Okay, so sodium hydroxide, yes, because sodium hydroxide is a strong base while ferric hydroxide is a weak base. That does not explain the reason. The reason is alkali. Alkali means water soluble bases. Okay, if ferric hydroxide is not an alkali, that means it is not water soluble. That means ferric hydroxide is not water soluble. So we look for that explanation. Sodium hydroxide is a base which is soluble in water. Yes, that's why it is called alkali. And ferric hydroxide is also a base, but it is not soluble in water. So that is the correct answer. Sodium hydroxide strong base, ferric hydroxide strong acid? No, because there is hydroxide. There is hydroxide, and hydroxide are given by bases, not acids. Base gives hydroxide. Okay, clear? Okay, so that means the correct answer is option B. Next question. The electron dot structure of chlorine molecule is. So we have chlorine has 7 electrons in its valence shell, right? So if I 1, 2, 3, 4, 5, 6 and 7. Then we have one more chlorine, let's say, and I denote its electrons by dot 1, 2, 3, 4, 5, 6, 7. 2, 8, 7. That is the electronic configuration of chlorine, right? That means 7 electrons in the valence shell. Chlorine forms single covalent bond. Chlorine forms single covalent bond. Okay, this. So what will happen? Count the number of electron 1, 2, 3, 4, 5, 6, 7, 8. Now here, count the number of electrons for the green one 1, 2, 3, 4, 5, 6, 7, 8. So both chlorine have completed their octet by sharing one electron, and this is a single covalent bond by making a single covalent bond. So which will be the correct answer? Just tell me which will be the correct answer. It has double covalent bond. This has double covalent bond. This is not correct. Yes, C. This has triple covalent bond. That is also incorrect. Again, there is double covalent bond. Incorrect. This is the correct answer. This is the correct answer. Okay. Next question. In order to balance the following chemical equation, the values of coefficient, you need to tell me the value of coefficients X and Y. Some option we can eliminate just by looking. This is incorrect because 3, 4, 2, 6, 3 values are given. Okay, now let's see. On the product side, we have 2 lead. We have 2 lead. So that means X will be equal to 2. Now let's see. Oh, 3 options. All 3 options have 2. No worries. Let's check the Y. Y is the number of nitrogen. Let's check. Focus on the nitrogen only. So here if we put 2 Pb NO3 whole twice. So there are 2 nitrogens, right? There are 2 here and 2 here. So 2 times 2, 4. 4 nitrogens on the reactant side. So we need 4 nitrogens on the product side. And are there any other nitrogen compounds? No. So only this will fulfill that. So that means Y will be equal to 4. Y will be equal to 4. If we put 4 here, now you can see the reaction is balanced. We have 3 times 2, 6, 6 times 2, 12 oxygen, and here we have 4 times 2, 8 plus 2 plus 2, which is 12, yes. On this side we have 12 oxygens, on that side we also have 12 oxygens. Number of lead is also balanced, number of nitrogen is also balanced. So the correct answer is A. Let me see how many answered A. Yes, Pavani answered A. Okay, which of the following reaction is an endothermic reaction? So in which reaction energy is getting absorbed? Energy is getting absorbed, right? Tell me the answer for this one. You tell me the answer for this one. tell me the answer for this one. D. B. Someone is answering B, someone is answering D. D. Okay, so when you burn coal, carbon plus oxygen, that is the burning of coal, carbon dioxide, and lots of heat is released. So that is not endothermic, that is exothermic. Energy is getting released. Okay. Decomposition of vegetable matter into compost. Again, decomposition of vegetable matter is an exothermic reaction, because if you have ever decomposed it, you will see that if you go outside and you check it, so there will be warmth coming out of it, there will be energy getting released. That means it is an exothermic reaction. Respiration, when you do respiration, energy release. Do we get energy from respiration or we give energy? We get energy by respiration, right? We get glucose, we have glucose, right? It combines with oxygen, it breaks down into carbon dioxide plus water plus energy is released. Okay, energy is released, that means it is also exothermic. So only one reaction is endo, that is option D, which is when you decompose calcium carbonate, you give energy, you provide heat. This is thermal decomposition. The reaction is thermal decomposition. And we will get calcium oxide plus carbon dioxide. Next question. The oxide which can react with HCl as well as KOH. That means that will be an amphoteric oxide. Now which among these is amphoteric oxide? Very easy. Which among these is an amphoteric oxide? You see, copper oxide is metal. It is basic in nature actually. Copper oxide is basic in nature. Again, these two are also basic in nature. So we have only aluminum oxide. We have, yes, Mohinder, we have only aluminum oxide. That is your amphoteric oxide. Next question. In which of the following chemical equation the abbreviation present the correct state of the reactant and product involved? So this is what? Combination reaction. This is an example of combination reaction. You have to tell the exact state. You have to tell the exact state of the reactant and product. So when hydrogen combine with oxygen, we get water. All the reactions are completely balanced. They are correct. But now you have to tell me which is the correct representation. Hydrogen is liquid or oxygen is liquid? No, neither of them is liquid. Both are gases. So hydrogen gas combines with oxygen gas and we get liquid water. Water is liquid, right? Done. So who answered? Pavani answered C. Correct. Okay, so your next class, yep, your next class will start after 10 minutes, okay, after 10-15 minutes. Till then, if you have any doubt, I'll give you a 10-minute break, don't worry. We have 5 minutes. If you have any doubt in chemistry, you can ask them now. Any doubts? Ask. You can ask now. If you have any doubt, you can ask them now. We have time. Nomenclature of carbons. So, Mohinder, right? We should try one. Tell me the name of this one. Let's try a different one. What is the name of this compound? Try. Mohinder, yes. It is not an ester. No, it is not an ester. This is a ketone functional group. This functional group, CO, it is ketone. Ester is different. Ester has 2 oxygens. Ester has 2 oxygens. So it would have been this one. This is ester. It has 2 oxygens. Here only one CO group, carbonyl group we call it, right? And here you have one alkyl group and here you have other alkyl group. Right? So the name is 1, 2, 3, 4, which means the root name is butanenon. Butanenon. Clear? For LDI, for ketones you use on. See, for nomenclature, do not worry much. To be honest, they won't be asking you the complicated one. They will ask you simple, straightforward one. No branching, nothing. Okay, simple, straightforward one will be asked. Don't worry about it. Dead short. So homologous series, it is a series of organic compounds that have same general formula, same functional group, same chemical properties. Each successive member differ by CH2 unit. Okay, each successive member differ by CH2 unit, and they show gradual change in physical or chemical properties. So same functional group, same general formula, same chemical properties. Each successive member differ by a CH2 unit, which is 14 atomic mass unit, and they show gradual change in physical properties. Either the physical properties will increase or they will decrease. Physical properties means melting point, boiling point, molecular mass. Okay. Any other doubt you have? Anodizing. So basically anodizing is a process by which we deposit layers of aluminum oxide on any aluminum article. You take any aluminum article and you apply layers of aluminum oxide. Deposit, actually not apply, you deposit layers of aluminum oxide on that aluminum article, okay, to prevent the corrosion. That is anodizing. That is one method to prevent corrosion of aluminum. Any other doubts? Is it clear, Pavni? Firstly, take my name correctly. What is, I'm not. Color change reaction. That is copper sulfate combines with iron. We get iron sulfate and copper, right? The color changes from blue color of copper. See, copper sulfate is blue in color. Iron sulfate is green in color. Copper is reddish brown in color. Okay. So there will be a reddish brown deposition on the metal strip, on the iron metal strip. Hydrogenation. So hydrogenation is when you have an unsaturated compound. When you have an unsaturated compound and you add hydrogen gas to it in presence of nickel catalyst, it gets converted into a saturated compound. So normally that reaction is used to convert vegetable oils into fats. Vegetable oils into fat, because oils are unsaturated compound, fats are saturated compound, right? In presence of hydrogen and nickel catalyst. That is hydrogenation. Solvay process, it is used to synthesize washing soda. It is used to synthesize washing soda and also baking soda. So it has 3 steps. First step involves when you have brine, which is NaCl plus H2O, aqueous solution of sodium chloride, and you add ammonia to it and pass carbon dioxide gas. So you get baking soda, NaHCO3, right? Now if you heat that baking soda, you will get sodium carbonate. And if you add 10 water of crystallization to that sodium carbonate, you will get washing soda. That 3 steps is the Solvay process. Okay. Hi Sumaya. I hope I pronounced your name correctly. Okay, now the next teacher will come in 10 minutes. Okay, I am leaving it. Next class is at around 1. Okay. All the best for your boards, no? You have your boards tomorrow, your science exam tomorrow, right? All the best. Do not panic. Be chill. You got this. Whatever you have studied, just revise it. Okay? Tomorrow 4 a.m. revision is there, right? So attend it. We are doing a 4 a.m. revision, so take it. And yes, all the best. Don't worry. You got this. Bye.
Hello, hello, hello. So that is exactly why. That's exactly why no one was asking. Hello, hello. Am I audible now? Is it clear? Okay, let's have a check. Everyone who feel I am audible, just give me a thumbs up now. Everyone who feels that I'm perfectly audible, just give me a thumbs up. By the way, very good afternoon to each and every single person out there. Let's have a one more start. Okay, fresh start. Yes. Thank you. Okay, perfect. Yes, ma'am. Yes, ma'am. Yes, ma'am. Okay, Pavani, just Akush. Perfect, Himanshi. So I see serious people also over here. Okay, perfect. Let's see. The first question that we have from the chapter life processes, we'll go chapter by chapter and we'll become pro in all the chapters. Okay. Assertion says the inner walls of the small intestine have finger-like projections called villi, which are rich in blood. Reason says these villi have a large surface area to help the small intestine in completing the digestion of the food. What do you think is the answer for this question? You have option A, both A and B are true and R is the correct explanation of A. Option B, both A and R are true but R is not the correct explanation of A. C is A is true but R is false. D is A is false but R is true. What do you think is the correct answer for this particular question? Someone says A, someone says D. What do you think is the answer for this particular question? Pavani says D. Pavani says D. A is false but R is true. Is it? Why is A false? Someone says A. A is what? Both A and R are true and R is the correct explanation of A. Well, A. Ayush also saying A is the answer, ma'am. Okay, since you guys are saying I love the answer is A. Baba, you only see the innermost wall. If I go inside the small intestine, okay, and I see what is happening up there in the small intestine, I will be able to see some finger-like projections out there, which I call as villi. And you know what? This particular villi which is there, it has so much blood vessels inside it. Okay, now suppose a food came in. A food is over here in the small intestine and the food is broken down. You get small things such as glucose, amino acids and things like that. These glucose, amino acids and everything is going to be taken up. Taken up by what? Taken up by the blood vessels, and from the blood vessels it goes to the entire body. So this is a super important process. So inner wall of small intestine have finger-like projections called villi, which are rich in blood vessels. Correct, Baba. These villi will have large surface area to help small intestine in completing digestion of food. Is that correct? Does it have large surface area? Listen to me. Suppose it was not like this. It was just like this. Okay, now when it is like this, don't you think it can take in the absorbed material from all the direction? If you consider this, it will be less surface area. If you consider this, there will be more surface area. So both the statements are correct, which is why your answer for this question is A. Now everyone who gave me the correct answer A, you guys are absolutely correct. Okay, now let's go ahead with the next question, question number 2. By the way, everyone who is talking over here, where is chemistry wali madam? Chemistry wali madam, she went now because chemistry lecture is over. Now it's time for bio, and after that we would be having physics. Okay. By the way, everyone who is chatting over here, bacha log, this is not the chat sessions. Please do not do the chat sessions. Otherwise, you know what? I have a superpower. That superpower is to basically remove the people from the chats. Okay, so I really do not want to do that. Otherwise it will be really bad, right? So everyone, tomorrow you have your boards. Boards are really important. The marks are super important. So let's not talk to each other, right? Let's not talk to each other. Let's talk to me. You talk to me and I'll be giving you the answers. Okay? Fine. Ma'am, you are right. Yes. So let me draw one thing. Just a second, okay? So I have to do one very important thing. Just give me a quick second out there. And let's see then if at all it works well for you guys who are actually studying. So, where is it? Because it's actually too much disturbance for me as well while teaching. So we'll do one thing, that is, plus ma'am, please make me moderator. Okay, I'll make myself moderator. Okay, let's do some very important thing. So I am putting people on timeout. Everyone who is just here to talk, listen to me carefully. I'll be keeping you on timeout. You will not be able to message in this particular chat for so long. Okay, so let's just study over here. Everyone else who is just talking, I'll just remove you from here. Okay, let's do that one more time. So I am just putting people on timeout. Okay, fine. So dear children, I will be doing questions, and with questions we are going to revise, because I think that will be the best way to do revision as of now for biology, because biology is super vast, right? So now we are going to go ahead with the second question that we have. Given below are two columns. Column 1 shows the enzymes secreted by the glands in the alimentary canal of human beings, and column 2 is what indicating the components of food on which these enzymes are going to act. Choose the options showing the correct matching. So over here you have the enzyme, over here you have the component onto which it acts. Now you have to give me the answer. Pepsin. Pepsin is an enzyme. Does it act on starch, my dear children? Do you think it acts on starch? The answer is no. It does not act on starch. Pepsin is for protein. P for pepsin, P for protein. Okay. Now trypsin is there. Trypsin, does it act on proteins? What do you think? Let's keep that option on hold. Now lipase. Lipase acts on proteins. Arey baba, lipase cannot act on proteins. It acts on what? Lipids. So again, that would be wrong. Now what do you have? Amylase. Amylase, does it act on emulsified fat? No baba. Amylase acts on carbohydrates. You know salivary amylase. Salivary amylase acts on starch. Starch is what? Carbohydrate. So in that particular case, what is going to be your answer? Everyone. Pavani says the answer for this question is B. What about others? What about others? Ayush also says the answer for this question is B. Okay, perfect. Mohinder also says the answer is B. So which is why we will log the option which is B. Trypsin, my dear children, is an enzyme that is secreted by the pancreas, and it also acts on proteins, just like pepsin. Pepsin is produced in this case of stomach. In the stomach, it acts on proteins. Similarly, trypsin is the case of pancreas. It is also going to act on proteins. So your answer for this question is going to be B. Works. It is going to be B. RPM also, you are absolutely correct. Solar rates, just Akush. Oh my God, awesome. Perfect. Now let's go on to the next question that is up there and over here. Question number 3. One of the events that does not occur during photosynthesis is one of the events that is not going to occur during photosynthesis. Tell me, chlorophyll absorbs solar energy. Second is carbon dioxide is released during the process. Third thing, oxygen is released during the process. Carbon dioxide is absorbed during the process. What do you think is not going to occur during photosynthesis? For this, you are going to need to know what is photosynthesis. So Ayush says the answer for this question is C. Vaishu says it is B, and I think Vamika also says it is B. Vaishu says it is B. Ayush says it is C. Okay. B, A, B, C, D. What do you think is the answer for this question? A, B, C, D. B. Mohinder says it is B. Carbon dioxide is released during this particular process. Listen, what is photosynthesis? In photosynthesis, the plant baba says that give me carbon dioxide. Give me carbon dioxide plus little amount of H2O. I am going to make what? I am going to make C6H12O6, that is glucose. Along with what? I'll be releasing some oxygen, and also here some amount of H2O is also going to be produced. My dear children, listen to me. CO2 is going to be used up. How can it be released? What is going to be released? It is oxygen. So your only answer for this question is going to be this, right? Carbon dioxide is released during the process. This is exactly wrong. Yeah, this is going to be exactly wrong. So everyone who gave me the answer as B, you guys are absolutely correct. Mohinder says B, ma'am. Sure. Okay, perfect. Okay, let's go ahead. I misunderstood the question. It's okay, it happens. Now the next question that we have is question number 4. Choose the forms in which most plant absorb nitrogen. In which form is Solo is correct, ma'am? Yes. So choose the form in which most of the plants absorb nitrogen. Listen, nitrogen cannot be taken in any random form out there. There has to be some perfect form. Which is that form? Is it in the form of proteins? Is it in the form of nitrate, nitrites? Is it in the form of urea or atmospheric nitrogen? What do you think is the answer? Over here you have got the options like this. You have to choose from this. Anyone who have read the NCERT will know it. Yes, Nisha, tell me. Ma'am. Mohinder says the answer for this question is C. C is what? C is 3 and 4. 3 and 4. Ma'am, doubt. Tell me. What is your doubt? Just Akush says the answer for this question is D. D is what? 1 and 4. Again, wrong. My dear children, rather than giving A, B, C, D option to me, you think for yourself. What do you think is the answer for this question? Very important question, Baba. It's there in your NCRT. Check, check, check. B. Pavani says the answer for this question is B. What is B? 2 and 3, and that is exactly correct. Arey, listen, everyone who is talking among yourself, are you guys not going to give board examination tomorrow is what I am going to feel. Is what exactly I am feeling over here. Oh my God. Jyoti, please ask. Ma'am, when will you teach chapter wise? So this is chapter wise PYQ practice that I am trying to do over here. Do you exactly need chapter wise explanation? Do you need it like that itself? So I was thinking I'll do chapter wise PYQs. Yes. Yes, ma'am, please. Mohinder says, yes, ma'am, please. Oh, in that case, I would have to take the PDF, PPT from... Okay, Akshara. Okay, fine. We'll do one thing then. Just wait for... Can you just wait for 5 to 10 minutes? Can you wait for 5 to 10 minutes? Okay? Oh my God. Okay, perfect. Give me 5 to 10 minutes. I'll try to bring in the PPTs. I would have to find it, okay? 5 to 10 minutes. That means be back by 1:30. Be back by 1:30. I'll just be there. Just a second. hello. Okay, guys, now I'm back. Everyone who was asking for the complete revision, now I want your 110% attention. Okay, so listen to me very carefully. Yes, hello Pavani. From this point onwards, I'm going to talk, you're going to listen. If you listen properly, you will definitely get the best benefit of this. Okay, so make sure you listen it, and please do not make me spend a lot of amount of energy. I have fever, I'm not really doing that great. Okay, so let's go ahead and start with the first chapter, that is life processes. So in life processes, my dear children, I hope you guys know that there are certain biological processes that are required for all the organisms to live. What do you think that processes are? Nutrition, where basically the food that we take in has to be broken down, and basically the process of obtaining food is known as nutrition. That is one thing. Second is respiration. Respiration is basically with the help of the food that we have taken in, we have to break it down and get glucose, as well as basically the food that we take in is glucose, and when we break it down we get ATP, we get energy, and this energy is used for the whole process that is there for running through all the processes which is there in our body. So that is respiration. Third one that we have is circulation. Circulation basically means what? Each and every particle that is there in our body, whichever is important, all the nutrients, every single thing has to be circulated throughout. And not just nutrients, the oxygen that we take in has to be circulated and given to each and every part of our body. So that is why circulation is important. Excretion, anything that is toxic in our body has to be removed, and that is also super important. So these are all the biological processes, and one more biological process comes into picture, and that is reproduction. But do you think reproduction is a process that is required for an organism to live? The answer is no. There is no need for reproduction for an organism to live. Okay, it's not a life-sustaining process. Reproduction is done just to what? Increase the number of progeny and also for the continuity of species. So please know that. Okay, now yes dear children, please ask the doubt. Whatever doubt you are having, you can ask me also. Now in this chapter you will see a term metabolism. What do you mean by metabolism? Whenever you are adding things up, okay, and you are making something, that means you are doing anabolism. Similarly, for example, in this particular case, when I am combining CO2 plus H2O, what do I get? I get C6H12O6. Over here, what type of reaction is happening? Anabolic reaction. Why anabolic reaction? Because two things have been taken together and it is making something else up there. That is why it is anabolic reaction. Similarly, we have catabolism. In the process of respiration, you might have seen that same glucose which is there, C6H12O6, is going to be broken down to what? CO2 and H2O plus ATP. What are you doing? You are cutting things, which is why it will be catabolism. So in our body, Baba, we have one very important thing, that is metabolic reactions. Metabolic reactions can be broken down to two, anabolic and catabolic reactions. Please know about that. This is very common in all the biological processes, whether it be nutrition, whether it be respiration, whether it's excretion, anything out there. This is going to be involved. Now the next thing that we have is the first part, that is nutrition. Why do you think nutrition is required? Because first of all, what is nutrition? It is the physiological process of absorbing or obtaining the nutrients out there. Why do we require nutrients? For growth, for maintenance, and for reproduction as well. And there are two types of nutrients out there. One is autotrophic and the other one is heterotrophic. What do you mean by autotrophic? Here, organisms are going to prepare their own food. For example, plants. Baba, plants, if they stand under the sun, what is going to happen? The sun's rays falls on them, and basically with the help of the sun's rays and everything, they can prepare their own foods. So I'll say autotrophs are organisms that synthesize their own organic food from what? From inorganic substances. Now this is super important. Okay, what are you doing over here? You are creating organic stuff. From what? From inorganic things. Ma'am, example, listen, CO2, H2O, they are simple things. They are simple inorganic things. With the help of this, what does the plant make? Plant makes C6H12O6. What is this? This is glucose. And what is this? This is organic compound. So always remember, this is an assertion reason question that usually comes in, that in autotrophs, they utilize inorganic things, that is simple inorganic things, to make complex organic things. If in the question it comes that they use complex inorganic things to make simple organic things, that will be absolutely wrong. So please know when to use simple. Simple is used always in inorganic things, and out of it we make complex things. Okay, and for this you will need energy. It can be light energy, it can be chemical energy. If at all you are using light energy, you will call this organism as phototrophic organism, photoautotrophic organism. If at all these organisms are using chemical energy, I'll call them as chemoautotrophic organism. I'll just call them chemoautotrophs because their energy source is chemical. Now what do you mean heterotrophs? Heterotrophs are us, Baba. Do we make their food? Do we make our food? Thanks a lot for this, ma'am. You're most welcome, dear. Okay, so do we make our food if at all we go under the sun and stand? Do you think we can make our own food? No, Baba. Why? Because we do not have chlorophyll pigments, do not have anything. Rather, we depend on other organisms for food. And these type of organisms who cannot synthesize their own food but depends on other organisms for food are known as what? Hetero. Hetero means others. Okay, please remember a heterotroph can feed on another heterotroph. That means probably I eat an animal. Probably chicken. If I'm a non-vegetarian, I can eat chicken, right? So I am basically a heterotroph who is eating another heterotroph because chicken also eats something else, right? Now, on the other hand, suppose I'm eating plant, in that particular case also it works. Anyway, if I'm not able to prepare my own food, I am a heterotroph. Okay? Perfect. Okay, कोई भी free नहीं है. Vineet, come on, guys, you have your exam tomorrow. These board marks matters a lot for you guys. Do not waste your time over here. Okay, innocent chicken, exactly. Yes. So let's go ahead. Let's talk about the next thing. That is, as I told, autotrophic nutrition is divided into two. One is photoautotrophs, another one is chemoautotrophs. Photobaba, they use light energy for preparation of food. For example, plants, they have the sunlight, simple inorganic things, that is CO2 and H2O, from complex organic things, that is what? C6H12O6. Done. Now chemoautotrophs, this example you might not know, so you should know. And also please know, how does chemoautotropism work? Listen to me very, very carefully. Suppose there's a reaction going. A plus BC comes and reacts and you get AC plus B. In this reaction, obviously, there might be chances that some amount of energy is going to be released. Chemical energy in the form of what? ATP. It might be released. Now, suppose this energy is going to help in conversion of simple inorganic things to organic things. Simple inorganic things to complex organic things. What do you call this as? Chemoautotrophs. Where are they getting their energy from? From some other chemical reactions. Okay, from some other chemical reactions. So this is important. This is chemoautotrophs. Example for this also you will be seeing really, really soon. So over here, phototrophs example are green plants, the green algae. Okay, the photosynthetic bacteria which is there, for example, nostoc, anabenna, you might have heard about them, right? All this bacteria, nostoc, anabenna, as well as green algae, green plants, they are photoautotrophs. Chemoautotrophs are basically examples you have. Nitrosomonas, nitrobacter, sulfur bacteria, all of them are chemoautotrophs. So over here I have written nitrosomonas helps in conversion of ammonia to nitrate. Why I have written over it over here? Listen, ammonia to nitrate, when this conversion happens, some amount of energy is going to be released and this energy will be used for converting inorganic things to organic things. Got it? So please remember the example, general example. Photoautotrophs, our examples are what? Green plants, green algae, photosynthetic bacteria such as nostoc and anabenna. Chemoautotrophs example of what? Nitrosomonas, nitrobacter. Two examples, if at all you can remember, that will be really, really good. Ma'am, you are beautiful. Thank you, bacha log. You guys are also beautiful. Now all my beautiful children, rather than talking hi Paras, hi Rani, hi this, hi that, please talk to me. Please understand things from me. It is definitely going to help you out. By the way, I am going fast because the chapters are pretty long in biology. If you have any doubts, please let me know, okay? Fine? Okay. Now, heterotrophic nutrition, my dear children, there are different types again. In autotroph you saw it's chemo and photo. In heterotrophic nutrition, okay, let me ask you guys a question. In heterotrophic nutrition, how many type of nutrition do you know? How many different types of heterotrophic nutrition are there? One example for this is parasitic mode of nutrition. Other examples, can anyone guess? Other examples or heterotrophic mode of nutrition? This is very important. 4 types. Okay, tell me the names. I want the names. One is parasitic. Apart from that, parasitic, holozoic and saprophytic. You says parasitic, holozoic and saprophytic. Okay, Pavani says parasitic. Okay, so 3 things I got: parasitic, holozoic and saprophytic, right? Yes, awesome, 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 Pavani, awesome, Mohinder. Okay, Vishal, awesome. Listen to me now, okay? in heterotrophic mode of nutrition, the first guy that we have over here is parasitic mode of nutrition. What happens over here? In parasitic mode of nutrition, there will be a host, a living host. Onto this host, an organism will be dependent. There are two types of parasite. For example, ectoparasite and endoparasite. Ecto means it stays on the body. For example, you might have seen lice, Jew we call it, on the surface of the head. They are ectoparasite. Similarly, apart from lice, we have something else also. On the dog, any dog lovers over here? In the case of dogs, they will have ticks. They will have ticks. Suppose you go for a trekking, a forest trekking, you will find leeches. Leech. They are all, my dear children, what? Ectoparasite. They are not going within our body. They are outside our body only. Fine. Now, endoparasites are there. Something that stays inside our body. For example, what? Tapeworm. Tapeworm is there inside our body in the intestine. Not everyone will have it, but I'm just generally telling you. Similarly, roundworm. They are all endoparasite. So, parasitic mode of nutrition basically means that an organism will be feeding on a living host out there. Okay, it derives nutrition from other host. Isn't it heterotrophic? Yes. Why? Because I'm depending on some others for my food. Got it? Perfect, right? Now the next thing that we have is saprophytic mode of nutrition. Here it is very, very simple. And listen, this is very important for you to know the understanding of it. So, suppose this is Baba mushroom. Yeah, over here it has the food, some tasty, yummy food over here. That means dead and decaying matter will be over here for the mushroom, right? Now the mushroom, do you think mushroom will open its mouth and will be taking it up? Do you think mushroom has a mouth? No, Baba. So what is going to happen? The mushroom is going to release some enzymes over here. These enzymes are going to break down the dead organism into small parts. And this, from the small parts that is there, some amount of nutrients are going to be absorbed. Some things are going to be absorbed, right? So here, where is breakdown of food happening, Baba? Outside. I will call this as, what do you call this as? Guys, everyone. Yes, absorbs nutrients. It is going to absorb the nutrients. It is breaking things down and is going to absorb the nutrients. Now, I was asking something. What was that? I forgot. Oh my god. Yeah. So basically, what type of digestion is this? This is known as external digestion. Why? Because the food is broken outside the body. This is happening in the case of saprophytic mode of nutrition. Every time the food breaks down outside the body, always remember the organism will be releasing some chemicals or some enzymes for breaking it down. The best example for this, anyone remembers the example for saprophytes apart from mushroom? Apart from mushroom, do you have any other example which is there in your NCERT and you should not be missing? External. Amoeba, no, amoeba shows different type of nutrition, not this. I'm talking about saprophytic, they're just releasing enzyme. Fungus, different type of fungus. Baba, mushroom is also fungus. So you have to tell the name of that fungus. Anyone? Bread mold, exactly, Vishal. Exactly oh my god, so many children are coming now. Perfect. Deet germs, okay. Penicillin, ayyo. Listen to me carefully. So bread mold which is there, bread mold, you also call this as rhizopus. This is a very important NCERT example. Do not forget this. Okay. So bread mold, which is rhizopus, also mushroom, also some different type of bacteria can act as saprophytes. Okay. These saprophytes are generally known as decomposers also. Why? Because they feed on dead and decaying matter. So always remember, under saprophytes, you have FB, Facebook. Facebook stands for what? Fungi and bacteria. And the most famous fungus that you have is bread mold or rhizopus. And apart from that, you also have mushroom. Both of them are fungi only. Do you understand it? Everyone who understood until this particular point, just give me a thumbs up. Everyone who got to understood this, just give me a thumbs up. The examples for all parasitic and all saprophytic is understood. Please give me a thumbs up. And saprophytic, they derive nutrition from what? Dead and decaying matter. This is very unique feature. Thank you guys. Thani Rani Gupta. Thank you Pavani for giving me thumbs up. Mohinder also. Perfect, dear. Okay. Yes, ma'am. Neetu and okay, Aisha, Shilpa. Thank you. Perfect. Now we have one more guy, right? Oh, by the way, I have a picture given. So, what is this picture of? Let me see. So, okay. Listen, So over here, I have this particular picture. Do you know what is this thing that you see? This is tapeworm. Where is it? Inside the intestine. So it is an endoparasite. Done. Now over here, I have another picture. What is this? This is a leech. Leech is actually this much only. You will not be able to see it. But when you walk around, it basically drinks our blood and becomes like this. It is leech. It is an ectoparasite. So I've shown you endoparasite. I have shown you ectoparasite. Now one more example is there. What is this? Anyone can guess this? This is also coming under parasitic mode of nutrition, and this is very, very important. Example for this. Amarbel, exactly, Neetu. Cuscuta, Yuv says Cuscuta, exactly. This is Amarbel, this is Cuscuta, this is Dodar, whatever you want to call it. This is a parasitic plant. Okay, example of parasitic plant is this. Exactly, Mohinder. Why is this very important? This is very important because, remember, this is the only plant parasite which is given in your NCERT. Why it is parasite? Because this particular plant does not have chlorophyll. No chlorophyll is there. If no chlorophyll is there, do you think it can photosynthesize its own food? No, Baba, it cannot prepare its own food. That is why it depends on the plant. Suppose there is a plant over here. Okay, suppose there is a plant over here. It will go use finger-like projections like this to get nutrients from the plant. And these finger-like projections which you have, you call this as hostoria. What do you call this as? You call this as hostoria. I think I have a picture of that. I'll be showing you that as well. Also, okay. So this particular Cuscuta is the only plant parasite, and this is the picture that I was talking about. So you see, this is the Cuscuta, and over here it has hostoria which grows inside the plant and takes in nutrients from the plant, which is why I'll call this as a parasite. Ma'am, I'm a new student. Hello, Ram Lakhan. Perfect. Okay. Guys, now we have the next type of, okay, there is a question for you guys, you can try to solve it. Organism who break down the food outside their body are. Organism that breaks down the food outside their body are. Option A is rhizopus, option B is virus, option C is tapeworm, option D is Cuscuta. What do you think is the answer for this question? Ma'am, doubt. Please guys, ask me the doubt directly. Nisha, you only think, okay, with these many chats going up and down, do you think I will be able to spot your doubt? Children, okay, I'll stop here and I'll take your doubts. Ask me, what is your doubt? By the way, everyone has given me the answer. Naman, Yuv, Nisha, Neetu Negi, Vishal and Pavani gave me the answer for this question, and they said the answer is A. Okay. Ma'am, can you call me Yuvan? Yes, I'll try my best here. Where is Nisha's doubt? Nisha's doubt I have not got yet. Okay. Anyways, it will be coming. Okay, so over here, my dear children, if at all you see, the answer for this question is A, as most of you guys said. Okay, it will be A, rhizopus, as most of you guys said, because A is a saprophyte. It is a saprophyte. Vishal, yes, dear children, ask me the doubt. I am here. I'm taking your doubt. A is the answer. Yes, exactly. Ma'am, I told A as the answer. Shilpa, perfect, dear. Okay, perfect. Ma'am, respiration, Ram Lakhan, I'll be coming to that also, okay? Okay, perfect. Chalo. My physics wali ma'am will also be coming in. Ayush, don't worry. This for all lesson, ma'am. Nisha, yes, I will be. Okay, perfect. Let me go ahead, okay? The next thing that I have over here is what? Holozoic mode of nutrition. So parasitic done, then we had what you call saprophytic, and now we are in holozoic mode of nutrition. In holozoic, what is going to happen? We are going to take the food inside the body. So are we, for example, we are showing holozoic mode of nutrition. Do you think we secrete enzymes outside the body? For example, I see a burger over here. Do I release some enzymes? No. I take the food inside and the food is broken inside my body with the help of some enzymes. This is known as holozoic mode of nutrition. Organism ingests the organic food material and breaks down the food inside the body. We humans come in this particular category, and this shows internal digestion. Apart from human beings, we have other animals also. For example, cow, for example, anything that you take up generally, okay, lion, whatever is there, it takes up the food and breaks it inside the body. Now, in your NCERT, there are two more examples given, that is about amoeba and paramecium. Amoeba and paramecium, they also show holozoic mode of nutrition. Hello, Mysterious. They also show holozoic mode of nutrition. So, I think I'll be going up to that first and then I'll come back over here. So, where is nutrition? Yeah. So listen to me, nutrition in amoeba. Since we're talking about holozoic mode of nutrition, let's talk about amoeba first and then we'll talk about the other things later on. So over here, this is amoeba and here is the food. Baba, always see the structure of amoeba. Inside this amoeba, you have lysosome, right? You have lysosome. These lysosome has so many enzymes. These enzymes can break down food. Okay, please know that. Now what exactly happens is that basically with the help of this thing that you call as what do you call this thing? What do you call this thing which is there over here, which helps in taking in the food inside? Anyone? What is the enzyme, ma'am? It can be any hydrolytic enzyme. You call them as lysozymes. Lysozymes, okay? Not lysozymes, basically any hydrolytic enzyme that can be breaking, digestive enzymes. You can just remember lysosome has some digestive enzymes out there. Pseudopodia, exactly, Naman. So basically with the help of pseudopodia, or you call this as false feet, they will be taking in the food. And now this process of taking in the food is known as what? Ingestion. This is the first step in the case of amoeba's nutrition. First step, right? Now the second step is what? Once the food vacuole is inside, the lysosome which is there, okay, which has so many enzymes, it will go and try to fuse with the food vacuole. Why is it fusing? Because it wants to break down the food which is there in the food vacuole, and whenever it tries to break down, I'll say this process is as digestion. The process of fusion of lysosome with the food vacuole for the breakdown of food. Finally, the food is going to be broken down, and the broken food is over here in the food vacuole itself. This is a digested food. So second step is what? Digestion. Now what is the third step? After the food is digested, my dear children, obviously the organism had the food for what? Taking in the important nutrients, right? So the next step is what? Absorption. So diffusion of nutrients from the food vacuole into the cytoplasm takes place over here. This is known as absorption. Okay, now after absorption, what is going to happen? Listen, children get confused between absorption and assimilation. Assimilation basically means whatever nutrients have been absorbed, those would be utilized for the organism's own purpose. That is known as assimilation. The process of utilization of nutrients for various metabolic activities is known as assimilation. Now everything has been done. It has been properly utilized. Now whatever is left behind, which we do not need as of now, the extra food which is there, it has to be removed out. And that is done through the process of egestion, the process of removal of waste. The food vacuole comes and fuses with the plasma membrane and would be removing it. Now, everyone who have understood this as of now, can you guys tell me what are the 5 steps? Okay, what are the 5 steps which are involved in the nutrition of amoeba? Everyone. In 5 steps involved in the nutrition of amoeba. Come on. Guys, oh my God. 5 steps involved in nutrition of amoeba. Vishal, taking in the food. So you have to tell ingestion and the list goes. Ingestion, absorption, assimilation, egestion. Mohinder, 1 step has been missed in between, Baba. Can you check? Ma'am, first one is injection, second one is digestion, third is absorption, fourth is assimilation, and the 5th one is egestion. Exactly. So instead of injection, no, the spelling is like this. It's egestion, okay? Ingestion. I-N-G-E-S-T-I-O-N. So make sure you write that. Paki, everything is perfect, Pavani. Perfect. Okay? Naman, ingestion, digestion, absorption, assimilation, egestion. Perfect. Okay. Mohinder, fine. Anyone single over here? I am single. Talk to me. Guys, what are you doing? Okay, chalo. नहीं सुधरोगे तुम लोग. Let's go ahead then. Let's go ahead. Everyone out there, let people who are talking. Ma'am, ingestion or excretion में difference? Ingestion or excretion? देखो, ingestion is basically happening in this organism where whatever food, unwanted thing is being removed. Excretion is what? Basically, excretion happens in the case of more advanced organisms out there. There, it's not just a food, it's basically anything which is not important. For example, some iron is not important, that will also be removed. Excretion of urine, in urine we see, right? So whatever, urea is not important, so it is also being removed. Here you're talking about undigested food out there, or basically the things which are not useful. Okay? Come on. Let's go ahead then with the next thing that is there. So apart from amoeba, there is one more organism which shows holozoic mode of nutrition, and that is what, Baba? It is paramecium. Have you seen paramecium? It looks like this. It looks like slipper shaped thing, chappal shaped thing. Okay, so over here, look at this carefully. What do you have? You have so many cilia. Why is cilia there? For the movement of the organism. Apart from that, suppose some food came and stuck over here. The cilia will be moving up like this. When it moves up, the food will be rolling on and going into the oral groove. So oral groove is like a mouth-like structure which is there. Okay, it's a groove which is there, and at the end there is a mouth which you call as cytostome, cell mouth. In this, again, the thing will be entering. Here, similarly, here also the same process. Ingestion, then digestion. Here also lysosome will be there. It will be fusing with the food vacuole. Food is going to get broken down. After that, it is going to be absorbed. After that, it is going to be assimilated, and then ingestion happens. Ingestion happens through the another pore which is known as anal pore. So just know about it. Usually it is not been asked, but please know. Yeah, hair-like projection, exactly, Ayush. Perfect. ठीक है? Okay. Okay, perfect, Neetu Negi, you are also correct. Ma'am, doubt. Yes, please ask me, Vishal, the doubt. So is this correct? Is this clear to you? Now, before we go into the nutrition of human beings, I want to come back over there again. So why did I explain you about all that? Because first of all, my teacher, we spoke about nutrition. There are two types of nutrition. We spoke about autotrophs and heterotrophs. In autotroph, you have chemoautotrophs and photoautotrophs. Then we spoke about heterotrophs, that is parasitic, saprophytic, and holozoic. In holozoic, I have explained you two organisms, but apart from that, we have human beings also. We will complete it separately. As of now, let's come back to autotrophs and let's talk about basically how photosynthesis and everything occurs. Are we ready for photosynthesis? Alimentary canal basically is the tract through which the food is going to pass down, my dear children. Okay, everyone clear? Let's go ahead. So everyone who thinks that we can go ahead with photosynthesis, just give me a quick thumbs up. Just give me a quick thumbs up. We will go ahead with photosynthesis. Okay? Thumbs up. I need a thumbs up. Before all this crowd who is talking to each other, if there is someone to talk to me, just give me a thumbs up. I will. Okay, thank you, Vishal. Perfect, Starry, and perfect, Pavani Putri. Okay, fine. Yes, ma'am. Let's go ahead. This is very, very, very important. Okay? So, photosynthesis basically needs light. Photo means about light and synthesis means formation. But what is getting formed over here? Baba, food is getting formed over here. What is food over here? Glucose, which is also known as C6H12O6. Okay? In the case of plants, the glucose which is going to be formed by dear children are not stored in the form of glucose only. They are going to be stored in the form of what? Starch. Always remember. In the case of animals, how is glucose being stored? Suppose we take the plant, we eat the plant, we get the glucose. In our body, how is glucose going to be stored? Anyone, any idea? In plants, it is starch. In the case of animals, it is what? In the case of animals, it is what? Oh my God. No one knows the answer? Glycogen, exactly, Venom. Exactly, it is glycogen. Okay, always remember glucose is going to be stored in the form of glycogen in the case of animals. In the case of plants, it is starch. Okay, fine. Now, and it's easy. It's actually easy. When I say this formation is happening, it's actually easy. Let's see the steps one by one. So first thing, you need to know the formula of it. 6 CO2 plus 12 H2O gives C6H12O6 plus 6 O2 plus 6 H2O plus some amount of ATP out there. Sunlight and chlorophyll are the two essential things which you require over here. How do you remember the balancing if at all you forget the balancing? Listen, here you have 6, here you have 12, right? So 6 remains 6 over here, carbon is 6 over here, also perfect. You do not need any balancing. This particular 12 you have to break between O and H2. So basically 6 over here, 6 over here, 6 plus 6, 12. Done. That's all. Okay, now, does oxidation and reduction happen over here? Does oxidation, little bit of chemistry, okay? Listen to me very carefully. Listen to me very carefully. So over here, does oxidation and reduction happen? The answer is yes. Reduction means basically means gaining of hydrogen. That is what you mean by reduction. So here Papa guy was CO2, right? This CO2 gained some hydrogen and now it is C6H12O6, my dear children. So reduction of CO2 happens to what? To glucose. Reduction of CO2 to glucose happens over here. Fine. What about oxidation? Does someone lose hydrogen? Yes. H2O was there. It lost its hydrogen and now it is what? Oxygen only. So oxidation and reduction both happens in the case of photosynthesis. That is very important. Now listen, apart from all these things, sunlight and chlorophyll that is required, you need nitrogen also, and nitrogen is taken in which form? This is an MCQ question. I made you solve this question. This is from your NCERT. So in which form is nitrogen being taken up? Nitrogen is taken up in the form of inorganic nitrates and nitrites also. Inorganic nitrates and nitrites. This is very, very important. Inorganic nitrites and nitrates. Apart from that, you need other things, for example, phosphorus, iron and magnesium. Phosphorus, iron and magnesium. These are the few things that you would require for the process of photosynthesis to happen very, 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 very smoothly. Okay, nitrates and nitrite. Exactly, Neetu Negi. Cool? Cool. Fine. Now, if we see the steps, listen to me carefully. All this is happening inside the leaf, and if at all there is a leaf and I'm cutting it like this and I'm seeing the sideways view. If I have leaf, I've cut it and I see the sideways view. How it will look? It will look something like this. You have upper epidermis, you have lower epidermis. In the lower epidermis, my dear children, you will be having more number of stomata. Why? Because upper epidermis is close to sunlight. Wherever sunlight falls on it, probably water will be lost immediately if at all more stomata is there. So since we want water not to be lost, we have more of the stomata towards the lower epidermis, right? Apart from it, what do you have, Baba? You have palisade mesophyll and also spongy mesophyll. This is a super important question for everyone who is going to write the examination. Listen to me carefully. Palisade mesophyll, which is there, it is rectangular, it is very close to each other, okay, and it has lots and lots of what? This thing which is chloroplast. If it has chloroplast, that means it has what? Lots and lots of what? Chlorophyll pigments also. It will be having lots of chlorophyll pigments. Now the chlorophyll pigments which are going to be there, will it help in photosynthesis? Yes, Baba, it will help in photosynthesis. Okay, ma'am. So, ma'am, only in palisade mesophyll photosynthesis is going to occur? No, Baba. If at all you see this, you have spongy mesophyll also. Spongy mesophyll have so much space in between them, the cells. They also have chloroplast within them. So, ma'am, you're saying only between this and this photosynthesis is going to happen? No, Baba. One more thing is there, that is your guard cell. The cells that guards your stomatal pore, my dear children, they will be also having chloroplast. So, ma'am, now 3 of them are going to do photosynthesis? Yes. But which one is going to do the maximum amount of photosynthesis? Which one is going to show the maximum amount of photosynthesis? It is going to be palisade mesophyll. Okay, palisade mesophyll will be having the highest number of photosynthesis amount, then comes spongy mesophyll, and then come guard cells. This is an important thing. Okay, please remember this. And now, as I said, we will talk more about the 3 events of photosynthesis or the actual photosynthesis. Remember, photosynthesis is divided into 2 things, light reaction and dark reaction. Light reaction and Baba, dark reaction. Okay, but until this, have you understood before I go ahead? We studied about photosynthesis chemical equation. We studied that what all do you require apart from sunlight and chlorophyll. We require nitrates, nitrites. Okay, we require phosphorus, we require iron, we require magnesium. We studied about palisade mesophyll. It shows highest amount of photosynthesis. Then comes spongy mesophyll, right? And now we are going to talk about the 3 events of photosynthesis. Until now, if at all everything is clear, can you give me a thumbs up? If everything is clear, can you give me a thumbs up? I'm asking for that since lots and lots of children are like just talking. I'm not able to understand who is listening, who is not. Pavani, thank you so much, dear. Ma'am, you are beautiful. Thank you, dear. You are also beautiful. Neetu Negi also gave me thumbs up. Thank you, thank you, thank you. Okay, perfect. Let's go ahead then. Okay, fine. Himanshi, thank you, dear. Okay, so 3 events of photosynthesis goes like this. There is light reaction, dark reaction. Light reaction means, Baba, it will happen only when light is there. Only when light is there. Dark reaction will happen when light is not there. Wrong. Dark reaction does not require light essentially. So it can happen in the daytime, it can happen in the night time. It just means that it can happen without light also. That is why we call this as dark reaction. So listen to me. Light reactions are light dependent, agreed. Dark reactions are light independent, agreed. Okay, location, where does it happen? Location, if at all you talk about it, if this is the chloroplast, these things that you see over here, okay, which looks like coin, this is known as a thylakoid. This is a thylakoid. The thylakoid stacks together to form what? To form a grana. And where is it located? Inside the stroma. Inside the stroma. So your light reaction is going to happen in the thylakoid. Your dark reaction is going to happen in the stroma. Know that. So over here, light reaction, when I say it happens in the thylakoid, and the dark reaction happens in the stroma. But what exactly happens, ma'am? You're not explaining that. So listen to me carefully. Over here, the first event that happens is absorption of light energy. Remember, in thylakoid, inside the chloroplast, inside the thylakoid, you have chlorophyll pigments. These chlorophyll pigments will be helping in absorbing the light from the sun. This is going to be the first event, absorption of light energy from by the chlorophyll pigments. Okay, now what happens with the light? Does the light do anything? Yes. Light, my dear children, is going to be responsible for photolysis of water. What? So water which is there, H2O which is there, my dear children, since I absorbed light, this light is going to fall on H2O and it leads to photolysis. Photolysis means in presence of light, there will be breakdown of something out there. Yeah. Now this will be leading to what? And okay, this is one thing that is there, photolysis of water. When you do photolysis of water, my dear children, the H2O is going to get broken down. It is going to get broken down to what? Hydrogen and oxygen. And this is exactly how you get oxygen being released in photosynthesis. When I say that this is a reaction, CO2 plus H2O gives C6H12O6 plus O2. Where does this O2 come from? O2 comes from H2O. How does it come? With the help of photolysis of water. Second event that is occurring is what? Photolysis of water. But along with it, one more very important thing happens. The light energy that we have taken up, yes, it helped in photolysis. It also is converted to something else, which is known as what? Chemical energy. And by chemical energy, I mean what? I mean ATP, I mean NADPH and things like that. So basically, I have converted the light energy which I have dropped into what? Chemical energy. But ma'am, why do we require chemical energy? Chemical energy is required for dark reaction to happen. What happens with the chemical energy? The chemical energy which is made over here is used for reduction of CO2 to carbohydrate. That means when I say CO2 to C6H12O6 has to be formed, it means that you need energy. Where do you get that energy from? From the whole process that is happening over here. Did you understand it? So 3 events of photosynthesis is what? First one, absorption of light energy by chlorophyll pigments. The second one is what? Photolysis of water, and also conversion of light to what? Chemical energy. This chemical energy is used up over here for reduction of CO2 to what? Carbohydrate. The gaining of hydrogen by the CO2 to form carbohydrates. Is this clear? Is this clear? Okay. Naruto is life. Naruto is life is the best child over here, should be getting an award. Okay, dare you talk to me like that, and the next time you will get the consequence of it. So bye bye, my dear Naruto. I hope you have a good day. Yes, fine. Let's go ahead. Is this clear? Children, 3 events of photosynthesis. I hope it's clear. Yes, guys, listen, whatever is given on the screen about photosynthesis, that much is enough. You do not need to know anything extra about these 3 steps, Okay, I hope it's clear. Okay, let's go ahead. Thanks. Thank you for telling me it's clear. Now, the next question is, if the plant does not receive light energy, will dark reaction happen? What do you think? If the plant is not receiving light energy, do you think dark reaction is going to happen? Do you think it is going to happen? Ma'am, is thylakoid in the chloroplast? Yes, it is there in the chloroplast, Baba. We saw, no? If at all we see the structure of chloroplast, this stack-like thing, the coin-shaped thing which you see is thylakoid. Thylakoid forms the grana, okay? So please know that. Yeah, where were we? Yes, ma'am. So someone says yes, ma'am. What if the plant does not receive light energy? Will the dark reaction happen? The answer is no. It requires light energy. Always no. Without light energy, how will you form chemical energy? If chemical energy is not there, how do you think dark reaction can happen? That is not going to happen, right? That is not going to happen. So light energy should be there somehow. At any time, it should be there. Okay, it's not like dark and light and dark reaction will happen together always. There are chances that light can happen only in the daytime and dark will happen only in the night time as well. We'll see examples for that, but always understand light energy is required because you need chemical energy and you get that from light energy only. Got it? This is very, very important. Now we come to one question, that does these steps occur one after the other in all the plants? When I say 3 events of photosynthesis, does this occur one after the other in all the plants? The answer is no. For example, we have a cute cactus plant over here. In cactus, my dear children, you know they live in desert. They are already passive organisms. They do not have enough amount of water and all. Okay, so they cannot afford to lose water anyhow. So what do? They do not open their stomata during the daytime. They cannot open their stomata during the daytime. They keep it closed only. Okay. So in that case, how do they take the CO2? You need the CO2 for photosynthesis to happen, right? For photosynthesis to happen, you need CO2, right? So what do they do then? So what they do is that at night they open the stomata, okay? At night they open the stomata and basically they take in CO2 and convert into something else which you call as malic acid. So we say that the CO2 is fixed at night. So they are keeping the CO2 ready. Now in daytime, my dear children, when you have light energy, you will convert the light into chemical energy, and this chemical energy will now act on CO2 for helping in reduction for forming C6H12O6. So what is different over here? The difference that you have is stomata mostly opens at night, and also remember the CO2 which is taken up, it is not going to be utilized quickly, since at night you do not have light energy. You need chemical energy and you get chemical energy from light energy only, so you have to wait until the daytime. And how do you store the CO2? In the form of malic acid. Later in the daytime, when you have enough amount of light energy, that light energy will be converting into chemical energy and helping in the process to happen smoothly. Got it? This is, ma'am, how do they get sunlight? Baba, they are staying in desert, so they will definitely get sunlight in the daytime. Right? Yes, Nitun, yes, this is the intermediate product that you get. Yuvan is saying that makes an intermediate, and this intermediate is used in night. Is malic acid the intermediate? Yes. Yes, we can consider that to be the intermediate. Yeah? Perfect. Okay, so is this clear? This is about cactus. Now we have one more thing about plant that is left behind, and that is stomata, Baba. Stomata. How do you think stomata opens and closes? You know, stomata has one very important thing, that is guard cells. Before I go ahead with that, I just need you to understand this very important thing. A guard cell is a very normal cell. It will have its own nucleus. Okay, it will have nucleus. It will also have chloroplast. It will have chloroplast. Since it is a plant cell, it will have a very big vacuole. It will have very big vacuole and everything, just like a normal plant cell, right? Now the stomata which is over here, it is surrounded by one very the guard cell which is over here, it is surrounded by one very important thing which you call as subsidiary cell. Subsidiary cell. Please remember that also. It is known as subsidiary cell, which is very, very important, right? Now this is a basic idea. Now we will come to this. Let's talk about what is happening over here. So when enough light or low CO2 is there, okay, when low CO2 is there, low CO2, that means we want more CO2. Where do we get more CO2 from? From the atmosphere. That means we want to open the stomata, right? At this particular point of time, proton pumps open, H plus ions moves outside. So listen to me very carefully. Inside the guard cells, you have so many hydrogen ions out there. Hydrogen ions are going to be moving outside. As the hydrogen ions move outside, what is going to happen? My dear children, the K plus ions which are outside, the potassium ions which are outside, they get inside. They will be getting inside. When these guys move outside, they get inside. Now you only think, when they get inside in too much amount. Okay, that means I'll say the amount of solute is very much over here. The amount of solute is very much over here. What about the solvent? Solvent is what? Water. Solvent is going to be less. Solvent is going to be less. Since solvent is less over here, I'll say that it is hypertonic situation that is being created over here. Solute is more, solvent is less. What is going to happen? From outside, water is going to move inside the guard cells. Water will be moving inside the guard cells. Now suppose water gets inside the guard cell, what is going to happen? The water comes inside and the guard cells, my dear children, they were like this, they will be moving up like this, right? Because they are getting swollen. Now when they are getting swollen, what is going to happen? It will be opening up. So I'll say this particular stage is what? It becomes turgid. It becomes turgid, and that is when stomata is going to open up. This is very, very important. Listen, how do the ion channels open up when it knows that the plant is not having enough amount of CO2? So there is a hormone inside the plant's body. Anyone, can you guess the name of the hormone? Anyone, can you guess the name of the hormone which is there, which makes the plant do all this thing? The proton pumps become active. Turgid and flaccid condition, exactly, Nidunegi. Anyone knows the name of the hormone that causes all this thing? I'm asking that. Auxin? No, Baba. It's not auxin. Remember, in the case of plants, you have a stress hormone. You guys have studied it. It's not auxin, it's a stress hormone. What is a stress hormone? Abscisic acid, ABA. Abscisic acid is a stress hormone. So when a plant is under stress, that means it does not have enough amount of CO2. The abscisic acid becomes active, and that is the one that will give signals for the proton pumps to open up, so that the hydrogen can move out and the potassium can get in and increase the solute concentration over here, leading to water getting in. So it is ABA, do not forget it. This is very important. Yes, abscisic acid. Exactly, Razia, and exactly Santoshi, and I'm seeing Yuvan. Okay, perfect. So if I missed Aman, I'm so sorry, because so many things I need to perfect. Okay, now next thing that we have is what? How the stomata close. Similarly, when there is no light or excess of CO2, when there is too much amount of CO2, we do not need it. We need to move it out. Okay, so what do? Again, the potassium which just got in, my dear children, it will be moving out. Now the solute concentration is going to be more over here. Solvent is what? Solvent is less over here, because solvent was there inside. So since the solute is over here, the solvent will also move outside. H2O molecules will move outside. When it moves outside, my dear children, from the turgid condition, it comes back to shrunken state. You call this as flaccid condition. You call this as flaccid. So please remember this. And now it will be closing up. Okay, now it is going to be closing up. Is this clear? When there is loss of water, it will be closing. When there is gain of water, it will be opening. So for everyone who thinks that it is absolutely clear, can you just give me a quick thumbs up, and then we will move on to the next thing. Yes, ma'am. Thank you. Thank you, Neetu Negi. What about others? Children? Pavani also, thank you. Mohinder, okay, perfect. Sanjana also, perfect. Okay, Santoshi, Sheila, oh my God, I'm seeing children who are actually studying. Perfect. Let's go ahead. By the way, everyone who is watching this video, have you clicked on the like button? If not, click on the like button, click on the share button, and subscribe to the channel if you're very new. Okay, perfect. So there is one experiment that is given in your NCERT that also we will discuss. Experiment for importance of carbon dioxide. How did you get to know that carbon dioxide is also important for photosynthesis? Basically what was being done over here is that there was a setup being done where there's a plant. Okay, there is plant and there is water and everything being kept over here in two conditions. Okay, and it's a closed condition. It's a very closed condition that you have over here. Now what you do is that you are going to basically, so when the plant gets sunlight, the plant will produce what? The plant, when it has sunlight, is basically with the amount of CO2 which is already over here, CO2 plus water, which is over here, okay, along with the sunlight, it will be doing photosynthesis. It will be doing photosynthesis, right? Now, basically, the end result will be C6H12O6 plus O2. Now, this C6H12, that is glucose that is being formed, that will be broken down again, and when it is broken down, you get CO2. So, photosynthesis happens, respiration happens, and that's how it goes on. But in this condition, suppose, my dear children, in this water, I am mixing something else, or probably instead of water, I am keeping a plate, which is having KOH. KOH is what? Potassium hydroxide. It is what? Potassium hydroxide. What is going to happen? What is going to happen if I am keeping potassium hydroxide? Baba, it will be taking in all the carbon dioxide, absorbs all the carbon dioxide. If carbon dioxide is absorbed, do you think photosynthesis is going to happen over here? No, which is why there won't be any photosynthesis taking place over here. Rather, on this particular case, photosynthesis is going to happen, starch is going to be produced as well. So please remember, CO2 का supply cut हो जाएगा. Exactly. So CO2 will be absorbed by this particular potassium hydroxide, and this proves the importance of carbohydrate. Sorry, this proves the importance of carbon dioxide. Now we have one more experiment, and that is showing the importance of chlorophyll. It shows the importance of chlorophyll. So what do you do is that basically you have a leaf that looks like this. Variegated leaf. Variegated leaf means at some places it will be green, at some places it will not be. Yeah? There will be yellow area, there will be green area. Suppose. Now, what do you do is that you do the starch test. When you do the starch test, you have multiple other processes in between, but I'm just telling you the, just the easiest thing that is there. When you do the starch test, you get to understand that in some areas it gives blue-black coloration. Why? When I'm putting iodine, and some areas it gives blue-black coloration. Why? Because there photosynthesis have taken place, carbohydrate is being produced. So listen to me. When the iodine comes in contact with the starch, that's when you get blue-black coloration. That's when you get blue-black coloration. Over here in the green part, my dear children, what is happening? You have the starch. You have the starch, which is why, because why? You have chlorophyll. The chlorophyll will be helping in photosynthesis. That is how you get the starch, which is exactly why in this particular case you will be getting blue-black coloration. Whereas the other areas where there are no chlorophyll, there won't be any starch production. Since there is no starch production, do you think there will be blue-black coloration? No. Which shows the importance of chlorophyll. Wherever chlorophyll is there only starch production will be there. Wherever chlorophyll is not there, their starch production is not going to be there. This is very, very important. Then these are the two experiments which are there for the things. Now, just a second, okay? What is going to be close? Okay. Okay, guys, can you try this question? Over here, it goes like this, okay? So this is fourth, this is third, and over here you have something in green. This is going to be second. This is going to be second. Can you tell me what is what? From the options given over here. From the options given over here, can you tell me what is the answer for this? Dushyant says the answer for this question is B. Okay. What about others? Nasan also says it is B. Okay. Neetu Negi says C. Baba, check. Sorry also says C. Guys, check the question carefully and then only tell the answer. Sharifa also says it is B. Listen, first one that you see over here is a small round. If at all you're not able to see that, let me draw that up. This is going to be the nucleus. This is going to be the nucleus. So first one is nucleus, so I can cancel out these options because here the first one is chloroplast and vacuole, right? Second thing is a green color thing. Green color thing has to be a chloroplast. It's the same in both the cases. Fine. What is the third thing? Third thing is a very big cell out there. That has to be what? Not big cell. Basically a very big organelle out there. What is this big organelle? It is going to be the vacuole. That is it occupies 95% of the whole plant cell out there. Now what do you have? You have this whole cell being marked, and that is going to be guard cell. So your answer for this question is going to be B. It is going to be B. Okay, perfect, clear? Now So we have officially completed everything that is under plants. Now everyone who have got who have an understanding of everything about plants, can you just quickly give me a thumbs up? Everyone who understood everything about plants, can you just quickly give me a thumbs up? Exactly, Nutunegi, I also get it. Super ma'am, thank you. Okay, Pavani Puri and Sharifa Banu, give me heart to you also. Okay, Nidunegi, okay, perfect. Thank you guys. I do not know how to pronounce it. NSAN beauty. Okay, Shilpa also gave me thumbs up. Santosh. So I see a lot of children are watching the video, and you guys are being very consistent also. I'm seeing Mohinder, I am seeing certain names from very start. Perfect. Let's just make sure that all the other children who are talking, let them realize they are losing out on something very important, right? Yes. Let's go ahead then. Okay. Now let's talk about. Listen, we spoke about holozoic nutrition. First example was of amoeba. Second example that we have was of paramecium. And now the third thing that we have is of human beings. And human beings example is very, very important. So you have to listen to me carefully. Okay, I'm going to talk in one stretch, and obviously that is going to help you. I'll just drink some water. Okay. Guys, you are having some water and food and things like that. Please have it, okay? Please have that. Okay. Perfect. Let's go ahead then. This guy that you see over here is what? His name is Pappu. And let's see what does Pappu is going to eat. So Pappu, when he eats food, my dear children, it goes to the mouth, right? From the mouth, it will be, so listen, this is the mouth, and this opening that you have over here is the buccal cavity. This is going to be the buccal cavity. Here you have nasal cavity, right? You have the nares, and the nares will be opening into what? Nasal cavity. All of them are going to come over here. What is this region, my dear children? Where the buccal cavity and the nasal cavity joins. This is going to be your pharynx. This is the pharynx. Now from the pharynx, again you have two diversion. One goes to the lungs, that is known as windpipe. One goes down, and that is your food pipe, right? Food pipe, you also call this as esophagus. It is also known as esophagus. Now the food which is there, it goes to the stomach. It goes to the stomach. From the stomach, it is going to what? Going to your small intestine. From the small intestine, it will join back to your large intestine. And in between that, you have some very important things. These are known as accessory glands. Okay, these are the glands involved in digestion, and that is your liver and also your pancreas. That is your liver and also your pancreas. All of them together are going to form what? Your gastrointestinal tract, or you also call this as your alimentary canal. Your alimentary canal. Okay? Clear? Now listen to me. We'll go one by one. What happens in each of them? First is your mouth. So in mouth, my dear children, you have saliva, right? We all have saliva in the mouth. What do you think saliva is having? Saliva has bicarbonate ions. Okay, what does it provide? It provides a neutral media. Suppose we have some acidic food, suppose we had some alkaline food, we have to make sure that everything is converted into a neutral medium, and that is why we have bicarbonate ions to neutralize it. Second thing that we have is lysozyme. You might have seen when someone get pimples over there, your mothers and all, okay, previously they used to sell that, put some saliva onto the top of the pimple. Why? Because it has lysozyme. You should not be doing that as of now, because your hands and everything is not clean. But listen to me carefully. What is the use of lysozyme? It is the one that is going to break down the walls of a bacteria and things like that. It is an enzyme that is going to kill the pathogens. Okay, so that is also there. Third thing, and the most important thing that we have, is salivary amylase. Salivary amylase is also known as ptyalin. You do not need to remember it, just know it is salivary amylase. So Baba, your mouth has saliva, your saliva has what? Bicarbonate ions, that is for neutralizing, lysozyme, which is there for basically killing the pathogens, and salivary amylase, that is the first enzyme that you have, which is why I tell that your digestion is going to start from the mouth itself. That is the first point of digestion. What is going to happen over here? The starch which you are taking in, the food that you are taking in the form of starch, my dear children, it is going to be broken down to maltose. It is going to be broken down to maltose. And it happens almost around a very neutral pH. Who provides neutral pH? Bicarbonate ions provide the neutral pH. What is the name of this enzyme? Salivary amylase. Do you think all the starch have been broken down? No, Baba. Some starch have been broken down to what? to maltose. Shafida, tell me dear, what are you not able to understand? Shahida, sorry. Others are able to understand what I am trying to teach? Okay, I think it's just salivary amylase is something that you're not able to understand. Yes, ma'am. Others are understanding. Okay, so anyway, I'll explain. Salivary amylase is an enzyme that is found in our saliva and that is responsible for breakdown of starch into what, Baba? Maltose. Starch is a complex carbohydrate. You're breaking down to simple carbohydrate, that is maltose. It occurs at a pH that is 6.8. This is the first time digestion has ever taken place and that happens in our mouth itself. Okay. Now the food which is there, it will be going to what? It will be going to your food pipe. Through what? Through the pharynx, which is right over here. Now when I say it goes to the food pipe, you need to understand you also call this as esophagus. Now once it reaches your food pipe, Baba, food has to go down. How will it go down? Can it go down on its own? No. You need peristalsis. Peristalsis is basically what? Involuntary contraction as well as relaxation. Involuntary, your particular muscles out there in your esophagus is going to contract, relax. And when that happens, my dear children, food will be going down into what? Into your stomach, which is going to be the next place for your digestion. So salivary amylase, I hope that is super clear to you, right? Yeah, peristalsis is what you call it. Exactly. Perfect, Mohinder. Now listen, once it is there in the stomach, okay, once it is there in the stomach, in your stomach you have multiple different type of cells which lines up the stomach. I know it will be too much difficult for you to know the entire thing, which is why just listen to me. What is important, I'm going to talk about that. Your stomach will be having HCl. Why HCl, Baba? For creating an acidic environment. First is that. Second is to directly kill the organism. Kill the pathogens which comes along with the food. No, that is why we have HCl. Now since HCl is being produced, which is an acid, you need to protect your own cells from attack, right? Which is why you will be having a lot of mucus being produced. Lot of mucus is being produced over here, just a second, in your stomach. So this is the first thing, this is the second thing. Now the third thing that is there is pepsinogen. Is what? Pepsinogen. This is also very, very important. When I say that HCl provides acidic medium for what? For the activation of an inactive enzyme. An enzyme is there, but it is in inactive form. You have to activate it into what? Into pepsin. And for that, you need what? You need an acidic pH out there. Who provides it? It is HCl who provides it. Okay, ma'am, what does this pepsin do? Why are we making this? The pepsin is the first enzyme to act on what? Proteins. So until now, carbohydrates was being dealt. Carbohydrate was being broken down inside your mouth, right? Now, pepsin which is there, it is going to act on what? Protein. And it is going to break down the protein into what? Into amino acid. But not entirely. Not complete digestion of proteins happens here also. Okay. You have to wait for some time such that the complete digestion of protein happens. So until now, all this thing was happening. Clear? This is very, very important. Stomach is also done. In stomach, you have HCl, you have mucus, and also pepsinogen. HCl provides acidic medium. Apart from that, it kills the pathogen. Second thing that is there, it is basically releasing mucus. It is basically releasing mucus such that your stomach walls can be protected. The third thing is production of pepsinogen. It is an inactive enzyme. You have to activate it by giving an acidic medium. Okay? Now, the pepsin which is being made, pepsin which is there, it is going to act on protein. Okay, it is going to act on protein. Done. Now we go to the next thing, and that is your pancreas and the other digestive things. Listen to me carefully. The food which comes from the here is going to be acidic. Yes or no? It is going to be acidic. Now, the enzymes which are there in the pancreas, if at all you want these enzymes to act on the food, you have to make sure that the food is made alkaline. But how can it be done? Who is responsible for making it alkaline? And here comes the role of liver. So your liver, which is right up over here, my dear children, is going to release something that is known as bile juice. It is known as bile juice. And your bile juice are going to be stored somewhere which is known as gallbladder. So gallbladder is just right beside the liver out there. and the liver, whatever thing is being released over here, that is bile juice, is going to be stored in the gallbladder. But why is bile juice important and what does it do? What is it made up of? Bile juice is made up of bile salts and bile pigments. It is made up of two things, bile salt and bile pigments, and both of them are super important for two very important things. One is to make the food alkaline. One is to make the food alkaline. Why alkaline? Because I told you the food from here comes to be acidic. The pancreatic enzymes cannot act on it, which is why you need to make the food alkaline. Second and the most important thing that you need to remember is emulsification of fat. That is basically breakdown of fat. Listen, the fat which is going to come, the food that we have fat, no, which is going to come, that is going to be like this, big globules is going to be there. Now suppose an enzyme wants to break down the fat, it is going to be very difficult, right? But now suppose I am breaking it down already into small units of fat. Don't you think that basically enzymes can act on it? Don't you think that enzymes can act on it now very easily? The answer is yes. The answer is secretly going to be yes, right? Because you get more surface area, and that is exactly what you mean by emulsification of fat. Breakdown of larger fat globules into smaller fat globules. Now what? Now these pancreatic enzymes can easily act on the fats also. Ma'am, do they act on fat? Yes. So listen to me. Pancreas in general are going to release some enzymes, and three of these enzymes are super important. Okay, the first one that we have is pancreatic lipase. Lipase as in it is going to break down lipid as in basically fat. So now this pancreatic lipase which is there, it can easily act on fat. Why? Because we have done emulsification of fat. So listen to me, food when it comes down the liver will be acting on it and breaking down the fat. The pancreatic enzyme will be acting on the broken fat, right, with the help of pancreatic lipase, and it will break down the smaller fats to even more what you call smaller units. Fine. The next thing is pancreatic amylase. You know you had salivary amylase inside your mouth, right, which was breaking down starch into maltose. Similarly, some amount of starch will be still left. You have to break it down again. So starch to maltose is done by pancreatic amylase. Now, there is protein that is being digested in the stomach, but still some proteins are left to be digested. Who does that? It is going to be done by pancreatic trypsin. So pancreatic trypsin is going to break down what? The proteins. It is going to break down the proteins into what? Peptides. So three enzymes are there, but for these three enzymes to act, you need alkaline pH. Who provides it? The bile juice of the liver. Apart from that, if you need pancreatic lipase to act, you also need to make sure that the fat has to be broken down. Got it? This is very important. Okay, this is going to be very important. Now, if you go ahead, by the way, until now, is everything clear? Until now, is everything clear for everyone who is genuinely watching this video? We have studied about what happens inside the mouth. We studied what happens inside the stomach. We studied what happens inside, or what do you call, inside this particular space that you call as duodenum. So stomach basically opens into duodenum of the small intestine, and that is where pancreatic enzymes and the bile juice and everything happens. Okay, perfect. Thank you, Nitinegi. Okay, we'll go ahead with the next thing that is out there. Yes, ma'am. And also thank you, Pavani Putri. Okay, perfect. Now we come inside the small intestine. In the small intestine, it is made up of duodenum, jejunum, and ileum. Okay, and small intestine, if at all you look, it looks like this. If at all I zoom in the small intestine, it looks like this. If I zoom in again, it looks like this. What is this? The innermost lining, my dear children, it is in the wave form of thing. Out on the top of that, you will have something else, which is finger-like projection. What is this finger-like projection, Baba? This is going to be known as villi. And if at all I zoom the finger-like projection, it looks like this. On the finger-like projections, my dear children, the green thing that you see over there, on the top of it, you have certain cells being arranged, and these cells are like this. These cells which are being arranged, my dear children, it looks like this. So basically on the villi you have some structure like this, basically a cell that is having a microvilli. It will be having microvilli. So you think of this scenario, my dear children. This is super crazy. We are doing differentiation again and again. Now listen to me carefully. In between two villi spaces, there will be some space over here, and from the space, lot of enzymes are going to be produced. Now these enzymes are going to do what? The final breakdown of food. Yes, the food was broken down until here, until this particular point of time. Now we are going to break it down again. So the final breakdown of food happens over here, and when the final breakdown of food happens, you need someone to absorb it. Who helps in that? Microvilli helps in the absorption. There is too much surface area now, so it can absorb it. Similarly, villi will also help in absorption. The food which is there will be now going into what? Your blood vessels. From your blood vessels, it goes to the entire body. So what do you mean by that? Where is the final digestion happening? The final digestion of food happens in the small intestine. And please remember, this is very important place. The final and the complete digestion happens in the small intestine. Okay, and over here, one very important thing that you need to remember is that, what was that? In the case of herbivores, okay, in the case of organisms that eat plants, their small intestine is going to be super long. Why? Why they have super long small intestine? Because plant is what they eat, and the plant is made up of what? Cellulose, and the breakdown of cellulose needs very long time, which is why you have a longer small intestine, such that the breakdown happens properly in the case of what? Herbivores. So if at all the question is asked why the small intestine is longer in the case of herbivores, it is because of this particular reason. Okay, and also remember, what are the things that are being broken down into what? Carbohydrates, which is there. Carbohydrate which is there, it is broken down to simple sugars. Simple sugars. What do I mean by simple sugars? For example, glucose. Okay. Second thing, what do you have? You have fat. Fats are broken down to fatty acid and glycerol. So glycerol and fatty acid come together to form a fat. Okay, now you have proteins. Proteins, what are they broken down into? Proteins are broken down to peptides. Peptides which are there, which are broken down into amino acids. So now in the small intestine, what all do you get? You get glucose, you get fatty acid plus glycerol, you also get amino acid. All this breakdown happens in the case of small intestine only. Okay, perfect. So ma'am, what happens in the case of large intestine? Large intestine, my dear children, is super important for one very important thing, and that is reabsorption of water. There is no digestion that happens in the large intestine, only reabsorption happens there. Okay, only reabsorption happens there of water. So listen, if at all large intestine is not doing its job properly, what you will have? You will be having loose motions with too much amount of water loss, right? So this is a general thing out there. Cool. Works. So yes, until now, is it clear to everyone out there? Is it super clear for everyone out there? Hi Divyanshu. Hello. Okay, peptones. What is peptones? It is also an intermediate substance that is being formed when the breakdown of protein happens. Okay, guys, I hope it's clear. Let's go ahead then. Everyone who feels it's clear, thank you Neetu Negi and everyone for giving me thumbs up. I'll ask once more, okay, once this is also been done. Listen, what's the problem when we do not brush our teeth properly? I'll tell you about the problem. So if you see the teeth, it looks like this. You have the enamel coating outside, the outermost thing, yeah. Inside that you have dentine, inside that you have pulp. Pulp is a place where you have your blood vessels and everything out there, yeah. And suppose what is going to happen is that, suppose a dental plague is being formed. What do you mean by dental plague? Dental plague is basically mass of your bacterial cells along with the food particles. You might have seen yellow in color, it is there, right? So this would be entirely round over what? The teeth outside. Fine. Now what is the problem if at all someone has a dental plague? The problem is that basically these bacteria which is there, it is going to release some, it is going to act on the sugar that is there on the food and is going to produce some acid. These acids are going to destroy your enamel out there. Listen to me carefully. Bacterial cells were feeding on the food particles. While they feed, they are going to release some acids. These acids are going to destroy your enamel. Now if your enamel is destroyed, my dear children, don't you think that's a problem? Obviously, very big problem. Later on, they destroy the dentine, they go ahead into the pulp, and then it is a very big problem. So because of this giant wall, saliva cannot act on the acid and neutralize it. Listen, so over here, since you have a big wall being formed over here, that is the reason why saliva also cannot act on it and kill any organism up there, because it has formed a very thickened layer out there. You get it? That is why we need to brush our teeth very, very nicely. Ma'am, your name please? My name is Jasmine. Yes. No one to A. Okay. Okay, guys, understood? That is why you should be brushing your teeth very often. Now, there's a question that is there. Most of the digestion and absorption of the food takes place in what? Small intestine, liver, stomach, or large intestine? Most of the digestion and absorption of food takes place in what? Small, liver, or stomach, or large intestine? What do you think is the answer for this? A, small intestine. Exactly. Digestion, most of it occurs in the small intestine only. Neetu Negi as well as no one to E. I do not know how to pronounce it. I am pretty sure there's some Gen Z thing into it. Okay. Pavani Putri, NSAN Beauty, everyone. Perfect. Tina also, Mohinder also, Prem Kumar also. Perfect, perfect. Now let's go ahead with the next thing. State the form in which the following are unused okay. Guys, can you tell me? State the form in which the following are stored. Unused carbohydrates in plants. Unused carbohydrates in plants, how are they stored? Any idea? So carbs which are there, which are not being used, how do you think they are being stored? Starch. Starch and ATP is the answer. Exactly. So unused carbohydrates is stored in the form of starch. The energy derived from the food in the case of humans is basically in the form of ATP, adenosine triphosphate. Awesome. No one to A. Okay. Perfect. Perfect. Now let's go ahead with the next thing that is up there. Complete the flow chart. Gastric gland present in the wall of the fruit. Okay. Just a second. So I think I'll move ahead with the next topic, that is respiration. That will be really good. Children, are you okay? Yeah, dear, humans may ATP. If ATP is not there, then how do you think any process in our body is going to take place? Guys, let's go ahead with the next thing. Respiration. Everyone who thinks it's okay, can you just give me a quick thumbs up? I'll go ahead with respiration. Yes, okay ma'am, thank you. Let's go. What do you mean by respiration? Respiration and how is different from breathing? Listen, respiration is the breakdown of food. Respiration is the breakdown of, of food to give you what? To give you energy. What do you mean by breathing? Breathing is a mechanical process of getting in air and getting out the air out of the respiratory organ. So respiration and breathing is totally different. First of all, know that. And the second thing that we have over here is how is the food broken down? So listen to me carefully. Suppose we are inside our cell. Okay, we are inside the cell. The cell will be having cytoplasm, and the cell has one more thing that is known as mitochondria. Suppose I had a food. I had some food. The food is having what? Glucose. Glucose which is there, it is going to be broken down to something very important. What do you call this as? Pyruvate. Now this point is super important, so make sure you listen to me carefully. A glucose is having how many carbon atoms, my dear children? It has 6 carbon. A glucose has 6 carbon, right? What about the pyruvate which is there? A pyruvate will not have 6 carbon. A pyruvate is not going to have 6 carbon. It just has 3 carbon. So that means that when one molecule of glucose breaks down, how many pyruvate will you get? You get 2 molecules of pyruvate. So 6C is going to give down two molecules of pyruvate out there, and this process is known as glycolysis. This happens in the case of cytoplasm, and during this process some amount of ATP is going to be released. Some amount of ATP is going to be released in this particular process. Okay, super important. Now what happens to this pyruvate? That is also important. What happens to this pyruvate? The pyruvate, my dear children, suppose there is oxygen in the mitochondria at this particular condition. Just give me a second. Yeah. In this particular condition, the pyruvate is going to get inside the mitochondria. It will get inside the mitochondria, and within the mitochondria, it will undergo Krebs cycle, this cycle, that cycle, and at the end, my dear children, it is going to give me three very important things. One is carbon dioxide, second is water, and third thing is the one that I have been waiting for so long, which is what? ATP, which is the energy. So carbon dioxide plus water plus energy is going to be produced inside what? Inside the mitochondria. And always remember, this is the place where maximum amount of ATP are going to be produced. There is almost 38 ATPs, or as you call as 36 ATPs being produced. These ATPs are energy currencies. For any reaction to happen in my body, I need ATP to be there. You get it? So this is a condition when there is oxygen. Okay, and this is a condition when it is happening inside the case of mitochondria. This type of respiration, which happens in the presence of oxygen, is known as aerobic respiration. Aerobic respiration. Now, my dear children, suppose I am Jasmine, right? And probably today I am going for a racing. Okay, today I am going for a racing. When I go for racing, there are most chances that are there that my energy is going to go low. Why? Because first of all, I am running, I do not have much amount of oxygen. When there is deficiency of oxygen in my muscle cell, in my muscle cells, when there is less amount of oxygen, do you think they can still afford to do aerobic respiration to produce energy? No. Do I need energy? Yes. So then what will I do? I need to do respiration, right? Yes. But in that particular case, my body shifts to next thing, which is known as what? Anaerobic respiration. Anaerobic respiration. My body shifts to anaerobic respiration, where the pyruvate is going to be broken down to what? Lactic acid plus energy. So energy is still being produced, but do you think carbon dioxide and water are being produced? No, Baba. Instead, what is being produced? Lactic acid. Ma'am, is that a problem if lactic acid is being produced? Yes, yes, and that is what exactly no one is saying. That is, and Mohinder also said, lactic acid, when it gets accumulated, Baba, you will have muscle cramps, right? You will be having muscle cramps. So here also ATP is being produced, but obviously comparatively very less amount of ATP is going to be produced. Now there's a scenario when we talk about what? When we talk about yeast. Okay, yeast. In the case of yeast, my dear children, suppose you are having yeast growing in a medium and you're covering it up. There is no oxygen up there. There is no oxygen up there. You call this process as fermentation. So fermentation happens in anaerobic condition. That means there is no oxygen. This also happens in cytoplasm itself. Here, during anaerobic respiration, or basically during fermentation, the yeast is going to produce ethanol, that is an alcohol, carbon dioxide, and also energy. Ma'am, is energy produced over here? Yes. Is it same like this? No, Baba. It is not going to be same like this. Okay, it will be different, but less amount of energy is going to be produced over here. So ethanol, carbon dioxide, energy is being produced, but the amount of energy is going to be less. That is the case of yeast. Now this particular chart is super important. Glucose, which is there, it breaks down to 6 carbon compound. It breaks down to pyruvate, is 3 carbon compound. How many of them? 2 of them, plus some amount of energy. What do you call this as? This is known as glycolysis. Where does this happen? This happens in the cytoplasm of the cell. Fine, ma'am. So when oxygen is there, what is going to happen? If oxygen is there, the pyruvate will enter into the mitochondria, will convert into something else. Later, at the end, you get 3 things: carbon dioxide, water, and energy. And this energy is the highest amount of energy which is going to be released out there. Fine, ma'am, if oxygen is not there, then the pyruvate stays in the cytoplasm itself. Okay, it stays in the cytoplasm itself of the muscle cell and produce what? Lactic acid and energy. Ma'am, this lactic acid is a problematic thing. Yes, it causes cramps. Done. Now what happens in the yeast if there is no oxygen? In yeast, it produces ethanol plus carbon dioxide plus energy. This ethanol is an alcohol thing. Carbon dioxide and energy is also being produced. If at all you are being asked which one will give the maximum amount of energy, please know it is only the aerobic respiration that happens in the case of mitochondria. mitochondria that will give maximum amount of energy. Is this clear? Is this clear? Ma'am, please do questions. So I was doing questions before, so some people came and said that please do theory, which is why I'm doing theory now. Clear. Thank you, Hemant, and thank you, Pavan Puri and Mohinder, everyone. Perfect. Thank you, dear children. Let's go ahead. So since that is clear, let's talk about plants. In plants, how do you think breathing and exchange of gases occurs, my dear children? It's very simple. It's very simple. There are few things. For example, stomata. Okay, for example, stomata. Apart from stomata, you have lenticels. So stomata is there in the, what do you call, in the stems of a tender plant. For example, small new plant out there, no, they will have stomata. And stomata is found in the leaves also, right? Apart from that, if you're talking about woody stems, there are woody stems. There you will be finding lenticels. Apart from that, you have one more thing, that is intercellular spaces. The space between the two cells out there. That also helps in what? Gaseous exchange. And the process through which gaseous exchange happens is basically known as diffusion. Carbon dioxide you get from the atmosphere, and basically oxygen is what is being released. Why? Because over here respiration is going to happen, Baba. Respiration will be happening, right? Respiration will be happening. Is it respiration that is going to happen? Carbon dioxide, when you take from the atmosphere and when you give out oxygen, what is the process that is happening over here? It is going to be photosynthesis that takes place, right? It is going to be photosynthesis, right? Where do you need oxygen? You need oxygen for the process of respiration. So that is different. So let's see one by one what is given over here. Okay, just give me a second. So this is daytime. Okay, this is daytime. In daytime, let's see what is happening. Carbon dioxide you get from the atmosphere, fine, and basically this carbon dioxide is going to release oxygen. This oxygen basically which is there, it will be moving out. For what? For giving to the whole organism. For whatever organisms are there, they will be taking the best use of it. Fine. So now some amount of oxygen is going to be utilized over here also. Why? Because you have respiration process going on, and in respiration again what do you get? You get carbon dioxide. So again this carbon dioxide is getting utilized. Now when you talk about the night time, in the night time what is happening, my dear children? In the night time, carbon dioxide from respiration, okay, carbon dioxide which is there from respiration, that is going to move out. Why? Do you need it for photosynthesis as of now? No, there is no photosynthesis that probably might be happening at this particular point of time. Majorly, no photosynthesis is going to happen, which is why at night time what is going to happen? Carbon dioxide is going to be moving out more, which is why we say that we should not be sleeping under the tree at night time. Why? Because at that time respiration is more and photosynthesis rate is going to be less. That is the reason. Now, there's a clear-cut line which is given in your NCERT which I want you to know, and that is at night when there is no photosynthesis occurring, CO2 elimination is the major exchange activity going on. During the day, the CO2 which is generated during respiration, it is used up during photosynthesis, right? Hence, there is no much CO2 being released. Instead, oxygen release is the major event at this time. So, oxygen is released majorly during the daytime, right? And at the night time, CO2 is being released, which is why we have said that we should not be sleeping under a tree at night time. Did you get it? Okay, this is very, very important. Please know that as well. Now we'll come to very important zone, and that is basically in the case of fishes. So in the case of fishes, my dear children, everything is different. You know, fishes, they have a higher breathing rate. Why? Because in the fishes, my dear children, they depend on dissolved oxygen. Do they depend on atmospheric oxygen just like us? No, they depend on dissolved oxygen, and the amount of dissolved oxygen is going to be less, Baba. So which is why the fishes have to take in water again and again, such that it gets enough amount of oxygen. So fish is saying that I am tired of breathing 100 breaths per minute. Yes, that is actually true. They take 100 breaths per minute. Why? Because there is very less oxygen, dissolved oxygen up over here. Okay, so gases exchange in fishes occurs through gills, which takes in the oxygen dissolved in the water. It occurs through gills, and over here I have a picture. So listen to me very carefully. This is how the exchange happens. So oxygen which is there in the water comes in. So water along with the oxygen moves around inside their body. Now they will be moving it out through the lung. Sorry, through what? Through the gills. They do not have lungs, they have gills. So it will be moving out through the gills. What is going to happen? You have to transfer the oxygen to the inside of the body. How do you do that? So there will be so many blood vessels which are lining the gills. So oxygen from the water will be moving to the blood vessels. Now whatever is left behind will be coming out through the gills. That is how respiration is going to happen in the case, or basically breathing is going to happen in the case of fishes. Please remember it. So from mouth to gills. From gills it will be going to the blood vessels. From the blood vessels it will be going to the entire body, and then it comes to the heart. We will be talking about it more when we talk about circulation. Okay, we'll talk about it more when we talk about circulation. Ma'am, what is epiglottis? Epiglottis is the okay, so you have windpipe, right? And you have food pipe just nearby. Suppose the food goes into the windpipe. What is going to happen? We will choke and we will die. Okay, we do not want that to happen. So there is a covering that will be covering your windpipe. It remains closed when food is there. That is known as epiglottis. Okay, works? Okay. Now we are left with the breathing in the case of human beings, and this is super important. So listen to me. How does breathing happens over here? So first thing, you have your nostrils, right? You have your nostrils. You say external nares also, N-A-R-E-S, external nares and internal nares. Anyways, so this is there. Then you have the nasal cavity. From the nasal cavity, the what do you call, whatever gas you have taken, it comes over here. What is this? This is going to be the pharynx. Now the pharynx will be going ahead. You have the food pipe over here. You have the windpipe over here. As of now, we are not going to the food pipe. We are talking about the windpipe. So it goes over here as what do you call? Someone was asking me as of now, what is epiglottis? Okay, epiglottis is this thing that is a flap. So epiglottis has to open. That's when the what do you call, the gases are going to get inside. Now when they get inside, the first thing that you have over here is going to be known as what? Trachea. And if you see, there are rings of cartilage present over here. Why there are rings of cartilage? Otherwise, suppose when we are not breathing, it will be collapsing. It will be collapsing. We do not want the things to collapse. That is why we have rings of cartilage. Listen, it is not made up of bone. It is made up of cartilage. This is super important, and it is there such that your whole system does not collapse. Now the gas came over here, it went to that lungs, it came to this lungs also. In the lungs, my dear children, you have first bronchi. This is bronchi. Bronchi opens into bronchioles. Bronchioles opens into what? Alveoli. Alveoli are sac-like structures out there. Okay, so that is what is happening. Now in the alveolus, my dear children, suppose we talk about the alveolus. There is case 1 where as of now when I took my breath, I took in lots of oxygen. Because in my atmosphere I have nitrogen, apart from that I have lots of oxygen, right? So oxygen is there. Now blood vessels are going through my, okay, nearby my alveoli out there, right? These blood vessels which are there, suppose in my body there is too much amount of carbon dioxide which has to be removed, and there is less amount of oxygen. So what will happen? Oxygen will move from higher concentration to lower concentration. That means it will go to my blood vessels. What about carbon dioxide? It will move from higher concentration, lower concentration. So that means it will go into my alveoli. So when we breathe in, we take in oxygen, and this oxygen goes to our blood vessels. When we breathe out, whatever carbon dioxide is there in the alveoli, that is being to move out. Okay, please understand that. And now beyond that, there is one more very important thing which is there, which is what, my dear children? Diaphragm. So this thing that you see over here is a diaphragm. What is the use of a diaphragm? First of all, it's a muscle, right? And diaphragm, it's made up of muscles. And what does it do? When we breathe in, everyone, I want you guys to keep your hand over here. When we breathe in, what is happening? Your ribs which is there, your rib cage which is there, it is expanding. Apart from that, the diaphragm which is there, it is basically going to go down. That we cannot feel, I'm just telling you. It is going to go down. So initially it is dome-shaped structure, but now it goes down. Why? Because you need more space over here such that your lungs can go up. Okay, so your lungs can basically be big. Now over here, one very important thing. What do you call this process? When the diaphragm is being what do you call, flattened, what do you call this? We say the diaphragm is contracting. When it is contracting, that's when it is going to become flat. Now suppose when we are breathing out, the rib cage which is there, it goes down. What about the diaphragm? Diaphragm which was like this, it will become like this because you need less space now. What do you call this condition as? We say the diaphragm is now dome shaped, or we say it is now relaxed. So how do you remember remember that. Always remember, when we are like this, when we sit like this, chumma, when we sit like this, right? Who sits like this? No one. We all sit like this. So this is a relaxed position. Similarly over here, when you are having something like this, you say it's relaxed. Whenever it's straight, we say that basically it is not relaxed, it is contracted. Always remember that. Okay? Got it? Fine. So breathing in is diaphragm contracts and moves down. Breathing out, diaphragm relaxes and moves up. And over here you can remember the whole thing like this. Metabolic poison leaves the body by airways. M stands for okay. Okay, anyways, so should not be mouth, it should be something else. P for pharynx, pharynx and larynx, larynx and then you have trachea, then you have bronchi, bronchioles and alveoli. But you do not need it necessarily, you can remember it like this also, easily. Perfect. Ma'am, are you Tamilian? No, I am not. Okay, perfect. Got it, everyone? Got an understanding of it? This is very, very, very important. Now also one more thing, can diffusion pressure alone help in the transport of oxygen? Obviously no. It's not just the diffusion pressure which is enough. You also need to make sure that there is hemoglobin. If hemoglobin is there, my dear children, it will help in the easy transport. Why? Because hemoglobin, my dear children, has a higher affinity for oxygen than CO2. Hemoglobin has higher affinity to oxygen than CO2. What about carbon dioxide? Carbon dioxide is more soluble in water. It is more soluble in water, hence can be transported in dissolved form in the blood. Okay, so hemoglobin has higher affinity to oxygen, which is why hemoglobin carries oxygen. And what about carbon dioxide? It is mostly traveling through the dissolved state, that is through blood only, because it is highly soluble in the water. Done? Okay, perfect. Now everyone who got an understanding of respiration, can you just give me a quick thumbs up? A quick thumbs up, everyone who got an understanding of respiration. Ma'am, have you taken lunch? No, I have not. I'm yet to. Thank you for asking. Thank you guys for giving me the thumbs up. Perfect. Ma'am, I didn't understand the cartilage bones. Okay, so it's not cartilage bones, it's just cartilage. Cartilage is different and bone is different. So listen, here when we talk about trachea, this trachea which you see, it has rings of cartilage. Why do you have that? So that suppose we are not breathing. If at all we are not breathing, this will collapse, right? The trachea will be collapsing, it will be going off, right? So to make sure that it's still there intact, we have rings of cartilage. That's the only thing. Okay? Got it? Okay, thanks. Perfect. Let's go ahead. King God, ma'am, I love you. I love you too. Okay, let's go ahead. Now, what do you have? This question, there is an experiment, okay? After a few moments of exposure to CO2, the lime water will turn milky due to the formation of calcium carbonate, which is insoluble in water. So basically, what is happening over here? So when we have said that if at all we are doing foo-foo, okay, if at all we are doing foo-foo inside lime water, it turns milky. Why? Because when we do foo-foo, what is going to happen? The carbon dioxide which is there, it is going to react with CaOH twice, that is your lime water, right? And then it will form something that is known as CaCO3, calcium carbonate, that forms the precipitate on there. Okay, so the reaction shows that CO2 is being released. That is exactly why it is forming CaCO3. Perfect. Exactly, Mohinder. Okay, diffusion is insufficient to meet the oxygen requirement of multicellular organism like human. State reason. Why? Because diffusion is going to be a very slow process. When you're talking about a multicellular organism, okay, there are multiple cells which has to get, so it's a very slow process. If from one cell to another cell it will keep going, obviously by the time it reaches the place where we need, we'll die. Okay, so please know that. Now we go to the transportation process. Now this is, love you, Saratya, I love you for teaching. Thank you so much. Okay, guys, one very important thing. Everyone, for you it's clear. Can we go ahead with circulation process? Is it okay if at all we go ahead with circulation process? Just give me a second, okay? Ayyo, where is it? Yes, perfecto. Okay, ma'am. Fine. So listen to me. We are talking about human beings. Okay, I'm talking about human beings, or basically mammals, cows, dogs, cats, anything that you want to think of. In the case of mammals and in the case of birds and mammals, always remember, birds are basically apes and we are basically coming under mammals. We have about 4-chambered heart. Our heart is having 4-chambered, 2 chambers up, 2 chambers down. The upper chambers are known as atrium, the lower chambers are known as ventricle, right? Now over here, they have a wall like this which is known as septum. What do you call this as? You call this as septum. Fine. Now, when we breathe in, basically all the gases goes into the lungs, right? Now this gas which is there inside the lungs, it will mostly have what? It will be mostly having lots of oxygen. It will be having lots and lots of oxygen. Now this oxygenated blood will go where? Right atrium or left atrium. So this is the right side and this is the left side. Where will it go? The oxygenated blood, always remember, it will be going to the left atrium. Why? Because the left atrium is chillowing, saying lao, bring in oxygen, which is why the oxygenated blood goes to the left atrium. From the left atrium, it will be going to what? It will be going to the left ventricle. So always remember, A comes before V. A comes before V. So you have A over here, then you have V. From the atrium, it goes to the ventricle. Not from the ventricle, where does it go? It will be going to one very important thing. You know the area where it goes? It goes to the rest of the body. Why to the rest of the body? Because in our cells, my dear children, the rest of the body, in our cell, respiration is happening. What is the end product of respiration? Baba, all the oxygen is being utilized up over here to produce ATP, which is why the cells are pretty much sad and they are crying that, hey, please give us lot of oxygen. We need oxygen to produce what? ATP for undergoing cellular respiration. That is exactly why it goes to the rest of our body. Okay, it goes to the rest of our body. Now, when it goes to the rest of our body, what? Okay, when it goes to the rest of our body, what is going to happen? When it goes to the rest of the body, what is going to happen, my dear children? One very important thing happens. Our cells utilize the oxygen to form the ATP, right? What will the cell give it back? The cell will be having so much amount of carbon dioxide, because the end product of respiration is what? Carbon dioxide, right? Which is why lots and lots of carbon dioxide is going to be released. And now this carbon dioxide is given to the blood, which is why we'll say, as of now, in the blood, there is less amount of oxygen, there is more amount of carbon dioxide, which is why we'll say that this is basically what? Deoxygenated blood. This is deoxygenated blood. Until now, we were dealing with oxygenated blood, which was there. Now it is deoxygenated blood. This deoxygenated blood will go where? Atrium or ventricle? It will go to the atrium first. A comes before V, right? It goes to the atrium, then it goes to the ventricle. Now, if at all you want oxygen, what do? Basically, you have to make sure that this deoxygenated blood is carried to the lungs, because that is the only place where you can get oxygen. So it goes to the lungs. That is exactly how things are going to happen in this particular case. This is very, very important. Right. Now listen to me. Blood comes twice in the heart. First, you have the oxygenated blood. The second is what? Deoxygenated blood, which is why I'll call this as double circulation. What do I call this? Double circulation. This is a proper double circulation that is happening over here. Okay, and I call this double circulation, I can divide into two things: pulmonary circulation and systemic circulation. That means the circulation that is being happening between the heart and the body, that means from the heart to the body, from the body back to the heart, this is coming under what? Systemic circulation. Okay, now from the heart to the lungs, from the lungs to the heart, that will be coming under pulmonary circulation. So whenever lungs is involved, you use the term pulmonary out there. This is very important out there. Yeah. Now listen to me carefully. How do you remember the names of all this vein, artery and stuff like that? The blood vessel that is going to bring blood, okay, towards the heart. When I say towards, it has to be a vein. When it's going to carry the blood away, A for away and A for artery. If it is going to carry the blood away, it is going to be known as an artery. So over here, from the lungs, it is going to carry blood towards the heart. So it will be what? Vein, Baba. From here, from the heart, it is taking away from the heart to the different part of the body away from the heart. So that is why aorta, which is what? An artery. Similarly, it is carrying the blood towards the heart. So again, this is going to be a vein. This is carrying the blood away from the heart to the lungs. So this is going to be an artery. Now always remember, since I already told you, whenever lungs is involved, you use the term pulmonary. What do you use? You use the term pulmonary. So over here, you call it as pulmonary vein, and over here, you will call this as pulmonary artery. Okay. Now these names are aorta. This name of this particular artery is what? Aorta. And what is the name of this particular vein out there? There are two veins. One is inferior vena cava and the other one is superior vena cava. Inferior vena cava will be carrying all the deoxygenated blood from the lower parts of the body. Okay, superior vena cava is going to carry the blood from the upper parts of the body. So superior and inferior vena cava will be there, which will be carrying this. Okay, and in between that, what do you have, Baba? You have the septum layer. Cool? Works. Is this clear? Everyone who is listening to me until now, is this particular thing clear to you guys? Children, is it clear? Yes. Thank you, Mohinder. Okay. Perfect. What about the others? Ma'am, I didn't understand what is aorta and what is vena cava. Okay, I'll tell you. What is aorta? So aorta is right over here. It's an artery. It's an artery that carries the blood away from the heart to the body. So you have given it a specific name, that is aorta, right? Similarly, the vein that carries the deoxygenated blood back to the heart, you have the name of the vein. The name of the vein is vena cava. And you have two different types. Superior, that collects the blood from the upper part, and inferior, that collects the blood from the lower part. Got it? Student, thank you so much. And Mohinder, thank you so much for taking that. I'll definitely take enough amount of rest. Thank you. Okay? Perfect. And Himanshi, Pavani Putri, everyone, thank you for giving me the thumbs up. Perfect, dear children. Let's go ahead. So, we have some valves also. In between the atrium and the ventricles, my dear children, we have some valves. Why? Listen to me. This is what usually happens, okay? The atrium, whatever blood is there, it is going to contract. When it contracts, whatever blood is there, it goes to the ventricle. Now, when the ventricles will contract and send the blood to the body, you have to make sure that there is no backflow of blood. If there is backflow of blood, what is going to happen? If I do this and pitch up the blood goes upwards, do you think the pressure will be maintained over here? If there is no pressure, do you think the blood will be moving forward? No. So we have to maintain that pressure, which is why we need a valve which will prevent the backflow of blood. So the one which is there between the left atrium and the left ventricle is known as bicuspid valve. You also call this as mitral valve. What do you call this? You also call this as mitral valve. This is very, very, very important. Okay, this is super, super important. Now, what do you have? You have one more very important thing that you have to note over here. Similarly, on the right side also, you have the valve. What do you call it? You call it tricuspid. So, tri-right. So, right term comes over here. So, it is between right atrium and the right ventricle. Tricuspid valve. All these valves which are there, they are there for what? For preventing the backflow of blood. For preventing the backflow of blood, we have the valves. Done? Ma'am, is systolic pressure and diastolic pressure important? Yes, it is. It is, Yuvan. So what is systolic pressure? What is systolic pressure? Listen to me. When the left ventricles, they pump the blood into the atrium into the artery, that is aorta. The pressure with which they exert, the blood exerts on the wall of the artery during a contraction, ventricular contraction, is known as a systole. The pressure that is exerted by the blood on the walls of the artery during a ventricular systole, during a contraction, is known as systolic pressure. Now, on the other hand, suppose the ventricles are relaxing. At this particular point of time, the pressure that is exerted by the blood on the walls of the artery is known as diastolic pressure. Obviously, which is going to be more? It is going to be systolic, which is always going to be more, because you are contracting and then the pressure which is there, it is going to be more. Okay? Got it? So please know about that. So your BP is counted by systolic upon diastolic. It is usually, this is 120 by 80 mm of Hg. Please remember, 120 by 80 mm of Hg. This is a systolic pressure which is high and diastolic pressure which is comparatively lower. Cool? Now, and these are known as atrioventricular septum, atrioventricular walls. Sorry, why do you call it? Because it is between atrium and the ventricles. Now you have another walls out there. These are known as semi-lunar walls. Why? Because they look like half moon. These valves are present over here. Just like when I say that the contraction happens and the blood moves to the artery, right? Listen, the blood can come back into the heart also. Again, you need a valve over here such that the backflow is prevented. And this particular valve which is there, you call this as what? Aortic valve, because it is there in the aorta and between the heart. Similarly, over here, when the right ventricle contracts and sends the blood to the lungs through an artery that is known as pulmonary artery. Again, you will be having a valve over here which prevents the backflow of blood, that is known as pulmonary valve. Okay, it will be known as pulmonary valve. Got it? This is very, very, very important. Perfect. Okay, and so this is pulmonary circulation, as I told you, when you're talking about just your heart and the lungs. So heart pumps the blood to the lungs, deoxygenated. The lungs gives oxygenated blood back to the heart. This is pulmonary circulation. And then you have systemic circulation, where what is happening? Blood is pumped, oxygenated blood is pumped to the heart, pumped to the body, and deoxygenated blood is pumped back to the heart. That is systemic circulation. Together it forms double circulation. Now, who has the superpower of maintaining a constant body temperature? This is important. Who has the superpower of maintaining a constant body temperature? Constant body temperature means outside whatever the temperature is, it's okay. Inside it will be the same temperature. Who do you think? Homeotherms or poikilotherms? Homeotherms सॉरी प्रश्न दोनों येलो बॉक्स में है. Okay, solo edits. Solo edit. Please know everything which is there in your NCERT. That is always a good, a safer option to be in. Okay, do not miss out on anything which is there in NCERT. Have that. King God, definitely I'll take rest. Okay, thank you. Guys, please listen to ma'am. Exactly, everyone, please listen to ma'am. Okay. Chalo. Ab, you have to tell me from out of these organisms which one are going to maintain constant body temperature. It is us. We are homeotherms. We are warm-blooded organisms. Under us, I already told you, we mammals come under this. Apart from that, aves, as in birds, also come under this. This is super, super, super important. Now we have poikilotherms. In poikilotherms, what we have cold-blooded animals. For example, they are not going to maintain any constant temperature. Okay, for example, what do you have? You have fishes, you have amphibians, you have reptiles. All of them, my dear children, they are cold-blooded. That means whatever is the temperature outside, their temperature could also vary with that. Okay, ma'am, what's the big deal about maintaining constant body temperature? Listen to me carefully. When I say I want to maintain a constant body temperature, you need to spend a lot of energy into that. You need to spend a what? A lot of energy into maintaining the constant body temperature, right? And for that, that means I have to produce more amount of ATP. If I want to produce more amount of ATP, I need aerobic respiration. That means more amount of oxygen is required. That is exactly why mammals and apes will be having 4-chambered heart, such that there is a clear separation between oxygenated and deoxygenated blood. On the other hand, poikilotherms need not maintain constant body temperature, which is exactly why they do not need too much amount of energy, which is why they do not have a proper separation between oxygenated and deoxygenated blood. That is why you see 2-chambered heart, 3-chambered heart, and things like that. And now we are going to talk about that itself. So just a second, okay? In the case of fish, let's see what is the thing. In the case of fish, my dear children, I told you, in the gills, okay, in the gills you have so many blood vessels which are surrounding. From the blood vessels, those blood vessels will be taking in oxygen which came through the gills. This oxygenated blood goes to what? The rest of the body. It goes to the rest of the body. Now from the rest of the body, where do you think it will be going? It goes to the atrium. It goes to the atrium, then it goes to the ventricle. From the ventricle, it will be going back to the gills. So you need to understand one very important thing. Oxygenated blood is carried directly from the gills to the rest of the body by some blood vessels. Now it gave to the body, okay, it gave oxygen to the body. Now what happens? Deoxygenated blood is something that is pumped by your heart in the case of fish. Fish has two-chambered heart. Do not forget it. Fish has what? Two-chambered heart. This is very, very, very important. Got it? Okay, this is very, very, very important. Now, next thing which is there. This is deoxygenated blood. I hope this is clear, right? This is the case of fish which is there. There is no oxygenated blood that goes to the heart immediately. Now, what do we have? We have lungs in the case of, lungs and heart in the case of reptiles. And here please know that here something is being written, that is, I am a reptile and I am different. Just a second. I am a reptile and I am different. Who is saying that? Crocodile. Because crocodiles, my dear children, even though they are coming under reptiles, they have a four-chambered heart. But every other reptiles which is there, so crocodile and family, whether you talk about gharial, whether you talk about alligator, all of them, my dear children, they are going to have what? Four-chambered heart. Apart from that, every other reptile will be having three-chambered heart. The same goes with amphibians also. And how do you think their work goes on? So let's see. So over here, from the lungs, oxygenated blood goes to what? The left atrium, as always. From the left atrium, it goes to the ventricle. From the ventricle, where does it go? It goes to the rest of the body. Listen, over here, I had oxygenated blood. And this went to what? The ventricle. From the ventricle, it is going to the rest of the body, right? From the rest of the body, what do you get? You get deoxygenated blood. Where does it go, Baba? Deoxygenated blood goes to the right atrium. Okay, now what? Now the deoxygenated blood is going to go to the ventricle. So, ma'am, are you saying that mixing is happening? There is mixing of oxygenated and deoxygenated blood. That is what you're saying over here? Exactly. Ma'am, is this okay if at all there is mixing? Yes. Because do they need to maintain a constant body temperature out there? No. Which is exactly why there is mixing of blood. Okay. And now it is going to the lungs. Again, it becomes deoxygenated. Again, there will be mixing of things. So that is why they have a three-chambered heart and they are pretty much fine with that. They are pretty much fine with that because they do not have any big things to do out with that. Got it? Exception is crocodile. If at all you forget it, you are going to forget. You should be forgetting the marks also. Okay, so why mammals and aves shows double circulation? This is a very important question for both. Why? Because both of them have to maintain a constant body temperature, and that means that basically they need a clear separation between oxygenated and deoxygenated blood. Because efficient separation will be helping in what? More oxygen, and this more oxygen will be helping in more ATP, and that will be helping them in maintaining the constant body temperature. Got it? This is super, super important. Until now, is it clear to everyone? Until now, is it clear to everyone who is watching this video? If clear, can you just give me a quick thumbs up? If it is clear, just give me a quick thumbs up. Thank you, Pavani. Okay, perfect. Okay, Tina also. Thank you. Very helpful, ma'am. Love your teaching. Thank you so much. Clear, ma'am. Thank you, Solo Edits. Okay, perfect. Listen, ask your friends to come in and join the live. And these people who are talking out loud, let them go away. Oh my God. How much talking do you guys need to do? This is terrible. Okay, anyways. Now we have arteries. Okay, listen, we have three types of blood vessels out there. One is arteries, one is capillaries, and one is veins, right? Arteries which are there, they will be breaking down into arterioles, and the arterioles which are there, they are going to form the capillaries along with the venules which comes from the veins end. Now, arteries, as I told, they carry the blood away from the heart, right? When I say that they are carrying the blood away from the heart, you have to use a logic. Ventricles are pumping, and the blood is going directly into the artery. If at all it has to sustain this much amount of pressure, you need to understand one very important thing about arteries, and that is basically, where is it? it will be having very thick wall. A very thick wall will be there in the case of artery. What about the veins? Now veins carry the blood towards the heart. So it's not like heart is pumping directly the blood to the vein, right? It is the vein that is carrying towards the heart, which is why they will be having thin walls. What about capillaries out there? Capillaries are something that has to go in between the cells, which is why their walls have to be extremely thin. Their walls have to be extremely thin, and I'll tell you, it's just one cell thick. One cell is only there. So if at all I say this is a wall, basically only one cell is going to form the layer up there. Got it? That is a basic difference. Now, what is the function? As I told you, arteries send the blood away from the heart, veins carry the blood towards the heart, and capillaries are there for exchange of things. Pressure which is there in the arteries, it is going to be very much. In veins, it is going to be less. In capillaries also, comparatively, it is going to be lesser. Narrow, is it narrow? Sorry, what about the diameter in between that? So in the case of arteries, since they have thick walls, they have much space in between? No. So that is why they are narrow. What about veins? Veins, since they have thin walls, they will be more wide. Okay, and capillaries, my dear children, they are very small, which is why they will be very narrow. Okay, now listen to me carefully. Very, very important. So forget about this thing. Very, very important. What about valves? Which of them have valves? Why do we have valves? Listen, arteries which is there, it is going to get pumped. I told you heart pumps the blood to the arteries. There is pressure such that the blood will go straight only. What about veins? Since veins is going to carry the blood towards the heart, there are chances that there can be backflow of blood. Okay, it has to go against the gravity. There can be backflow of blood. This is exactly why veins are the ones which will be having valves, and these valves which will be preventing what? The backflow of blood. What about capillaries? Capillaries will not be having any valves out there. Got it? Okay, this is super important. Ma'am, I called my friend, but she's very disturbed. Exactly, this is actually a very big disturbance. Okay, anyways. Now let's go. Blood pressure. I already spoke about it. The force that the blood exerts against the wall of the vessel is known as blood pressure. Systolic means basically the pressure inside the artery during the ventricular systole, as in the ventricles when they contract. Diastolic means the pressure inside the artery when the ventricles are going to dilate. The normal range is what? 120 mm of Hg, and diastolic pressure is 80 mm of Hg. What is the thing that we use to find this out? Sphygmomanometer. Sphygmomanometer. Okay? Now, just a second. Yeah. Now, apart from all this happening inside our body, we also have one more thing, that is your lymphatic blood vessel. A lymphatic blood system is super important, or basically it's not a blood vessel, it's called as lymphatic vessels itself. So basically when I say that arterioles are there and they help in the formation of capillaries and everything, okay, and they join back to the venules and they form all these things, you need to understand that it goes between the cells, right? These capillaries are going to go between the cells. And since these capillaries are only one cell thick, there are high chances that some leakage can happen. What leakage? Leakage of some very important thing, for example, plasma. Your blood is made up of plasma and red and all the different type of blood cells, right? What all blood cells do you have? Erythrocytes, okay, leukocytes and platelets. Erythrocytes or red blood cells are responsible for oxygen transport since they have hemoglobin. You have leukocytes which are there for immunity. Okay, they fight against the other antigens out there in your body, pathogens out there. Then you have platelets. Platelets are important for clotting of the blood. Okay, they are responsible for clotting of the blood. Now, in the cells, first of all, their cells are floating inside the plasma, right? Plasma is something that can easily move out. What about RBC? Do you think they can move out? RBC cannot move out. RBC is not able to move out. What about platelets? Do you think they can move out? They will also not move out. What about WBCs? Do you think they can move out? No ma'am, because they are very big. Wrong. They can still move out. Why? Because they can change their shape. Okay, they can change their shape and move out basically. So can I say that plasma, WBC, and also if at all there were some pathogens, okay, some pathogens which were there inside the blood, all of them are going to move out, and then what? When all of this are going to move out, then what happens? That is very, very important. That is also super, super important. When all of this moves out, my dear children, there should be someone to collect it up. Otherwise, what is going to happen is that the fluid, the space between the cells is known as interstitial space. Interstitial space. And this space is going to be filled with what? Lots and lots of fluid. So there should be someone to take this fluid up. And what is that someone who takes this fluid up? It is going to be your lymphatic vessel. Your lymphatic vessel will be taking this fluid up such that it does not stay over here and such that it does not cause any swelling up there. And the lymphatic vessel which will be transporting this fluid back into what? Back into your vein, and from the vein it will be going to what? It is going to what? It is going to go to the heart. That is how things are going to go out. Okay? So, lymph is also known as lymphatic fluid or tissue fluid. Is a collection of the extra fluid that drains from the cells and the tissues that is not reabsorbed into the capillaries, plus the other substance. The other substance include proteins, minerals, fats, nutrients, damaged cells, cancer cells, foreign invaders. It can be anything along with the plasma and the WBCs. Lymph is a colorless fluid. Because why? It does not contain RBC. RBC is not there in the lymph, right? It consists of plasma, also leukocytes. Leukocytes as in the WBCs are there, and not erythrocytes and thrombocytes. So thrombocytes is basically platelets. That is not going to be found. Erythrocyte, that is RBC, that is also not going to be found. Only your WBCs are going to be there. I hope that is clear. Now, what is the use of lymph? It maintains the fluid level in the body. Suppose all the fluid is leaking out. Do you think the blood pressure is going to be maintained? No. If blood pressure is not maintained, do you think we can live? No. Second thing, it absorbs fat from the digestive tract. Okay, what does it do? Okay, so this is very important. So when I spoke about villi, you have seen the blood vessels, right? Similarly, in the villi, you have lymphatic vessels. The normal blood vessels cannot take fat because they do not have any perforation to take in big fats out there. But the lymphatic vessels, my dear children, they have that ability to absorb fat from the intestine. So they are the one that absorbs the fat from the intestine. This is important. Ma'am, is this fluid plasma fluid? Listen, yeah, the lymph has the fluid of the plasma. Yes, the plasma leaks out. The plasma fluid is also, it's not plasma fluid, it's basically plasma. Plasma is basically fluid only. So you just say plasma will be there. Apart from that, all the other cells, such as I told you, WBC will be there, any damaged cell will be there, any pathogen will be there, all of it will be there. Cool? Yes. Now what? It protects the body against foreign invaders. How do you think lymphatic vessel is going to protect the body? So when I spoke about lymphatic vessel, I didn't tell about one very important thing. In lymphatic vessel, you will be having some enlarged portions like this. What do you call these portions as? You call this as lymph nodes. What do you call this? Lymph nodes. And lymph nodes will be having so many WBCs. They have ready-made soldiers out there. What do the soldiers do? Suppose the extra fluid which is coming out from here, inside that you have some invaders, some pathogens. Those will be killed by this lymph nodes, the cells of the lymph nodes. And lymph node is entirely present throughout your body, which is why, suppose some doctors, when you go, they touch over here and check whether your lymph nodes are swollen. They are basically checking if at all you have an infection or not. Okay, so it protects the body against the foreign invaders as well. Next thing, transports and removes waste products and abnormal cells from the lymph. Do you think it does that? Do you think it does that? Transports and removes waste products and abnormal cells from the lymph? Yes, it does. Okay. So that is the use of lymph. Is this particular thing clear to you? Everyone who is watching this video, is this super clear? So what is the difference between lymph and the blood? Blood, it has plasma. Plasma has more proteins, calcium and phosphorus, whereas lymph, the plasma has less proteins, calcium and phosphorus, because everything is not going to go out. It consists of plasma, erythrocytes, thrombocytes and leukocytes. It just consists of plasma and leukocytes. Erythrocytes and thrombocytes are not there. Blood is red due to presence of RBCs. As RBC have hemoglobin, over here it is going to be colorless because there is no RBC. Yes, ma'am. Okay, thank you, Asfi. Mohinder, thank you. Okay, perfect. Fine. So, everyone, you can try this question. Which of the following is the correct feature of lymph? It is similar to the plasma of blood, colorless and contains less protein. Similar to WBC of blood, colorless and contain more protein. Similar to RBC of blood and red in color, it contains more fat. What do you think is the answer for this particular question? Which question is actually, or which option is actually correct over here? Any idea? Ma'am, are hollow glands filled with lymph? Hollow glands. No, they are not. Your lymphatic blood vessels are going to be filled with lymph. Okay? A is Yuvan is saying A. Okay. Is the answer A? The answer is A. It is similar to the plasma of the blood, colorless, and contains what? Less protein. That is the answer. Okay. Now we move on to the transportation in the case of plants. In the case of plants. And before I go ahead with that, okay. Guys, you have two options with you. One is to complete this chapter right now. That's only transportation and excretion is remaining. Or else, basically, after that we can take a break, or we can take a break now. Which is the option that you would like? Finish the chapter. Okay, let's finish the chapter then. Let me drink some water then. Okay. Okay, let's go. Transportation in the case of plants. So, there are two ways in which transportation happens. Water transport happens in the case of plants. First of all, you need xylem for that. Xylem is a vascular tissue that you need. There are two theories: transpiration pull theory and root pressure theory. Root pressure theory, it goes like this. Listen to me very, very carefully. Okay. So, basically, suppose this is your roots. Yeah. These are the roots which are there. The roots which are there, they are surrounded by soil, and the soil, what do you have? You have so many ions. So plants, no, they are always lalchi. Lalchi, by that I mean they always want things more. So they take the ions inside the root cells. So the ions were outside, but they took it inside. How? With the help of active transport. So whenever I use the term active transport, just understand that they are going to spend their ATP. ATP is like the money for them. Right, they're going to spend some money, and they're going to spend some energy out there and going to take the ions inside. They will be taking the ions inside with the help of what? Active transport. When do you usually do active transport? When you feel that already things are very much in amount, and then also you're taking it in extra format. That's when you say it's active transport. Okay, I have taken in the ions. Then what? When ions are more inside the roots, you need to understand the solute is more, the solvent is less. The solute is more and the solvent is less. When this happens, don't you think osmosis will be taking place? Yes, right? Osmosis takes place. What will happen? Water molecules now move inside the roots. So water molecules will be now moving inside the roots. Now when the water molecules are inside the root, what is going to happen, my dear children? Suppose this is a water molecule which is there. This is another water molecule which is there. One water molecule is going to push the other molecule upwards. So basically, now the water molecules push each other upwards, and then the pressure increases. This is root pressure theory. According to root pressure theory, we say there's a push being created, which is why water will be going upwards. Okay, do you think a big plant out there, a big tree out there, for it, root pressure theory will be enough? No, obviously, this is not enough. You need something else also. And that's when transpirational pull theory comes into the picture. Okay, that's when transpirational pull theory comes into the picture. So listen to me. Over here, the sun is there, the leaf is there, the stomata will be there. Through the stomata, water is lost in the form of vapor to the process of transpiration. Right? When the water is lost, you need to understand one very important thing. The water molecules which are there, they are close to each other like this. They are close to each other like this. You call this as adhesive force. It's like holding their hands. So when one guy moves outside, the other guy is also pulled upwards. You get it? Because why? Because there's a cohesive force between two water molecules. Similarly, my dear children, a water molecule, which suppose I am water molecule and I am going upwards, I have also touched one of my hand toward the walls. So there is a force over here, or basically I call this as adhesive force. Okay? So when someone moves in, I also go up like this. I also go up like this. Why am I going up? Because water is being continuously lost in the form of vapor through the process of transpiration. So listen to me carefully. Transpiration leads to a pull. Root pressure leads to a push, and both of them together helps in the transportation of water inside. Okay, transportation inside what? Inside the xylem. Is this clear? Is this clear, everyone? Guys, if it all is clear, just give me a quick thumbs up. Come on, come on, come on, come on. Yeah, thank you. Fine, let's go ahead. So now there is one more thing, that is translocation in plants, and that is through phloem. So food transports through phloem and water transports through what? Xylem. Water transport, always remember, it is going to be unidirectional in nature. That means only in one direction water is going to go, that is upwards. It cannot go in all the direction out there. I hope this is clear, right? Now we are coming over here when we talk about translocation. Translocation term is going to be used whenever you're talking about the assimilates, or basically the food, when you're transporting that. Okay, so translocation is the process by which assimilates from photosynthesis, as in the byproducts of photosynthesis, are moved around the plant from where they are made. So from where they are made, you call them as source, and to where they are going, you call them as sink. Okay, so there is source and there is sink, and this is always going to be, most of the time it is going to be bidirectional. That means the food, the upper part of the plant will also need food, the lower part also needs food, so it is going to be bidirectional. Okay, and before we go ahead with that, listen to me. Plants convert the sugar made during photosynthesis into sucrose. So whatever thing that we formed over here, suppose we formed glucose, right? During photosynthesis we formed glucose. This glucose molecule which is there, my dear children, it is transcribed to what? Sucrose. Why sucrose? Why are we converting into sucrose? Because sucrose is something that is not going to be reactive. Okay, we want to transport the food to entire plant. Suppose you have glucose. Glucose is reactive, which is why it will keep on reacting wherever we are going. We want something that is not going to be reactive, and that's exactly why we have what? Sucrose. Sucrose is what? A non-reducing sugar. It is what? A non-reducing sugar. So please remember this. So from source to sink, we are going to transfer not the glucose but the sucrose, and it is going to be bidirectional. Now let's see what exactly happens over here. So my dear children, let's see the picture. These are the parts of your phloem. Okay, these are the different parts of your phloem. Over here you have sieve tube cells are there, and beside that you have your companion cells. You have what? Your companion cells. We are going to get one by one. So phloem tissues consist of two main types of living cells, sieve tube and then companion cells. They are the living cells out there. Companion cells are linked to the sieve tube members by pores in the cell wall known as plasmodesmata. If at all you are able to see, there are some pores over here. What do you call it? Plasmodesmata. Okay, and companion cells has so many mitochondria which could later help in active transport by giving ATP. So basically companion cells are like the exact companions that everyone should be having over here. Why? Because they have so many mitochondria that will be helping in ATP production also if at all we need it. Okay, done. Now let's go to the next thing which is there. Steps which are involved. So if at all you see, this is going to be what? A normal cell, palisade mesophyll cell, where photosynthesis is happening, right? Now if glucose is being made, glucose is converted into what? Sucrose. Glucose is converted into sucrose. This particular sucrose will be moving into what? The companion cells. The companion cells. From the companion cells, my dear children, suppose over here you had sucrose. Suppose you had sucrose, then still you will be needing more sucrose. How will you do that? With the help of active transport. You know, with the help of active transport, you can transport more of these things. So sucrose from companion cells is now going to go into what? Into your sieve tubes. Into your sieve tubes. This is what? This is your source. This is your source, right? So in the source, sucrose made in the source is actively transported into the companion cells. So here also, with the help of active transport, you transferred all this thing into the companion cells. From the companion cells, again you transfer it into what? The sieve tubes. So from the companion cells, sucrose moves into tube cells through diffusion. From here to here, it goes through diffusion. Whatever is there, it's higher here, it's lower here, so it will be moving to this particular area. Got it? Did you get it until now? Yes, it is inside. Now what happens? Water from the xylem tissue moves into the sieve tube. That is a very big thing. So listen to me. Parallelly, what do you have? You have xylem also. Now here, if at all you see, once these guys comes over here, the amount of solute is more, the solvent is less, which is exactly why water from the xylem would be coming what? Coming into the sieve tube. It will be coming into the sieve tube, right? So water is here, the food is here. What is going to be happening over here? what is going to happen over here? The pressure is going to be high. Now with this high pressure, things are going to move to area where there is low pressure, and this is known as what? Mass flow. This will be known as mass flow. So this movement of water could lead to increase in pressure in the sieve tube cell, and further would lead to mass movement of the phloem sap to the area where the pressure is low. It can go up, it can go down as well. Okay, and then suppose it has reached over here, that is the sink region. Suppose it is going to the root where it is going to be stored. Okay, so in that particular case, in the sink when it comes, the sucrose which is there, it will be moving into the companion cells. Yeah, the sucrose will be moving into the companion cells because there it was less, and then it will go to the root cells also by simple diffusion out there. Now also the water moves back from the sieve tubes into the xylem, so water concentration is also being maintained out there. That's all. Okay, is this particular thing clear? This is basically translocation of food. This is going to be what? Translocation in the case of plants through phloem. This is very, very, very important. Nisha, it will be getting over now, very soon. Ma'am, is there a separate channel for NEET prep in English medium? As of now, no. Okay. Is this clear, children? Now, I think that's clear. Now there is only one thing that is left, and which is excretion. With this we will be completing the chapter. So if at all it is clear, just give me a thumbs up. Yes, Nisha, tell me. Okay, so you guys are talking. I'll just explain about excretion and then I'll go on. So excretion, for that you need a basic thing that is known as nephron. So this thing that you see is a nephron. It is found in your kidneys, right? So listen to me carefully. If I talk about all the parts of a nephron, if I have to label it, it looks like this. This is going to be the Bowman's capsule. This is the Bowman's capsule. Here you see that the tube is there and the tube is coiled up, right? So you call this as proximal convoluted tubule. Why do you call it proximal? Because it is very close to the Bowman's capsule. Now you have something like this. What do you call this? This is known as Henle's loop, or you also call this as loop of Henle. Now you have again some coiled tube. What do you call them as? Distal convoluted tubule. Distal convoluted tubule. Why distal? Because it is a distance from the Bowman's capsule. Finally, what do you have? You have the collecting duct. You have the collecting duct or the collecting tube, which is going to collect the urine from all the different places out there, from all the different nephrons. Now listen to me very, very carefully. Your kidney is there, okay, your kidney is there. Kidney will be getting an artery from the heart, right? You call this as renal artery. What do you call this? Renal artery. The renal artery has to divide in a way that it goes to each and every nephron. So we say there is arterioles which are being formed over here. And in arterioles, there is one arteriole over here which you call as efferent arteriole. What do you call it? Efferent arteriole. So you have to imagine over here, this efferent arteriole is pretty narrow, it is pretty wide, and over here it is going to form a bunch of capillaries, and then it is going to be narrow from here onwards. So this is going to be efferent arteriole and this is going to be efferent arteriole. E for exit and A for A. Okay, why is it wide over here and why is that narrow over there? This is a very important question. So listen to me carefully. The blood that comes, okay, the blood that comes over here, it has to make sure that it goes to the capillary, and whatever small thing is there, whatever unique thing is there, it moves out into the Bowman's capsule. How will it move out? Only when the pressure is high. Only when the pressure is high. What do we do to make the pressure high? If at all we make it narrow, what is going to happen? The blood cannot easily move to that. There will be some pressure created over here. Slowly the blood will be moving out. That is why in efferent arteriole it will be narrow and here it will be wide. You got it? And now what are things are going to move out over here? There are going to be some ions. There are going to be some amino acids that will be moving out. Okay, there are going to be a lot of things that will move out. explain collected done. I will. Okay, I will definitely explain everything out there. Listen to me carefully. So this is the basic thing that is there. You call this bunch of capillaries which is formed with the help of efferent arteriole and efferent arteriole as what? Glomerulus. Glomerulus. Listen to me. Formation of urine has how many steps? It has 3 major steps, and 3 of them we are going to study right over here. So make sure you listen to me very, very, very carefully. Okay? Done? Let's go ahead. So let's go. First thing that is there, blood comes from the renal artery and moves through the efferent arteriole. It comes from the renal artery, it moves to the efferent arteriole, right? Next thing, glomerular filtration. This is the first step of urine formation. Over here, what is going to happen? Because of the pressure, certain components present in the blood moves from the glomerulus to what? To the Bowman's capsule. What are these things? Ions. What are these things? Water. Urea. This is a nitrogenous waste out there. Apart from that, glucose. Apart from that, amino acids. All of them are going to move out. Always remember, proteins will not. Why? Because proteins are large substances. It cannot move. Okay, it will not be moving. Rather, amino acids will move. Urea will be moving. Water will be moving. Ions will be moving, and amino acids will be moving. Okay, only small components could pass through. Altogether, what do you call this as? Filtrate. What do you call this as? Filtrate. This is glomerular filtration. Now, all this filtrate is going to move into what? The proximal convoluted tubule. And now the second step happens. So, if at all you see, my dear children, blood continues to flow through efferent arteriole, then glomerulus, then efferent arteriole, then moves to the capillaries, and later will be forming what? The veins out there. So, these capillaries are going to run around the whole nephron. These capillaries, the blood vessels, are going to run around the whole nephron. Later, you have a vein that will be carrying things outside. So, listen to me carefully. Second thing, selective reabsorption. So, when I say capillaries are all around, you need to understand that whatever came in as filtration during glomerular filtration, not everything is not useful for us. Some of it is useful for us, some of it is not. So whatever is useful for us, there is a chance for taking it back. For example, some ions in my body, sodium is less. I want to take back sodium, so I can take back sodium. I want to take back some water, I can take back some water. I want to take back glucose, my blood sugar level is less, I can take that also. What about urea? Urea is generally not taken. I'm not saying it is not at all taken. Generally, it is not being taken by this. So what are you doing? You're selectively, whatever you need, you're selectively reabsorbing it. Where is it happening? It is happening in the proximal convoluted tubule. Here, in the proximal convoluted tubule, selectively things are being reabsorbed. That is what you call as selective reabsorption. Always remember, PCT, proximal convoluted tubule, is the place where all this thing is going to happen. Note, some amount of urea is also reabsorbed. Some amount is absorbed, some is not. Mostly it is not, as I told you. Done. Now what? Now everything goes to the, it will be going to what? The Henle's loop or loop of Henle. And as I told you, they are forming capillaries all around that later forms the vein and stuff like that, right? So blood flows through the capillaries that traps around the whole nephron. And while all of this happens, there are so many other things happening in the background. What are the things that are happening in the background? Listen to me carefully. Tubular secretion is one such thing. So basically, once the blood reaches up over here, not the blood, basically once the thing filtrate reaches up over here, tubular secretion happens such that, suppose in your body you had some medicine, okay, you had some medicine, and now there are some components which are not needed by your blood. It has to be given back, but glomerular filtration has already been done. We have reached until here. Next step is what? Collecting duct. So what can we do over here? This is one thing that can we do, that is tubular secretion. Some things can be still given back from the blood to the tubules, and that is known as tubular secretion. Don't think that the tubule is secreting back. It's the blood vessels which are going to secrete some unuseful stuff back into the tubules. That is known as tubular secretion, which happens in the DCT, distal convoluted tubule. So over here, from the blood, certain components which are in high amount in the body and is of no use moves back into what? Into the nephron. So what all can move back from the blood to the nephron? Certain ions which could be increasing the pH of the blood, or certain drug which is there, it can be taken back. That is known as tubular secretion. Nisha, it will get over, dear. Okay, it will get over now. Last topic, it's there. Fine. Now, last what we have Henle's loop. Know the understanding of this. 3 steps which are there in the urine formation that is being done. Please know about Henle's loop also. here you have descending loop of Henle and ascending loop of Henle. Hello, I am descending loop of Henle. I am permeable to water and not permeable to solute. So what is going to happen? Water can easily move out from here to here. So your urine has to be concentrated. If at all you remove all the urine out there, basically what is going to happen? Water out there, your body will be dehydrated. So you do not want all the water to be lost, right? So here in descending loop of Henle, water is permeable. It can move out from the urine. It can move out from the urine. On the other hand, I am ascending loop of Henle. I am not permeable to water, but I am impermeable to solute. Okay, I am permeable to solutes. So solutes can move out from this side also. Ma'am, I didn't get it. What is the use of it? So listen to me. Ions move out by active transport. By spending some ATP, ions are going to move out. When ions are going to move out from here, solute concentration is going to go high, right? If you have solute concentration more high, what will happen? The water has to be coming in. The water will be moving out now, and when water moves out, tada, our urine will not be that concentrated. It will not be that concentrated. Did you get it? So what is the use? To concentrate the urine, we need loop of Henle. This is super important. Now, glomerular filtration rate in all nephrons together is 180 liters of filtrate. Please understand this. What is the filtration rate? It is generally 180 liters of filtrate is being filtered. But you know, how much do we urinate? It's just 1 to 2 liters. What happens to rest of it? It gets selectively reabsorbed. There is Henle's loop, concentrate the urine. Lot of things is happening over here. So that means that 98 to 99% of water is reabsorbed in the kidney. So a glomerular filtration rate is 180 liter, but only 1 to 2 liters of things are getting urinated every single day. Please know about this. This is super important. Okay, this is super important. Now, one more very important question. Suppose someone does not have a proper kidney out there. In that particular case, what do you have? You have hemodialysis, which is being done. Hemodialysis is being what? Is basically you are going to connect the artery, okay, to what? To a setup where you would be having so many, okay, you have a tube like this. Okay, you have a tube like this, and this tube setup is inside a fluid, dialyzing fluid. You need to understand that you are getting the blood from what? From your artery. And this particular fluid will not be having no urea or no nitrogenous waste will be there. Why no nitrogenous waste? Because, my dear children, this tube, that thing that you are forming is made semi-permeable. So suppose your blood is coming. In the blood, you have some proteins, you have some amino acid and everything. They have to move from here. But whatever amount of urea is there, it has to move from higher concentration to lower concentration, which is why you do not keep any urea over here. So that whatever urea is there or whatever nitrogenous waste is there, it will be moving outside. And you also have to make sure that the dialyzing fluid is being removed continuously. Otherwise, the amount of urea will be more. Okay. Further, so you have done that. So instead of your kidney doing it, you are doing it with the help of a machine, and later this particular thing goes back to your vein. So from artery it is connected and goes back to the vein to the heart. Okay. That is exactly how it works. Please remember, you give some anti-clotting things so that your blood also does not clot over here. This is very important. And the last part of the story is The last part of the story is basically how does excretion happens in the case of plants. Remember, excretion happens in the case of plants by multiple methods. If we are talking about water is removed with the help of transpiration. If at all you are talking about gases, so there is gaseous exchange of CO2 and as well as O2. If at all you are talking about some other things which are there, it is being removed through the help of gums, through the help of resins and everything. Apart from that, there is old and worn out leaves. Old and worn out leaves, they also shed down. So that is another thing which is there. These are the different methods that you have for plants. Is this chapter clear to everyone out there? Is this chapter clear to every single person who is watching this video? If yes, just give me your thumbs up. If yes, just give me a thumbs up. Yes. Pavani Putri, thank you. Okay, ma'am, clear. Thank you so much, Tinku. Okay. Pratap, please ask me the doubt. Sandhya, thank you so much, dear. NCNBUT, oh, they are, oh, wow. Thank you. Ma'am, what is your name? My name is Jasmine. You can call me JJ. Thanks a lot. Perfect, Nisha. Clear. Joshi Danny, thank you. Mohinder also, thank you. Okay. कि क्या materials reabsorb होता है? I told you, no, water, amino acids, ions which are there, they are getting reabsorbed usually. Okay, urea is not being reabsorbed usually, but some amount of it can be. Okay, perfect. Guys, we'll take a 15 minutes break because I am super tired, and think about a chapter that you want to do next, which is very difficult for you. I'll take that chapter on priority. Okay. So my tabiyat is not that great, which is why I'll try my best to complete the entire thing, but if not, at least I'll try to take up your doubts. Yeah. So let's take a break, and what next, ma'am? You tell me what next chapter you want. I'm ready to teach anything that you need. Cool. So let's take a break of 15 minutes. I'll be back at, so basically, Kit Kat break. Be back at 4:17. Okay. Hello dear children, are we all back? Are we ready for the next chapter? Hello, hello, hello. Yes. Guys, are we ready for the next chapter or? Okay, very busy, very busy. Okay then, since you guys, yes, Nebul, yes, Pavani Putri is also here. Okay, fine. Can you tell me, Sandhya is also here, which chapter is the one that is very difficult for you so that I can take that chapter first? Okay, can you tell me the name of the chapter which is difficult for you? I'll take that chapter first and then we'll go ahead. Hi, hello Nisha, hello Nidhi Sharma. Hello Chota Beam. Okay. How do organisms reproduce? Okay. Is that the one difficult for you? I can take that up. Okay then, let's go ahead. Yeah, let's go ahead. Heredity. Someone is saying heredity. Heredity. Yuan is also saying heredity. So heredity, okay. Kani is also saying heredity. Shall we state heredity first? Then let's take that first. Because I know it's actually difficult for a lot. And then I hope, dear, you will forgive me. We'll start with, how do organisms reproduce after that. So let's go with heredity first. Because I know it's difficult for a lot of us. So, okay. What do you mean by heredity? First of all, what is the meaning of heredity? Heredity basically refers to transmission of characters from the parents, okay? From the parents to their offspring. That is what you mean by heredity. And heredity helps in what? Continuity of the species from one generation to the another. These are the things that we generally know. Now, please know there are different type of traits. One trait is something that is inherited and the other one is acquired trait. What do you mean by inherited traits? Some things that we can get from our parents. For example, the color of our eye, the hair, okay, the type of ears and everything. These type of things are something that is inherited, which is why we call them as inherited traits. Now, for example, tomorrow I go to gym and I do biceps, okay? And my dear children, what is going to happen? Tomorrow I have big muscles being formed over here. Do you think in future my kids will also be having this, or basically in future your kids will be having this? No, this is acquired trait, something that you acquire during your lifetime. Acquired traits are something that are not going to be passed to the next generation. Please know about this, okay? Please know about this. So over here, one very important thing that you need to understand is that when I talk about sexual reproduction, there is involvement of two parents over here, right? Two parents means what? Two genetic material out there, different types of genetic material out there. Now when different genetic material comes together, obviously I am going to get something new in the progeny. The progeny, that is me and my father and my mother, we all look different. Why? Because I am a genetic combination of both of my parents, genetic materials out there. I am a combination of both of their genetic materials. Same goes with you as well, okay? In your case also it's the same. So one thing that is super important is that in which one do you think, asexual reproduction or sexual reproduction, will you be seeing more variations, more differences? Asexual reproduction is basically when only one parent is involved and this parent gives rise to progeny. For example, I talk about fission, okay, binary fission, amoeba dividing into daughter amoebae. It's just passing down, it's just copying the genetic material and passing down to the organism out there. There is no genetic variations that is going to come up over here. So which one do you think is having more genetic variation? It is definitely going to be sexual reproduction that has more genetic variations. And these variations, my dear children, can let an organism survive. Suppose there is someone with better variation. And here there is someone with lesser variation than us, okay? Now some problem came in, for example, a heat wave came in. Because of heat wave, since this organism had some variations within it, it survived. And since it has survived, it can go ahead and continue its species. But what about this organism which had less variation? Do you think that can survive? No, Baba. So basically, can I say this variation is helping us continue our species? Some good variations which are there, it is going to help us in what? Continuity of the species also. So always remember, asexual reproduction has lesser variation in comparison to what? Sexual reproduction. And these variations can be good and bad. The good variations which are there can help us survive in bad conditions as well. Now, we'll come to the basic thing which is entirely, so I do not want to talk about a lot of things out there which could confuse you. I'll come directly to the basic point. Listen to me very carefully, okay? Very, very carefully. So, if this is a chromosome, you need to understand that chromosome have sites. It is basically segment of DNA. So chromosome is basically what? DNA. A DNA is coiled around and that is how you get chromosome. Suppose there is a segment of DNA which is there. I will call this as gene. And what is this gene coding for? This gene is coding for a protein that is very important for the formation of my height. So can I say that this gene is regulating my height? Yes. So this is a gene. Suppose I am saying that this gene has varieties of it. I am saying that one is capital T and one is small t gene. Capital T gene is responsible for more height and small t gene is responsible for less height. What do you understand from this? That basically there are two different type of gene for one character, that is what? Height. There are two variations of gene for one character, that is height. Can I call these variations as what? Alleles? Can I call them as alleles? The answer is yes. I can call these variations of genes as what? Alleles. So for every character that you see, my dear children, you will have a gene and that gene will always have an allele. Now, when you call this particular combination and when I say that there is capital T allele and when there is small t allele, you need to understand that only one is going to express itself. The one that expresses itself is known as what? Dominant allele. So when someone has a combination like this, that is capital T, small t, please understand that. Why it is known as capital T? Because it is dominant. Why dominant? Because probably it is able to produce proteins and those proteins are responsible for giving more height. It is able to show its effect. This guy is also showing the effect. But which one is producing more protein? The capital one. Which is why I'll call this what? The dominant allele out there. The one that does not express in this condition is known as what? The recessive allele. So this is recessive and this is going to be what? Dominant. This is dominant and that is going to be what? Recessive. This is very, very, very important. Now listen to me very carefully. So us, when we talk about us, we can be having a combination like this. We can be having a combination like this. We can be having a combination like this. Suppose in one chromosome it is capital T. Another chromosome also it is capital T. What do you think? It will be tall or dwarf? What do you think? It will be tall or dwarf? The answer for this question is what? Guys, any idea? If a condition like this comes, what do you think? It will be tall or dwarf? Any idea? Oh my God. Tall. Kani says it is going to be tall. Exactly. Why it is tall? Because you have the dominant allele. That is why it is going to be tall. What about this? Here also, my dear children, since you have one capital T, it is going to overshadow the effect of small t, and here also it is going to be tall. What about this? Here there is no capital T, which is why they are going to have lesser proteins being made. That is what I'll say, that it is going to be what? Dwarf in nature. It is going to be dwarf in nature. Now listen to me. Condition where both the alleles are same. Here capital T and capital T is there. I'll call this condition as homozygous condition. What do I call it? Homozygous condition. Here when both the small t same, I'll call this as again homozygous condition. So homozygous dwarf and this is what? Homozygous tall. What about this? When you have two different alleles out there, you will call this as what? You will call this as heterozygous. You would call this as heterozygous tall because both the alleles are not same. Got it? So what do you mean by gene? This is a segment of DNA that is going to code for a protein. These protein, my dear children, which are going to be made, always remember, genes are going to code for proteins only. Now if at all you want height, probably you need hormones, growth hormones. Those growth hormones might need the help of these proteins. That is what we say, that a gene regulates the height by producing what? A protein. This protein will be probably helping in formation of some enzyme or things like that, or this protein can itself be an enzyme. Enzymes are proteins. I hope you guys know that enzymes are what? Proteins. Okay, so this thing that is produced can be an enzyme which will be helping in giving us height, or probably this can be a protein that can be helping another protein that can be helping us giving in height. You get it? These are the things that you need to understand. And and the different varieties of genes which is there, that is what you call as alleles. One is going to be dominant, which is going to be expressing itself in heterozygous condition, okay, and also in homozygous condition, and one is going to be recessive, which is only going to express itself in homozygous condition, that is small t condition. Is this clear, guys? Is this clear? Ma'am, doubt? Yes. Coming. All clear. Okay, perfect. Now listen to me carefully. Now I'll go ahead and I'll talk about the generations. Okay, suppose I am crossing tall plant and I am crossing dwarf plant. What do I call them? Homozygous. I also use the term pure breed. Please know I can also use the term pure breed. So there's pure breed tall and this pure breed dwarf. These are what? The parents. These are the parents. Similarly, you need the gametes. Gametes means basically what? You have sperm, you have ovum, right? These are the gametes. Always remember, gametes will not have both the number of chromosomes. It will have only half of it. Only half the number of chromosomes. So either it can be one capital T or it can be another capital T, another gamete. Similarly, one small t, another small t, another gamete. Suppose this T and this T came together, you got capital T, small t. This and this came together, you got capital T, small t. This and this came together, again capital T, small t. This and this came together, capital T, small t. This is what the first generation number 1, F1 generation. What do you think they are? How do they look? Guys, how do they look? Capital T, small t. How do they look? Are they tall? Are they going to be dwarf? Are they going to be tall or are they going to be dwarf? I'm just waiting. Divyanshu, good evening dear. Tall. Exactly, Pavani Putri, Kanni, as well as Swishal, Divyanshu, thank you. They are going to be tall in nature. This is what the physical appearance, and physical appearance is nothing what you call as phenotype. This is what you call as phenotype. Okay, let's cross this and see what is going to happen. Did it go? Yes, it went. Okay, fine. Anyways, so we were there. Let's cross this and let's see what is going to happen. Again, over here, these are the parents. Now the gametes, when you form them, it can either have capital T or can have small t. Either have capital T or can have small t. Now when I cross them for F2 generation, what do I get? This and this, capital T. What is going to be this? Tall or dwarf? What is this going to be? Tall or dwarf? This one is tall or dwarf? Come on, together we will do. Tall, exactly. So I'm writing tall, okay? This and this crosses. I get capital T, small t. What about this? What about this? Exactly. This is also going to be tall. Perfect, my dear children are super good. Okay. What about this and this? Capital T, small t. This is also going to be tall. What about this and this? What about the last one? Awesome. All my dear children are now active. Yes, that's the spirit. Let's make the other people who are talking in the class lose this particular thing. Okay, you should be winning up. Yes, they are going to be dwarf in nature. Now, my dear children, if you are asked about phenotypic ratio, as in how do they appear, what is the ratio? 3 of them are tall, 1 of them are dwarf. Can I say that 3:1 is the ratio? I can say that 3:1 is the ratio, right? It is not 3:2, it is 3:1. Okay, perfect. Okay, perfect. Now one more question. What is the genotypic ratio? What is going to be the genotypic ratio? Genotypic ratio is 1:2:1. What do you mean by genotypic ratio? As in, what is the genotype? What is the combination of genes? So here it is capital T. None of them are capital T. So I'll write 1 is capital T. 2 of them are capital T, small t, right? And 1 of them is going to be small t. So genotypic ratio is 1:2:1. Perfect, my dear children. You guys are awesome. And listen, we have to make others loose who are talking over here, who are doing loose charts over here. Let's make them loose. Listen to me very carefully. Which 2 laws are proved with the help of this experiment? With the help of monohybrid cross experiment. 2 laws were there that was established because of monohybrid cross experiment. What were those? What were those? Any idea? Law of segregation, exactly, that is one thing. There is one more law that is there. Apart from law of segregation, one more thing is there, law of dominance. Listen to me carefully. Here law of dominance is being shown. That is when you have a pair of dissimilar factors. He did not call this as genes or alleles, okay? He did not have that knowledge. He called them as factors. Whenever you have dissimilar factors, as in capital T, small t, the one which is dominant will be expressing and the one which is recessive is not going to express. This is law of dominance. Then law of segregation. What does law of segregation say? In a pair of factors, only one will go into a gamete, right? So isn't capital T the only one going into this gamete, right? Similarly, small t goes into that particular gamete. So always remember law of segregation as well as law of dominance is being proved over here. Now, one very important thing that I want to say is, if at all you are asked like this, how much percentage of them are going to be tall? If you are giving something like this and you have been asked how much percentage of them are going to be tall, what is your answer for this particular question? What is the percentage? What is the percentage for this? 75, exactly. 75% will be tall and 25% will be dwarf. Always when they give you tall versus dwarf, always remember tall can be like this, it can be like this. Check the question whether it is heterozygous tall or homozygous tall. Is it been mentioned? If not mentioned, so you have to think of both of these conditions out there. Okay, now let's go ahead with the next thing. Okay, let's talk about the dihybrid cross. Is this clear? Everyone, monohybrid cross is clear. Monohybrid cross means only one character is taken. Height was being taken over here. That is monohybrid cross. If it is clear, just give me a thumbs up. Everyone, quickly give me a thumbs up and we'll go on to the next one. Thank you. Perfect. Chalo. How to calculate, ma'am? What to calculate? So listen, 3 out of 1. 3 out of 1 is there. So total is 100%. Out of that 3, so I'll say 75%. Rest is what? 25. Okay. Okay, perfect. Clear. Thank you. Now we go to dihybrid cross. In dihybrid cross, we are going to take 2 characters at once. 2 characters are being taken at once. For example, you are going to talk about the shape of the seed and the color of the seed. Similarly, the shape of the seed and the color of the seed. So remember, in the shape of the seed, round is dominant and wrinkled, which is there, it is recessive. In the color of the seed, yellow is dominant and green is recessive. Remember that. Okay. Now, how do we do the cross? How do we do the cross? It's very, very simple. Listen to me carefully. This is where most of you get confused. Capital R, capital R. This is for round, right? Like tall, just like how we had for tall, just similarly for round. For yellow, we have capital Y, capital Y. Here you have small y, small r, and small y, small y. Now you have to make the gametes. How do you make the gametes? And this is where most of you do your mistakes. Listen, you have to imagine, use your imagination. The chromosomes are lined up like this. Capital R, capital R, capital Y, capital Y. Okay, from this pair only one can come. Whatever you do, it will be capital R only. From this pair only one can come. Whatever you do, it will be capital Y only. So you can get multiple gametes. You can get 4 gametes, but all of them will be capital R and capital Y. Similarly, from here also, you get small r, and small y. So from here also, from one pair one can come small r. From here one can come small y. Now you have to form the F1 progeny. Okay, now we want F1 progeny. So how do we do the F1 progeny? We have to cross this and this. So if at all we do that, capital R, small r, capital Y, small y. My dear children, how do they look according to chromosome? You have to know that. Chromosome wise, they look like this. Capital R, small r, capital Y, small y. This I got from one parent, this I got from another parent. What is the phenotype over here? Anyone? Can you tell me what is the phenotype over here? What is the phenotype over here? Why do we clean aquarium but not ponds? Because aquarium is something that there's an artificial ecosystem that we create generally, and we keep it at home, right? Ponds also we clean sometimes. Okay, and ponds will be having obviously lots and lots of decomposers out there. Naturally, there will be lots and lots of decomposers. Okay, such as fungi, such as flagellates, such as bacteria. Fine, which is not being found in the case of our the aquarium. In the aquarium, decomposers are not being found, right? Yeah. Fine. all round and yellow, all round and yellow. So everyone was saying round and yellow. Perfect. My dear children, we are letting others win. We should not make others win, okay? Those of them are talking. So it is round and yellow. So I'll write round and yellow. Why round and yellow? Because this is dominant over small r, this is dominant over small y. Now we had to do the cross because Mendel was like, is it round and yellow like this or it is like this? I do not know. He cannot see it. So he tried to do the cross and then he tried to see what is going to be the answer. So let's do that now. Okay, so I'm going to cross this with this. So when I cross this with this, just a second, okay, I'll try to go to that particular page itself such that, okay, perfect. So listen to me. I have capital R, small r, capital Y, small y. Similarly, I have capital R, small r, capital Y, small y. My gametes are going to look different this time. Why? Because I have capital R, small r, and capital Y, small y. From here one can come, suppose capital R came. From here one can come, suppose capital Y came. This is one combo of gamete. Fine. Now the next thing, from here capital R came, from here small y came. This is another combo. From here small r came, from here capital Y came. This is another combo. From here small r came, from here small y came. This is another combo. How many different type of gametes do you form over here? You get 4 type of gametes. Okay, how many type of gametes do you get, Baba? You get 4 type of gametes. Now listen to me. This plant gave these type of gametes. These plant also will give this type of gametes. So if at all you do the cross and if at all you write it like, so you are never asked to write it, always remember it, just need to know it, the phenotypic ratio at the end. So if you put all the gametes on this side, if you put all the gametes on this side and do the cross, capital R, capital R, capital Y, you do this for all those things line by line. How many of them do you get? You get 16 of them at the end. How many progenies do you get? 16 of them. But there is a ratio that you need to remember. And what is that ratio, Baba? The ratio goes like this. It goes like this. 9:3:3:1. How do you remember the ratio, phenotypic ratio? It's very, very simple. Okay, it's very, very simple. 9 of them are going to show the dominant parental character. What was the dominant character? Round and yellow. 1 of them are going to show the recessive parent character. What was it? It was wrinkled and green. It was wrinkled and green. 3 of them are going to show the new characters. Round was with yellow until now, but this time round will be with green. Wrinkled was with green until now, but wrinkled will be with yellow now. These are the non-parental characters, something that you did not see in the parents. Please remember that. Okay, please remember that. Stagnant, ma'am, what is stagnant water? The water which stays, which does not move, things that is known as stagnant water. Okay. Got it? Did you get it, guys? Over here, after doing the dihybrid cross experiment, which was the law that Mendel put down? Which was the law that Mendel put down after doing the dihybrid cross experiment? Any idea? Independent assortment, exactly. It was independent assortment that was being done. What do you mean by independent assortment? That means that when you talk about a character, a pair of alleles for a character and a pair of alleles for another character, this pair is going to segregate independently of this spread. That means capital R does not say that I will only go with capital Y. Does it say? No. You have different combinations. That is law of independent assortment. A pair of alleles of one particular character is going to assort independently, is going to separate independently of the other pair of alleles of another character out there. That is why, since you have multiple gametes, you get new combinations. Otherwise, you would not have got newer combinations. Is this clear? Perfect. My dear children are super good. Guys, is this clear? If this is clear, just give me. Okay, thank you, Devyanshu. And everyone who is talking, you are basically testing my patience. You might make me go and block you guys. Okay. Ma'am, physics numericals means Yashi Kumar, physics numericals would be coming up really soon, okay? She will be coming by 6 p.m. and you will be having your physics class being started. Ma'am, we will continue. Okay, perfect. So I was just going on and removing some people. Oh my God, this is too much. Fine. Now, listen children, there is one more thing, that is blood grouping. Do you know the blood grouping thing, or do you do not know about it? This is super important. Just a second. Also, before that, did I miss anything up there? Yeah. Guys, also the Mendel's 7 pairs of contrasting characters, I hope you guys know. Okay. I hope you guys know the 7 pairs of characters. Height. In height, you have tall and dwarf, that is tall and short. Now, seed shape, you have round and wrinkled. Seed color, you have yellow and green. Seed color, even though we have green piece, but actually yellow is the one which is dominant. Okay, remember that. Now, over here, seed coat color, it is, just a second, okay. Okay, this is wrong. Then you have pod shape can be inflated or full, or it can be constructed like this. Pod color can be green or it can be yellow. Flower position can be axial. Axial means what, my dear children? Suppose it's from the place where a branch is coming off, that is axial. If at all it's at the tip, it is known as terminal. Which one is dominant? Axial is dominant. And one thing that is being missing over here is what? The flower color. The flower color, you have 2 of things. One is the violet one and the other one is the white one. Which one is dominant? The violet one is dominant. The violet one is going to be dominant. Cool. Okay. Now, tell me, how many of you know to do the blood grouping thing? How many of you to know? Okay, Divyanshi, yes, violet and black. Violet and white. How many of you know to find the blood group? This is super important. Any idea about blood grouping? Ma'am, who will conduct the physics class? Dear Aditi ma'am is going to conduct the physics class, okay? Okay, chalo, you do not know, so let's do it. So blood grouping is also important, so please listen to me about blood grouping. So there is A blood group, there is B blood group, and there is there is O blood group and there is AB blood group. So listen to me. Here also you have multiple genes. I gene is there. It can be IA. If at all one allele is IA, another allele is IA, then I say that A blood group is there. Otherwise, when someone has IA and the other one is IO, in this condition also the person will be having A blood group. Why? Because A is dominant over O. Okay, so these two are alleles. These two are alleles out there. Fine. So in homozygous condition also you get A blood group. In heterozygous condition also you get A blood group if it is IAIO. Similarly for IB, what do you have? You need to have 2 of the alleles for IB, that is IB only. Now otherwise it can be IB, IO. Here B is also dominant over O, which is why you will get B blood group as well. This is clear. Now how will you get O blood group? When, in which condition will you get O blood group? That is the question. In which condition do we get O blood group? So you need to realize, since O is basically something which is not too dominant, okay, it is being recessive. So what do we say? This is going to show only in a recessive condition. It will be showing only in the recessive condition. Otherwise, it is not going to show up. Now, what about AB? AB is going to be seen when someone has one A and the other one is B. So, ma'am, here both of them are equally dominant. The answer is yes. They are the examples of codominance. Both of them are going to be equally dominant over here in this particular case of AB. Now, there's a question that is being asked and you need to answer that question. Guys, is this clear? This is super important. Okay. Sandhya, it is, but then saw a few questions around it, which is why I thought of making you solve this. Just have an idea of it. It could be helpful for you. Okay? Yes. Is this clear? That's all. just have a basic idea. I'm not saying anything else, just have a basic idea. Now, how is sex determined in the case of human beings? I hope you guys know that also. So in the case of males, my dear children, you will have XY chromosome. In the case of females, you will be having XX chromosome, right? Now, the gametes that are going to be formed is X and Y over here. Here it will be, just a second. It will be X and X over here. Just a second. It will be X and X over here. Suppose this and this came together, I get XX, that means it is going to be a female. If this and this came together, it is going to be again XX, that means it is going to be a female. What about this? This and this came together, X and Y, it is going to be a male. This and this came together, again it is going to be what? A male. What do you understand from this? That every single time there is 50% of chance for a female to be formed and 50% of chance for a male to be formed. Who is responsible for the sex of the child? Who is going to be responsible for the sex of the child? Any idea? It is going to be the male. Why? Because the males are the only one that can contribute two different type of gametes. That is either X or Y. Females anyway cannot bring that, right? Ma'am, questions on blood group. I'll give you an example. Okay, I'll surely give you an example. Just give me a second. I got a message. Okay, it is usually the father who is responsible for the sex of the child. Okay, guys, I'm going to tell you how do you get questions on the base of blood groups as well. Just wait for a second. Okay, one more very important thing is there, and that is being mentioned over here. Sex determination in the case of some organism. For example, crocodile or reptiles. In some reptiles, my dear children, sex determination is a temperature dependent process out there. It is what? A temperature dependent process. If at all the temperature is more, basically it will be males. It is the temperature is less, it could be females also. So there is what do you call temperature determinant sex determination as well. So please know that. Now I'll give you a question for blood groups. If at all I get a question, okay, if at all I get a question like, if a person is having B blood group and another person is having A blood group, what is the possible blood groups of the children? What is the possible blood groups of the children? How do you solve that particular question? If I am saying some people have B blood group, father has B blood group and the mother has A blood group, what is the possible genotypes or what are the possible blood groups in the kid, if at all that is being asked? How do you solve it? How do you solve it? Just a basic idea. Listen. IB is seen when someone has something like this, or it can be also the case when someone has something like, when someone has something like this, right? Similarly, IA can be somewhere something like this, or it can be condition where it is like this, right? Because it is also dominant over O and this one is also dominant over O. In this particular condition, I can get IA, IB. Whatever I do, I will be only getting IA and IB. That means only AB blood group is going to be seen over here. Whatever I do, only AB blood group is going to be seen over here in this condition. Now you have to think about this condition also. When I cross this with this, I get IA, IB. That means AB blood group. When I cross this with this, I get IB, IO. That is what? B blood group. When I cross this with this, I get IA, IO. That means again A blood group. Okay, then I cross this with this, I get IO, IO. That means O blood group. So multiple blood groups are being possible if at all a person is B and person is A. So please know about that. These type of questions used to come, but as I said, this time not sure it will be coming or not. Okay. Clear? Okay, children, tell me, what is the next chapter that you want me to cover? I can help you with that. Otherwise, okay, this is also, I already told you, right? this is important. How is trait expressed? Plant height depends on the amount of a particular plant hormone. The amount of the plant hormone will be dependent on the efficiency of the process of making it. So basically, height is dependent on what hormone? Now hormone is dependent on what? The enzyme which is responsible for this process. So enzyme is made how, my dear children? Basically a gene is going to code for a protein, and this protein is going to help in the formation of this enzyme, or this protein itself can be the enzyme, and this enzyme in turn help in the formation of hormone. A hormone will be helping in the height. So please know that gap. Ma'am, doubt hai, bolo bacha. Ayana, you can ask me. How do organisms reproduce? That is the chapter that you want next. Ma'am, is it recorded session? No dear, it is not. I'm clearly giving you the answer. It is not. Okay? Yashi, yes dear, tell me. By the way, children who are watching this particular video, have you subscribed to the channel yet? If not, definitely subscribe to the channel. Okay? Sandhya says control and coordination, and the other person, Pavani, was saying this thing, this chapter. Which one do you want? Everyone, let's vote and let's see what is going to be the answer. Divyanshu says how do organisms reproduce? Okay. I feel that is actually comparatively okay. Okay, fine. Coordination. The heredity is just been completed here. You can just go watch it. And life process is also completed. So I think I will be going with, let's go with how do organisms reproduce then. Yeah? Where is it? So we will cover the animal part first and then the plant. So, okay. First, let's start with different forms of asexual reproduction. Okay, we'll start with asexual reproduction. Guys, which one gives more variation, sexual or asexual? It is going to be sexual, right? Sandhya, I see, Sandhya, just after this, I'll be going ahead with control and coordination, okay? Don't worry. So I'll make sure this goes on really fast. We'll not take too much of time, okay? Fine. So dear children, listen, asexual reproduction is something that gives lesser variation. Sexual reproduction gives more variation. We know about that, right? Now, the first type of asexual reproduction is fission. Fission is what? When basically, this is something that is found in unicellular organisms such as amoeba, paramecium, plants, euglena, protozoa, etc., etc. Here, the parent plant which is there, it is going to divide into two parts. Into what? Two or more parts. Suppose if it is happening in two parts, I'll say it is binary fission. If it is happening in more than two parts, I'll say it is multiple fission out there. Binary fission is something that is very commonly seen in the case of amoeba. And there is one very important thing about amoeba that you should be knowing, and that is what? Yes, amoeba, leishmania, fission, exactly. So amoeba which is there, it shows irregular fission, as in basically it can cut from any direction and give rise to two organisms. That is what I mean by irregular binary fission. Okay, it is irregular binary fission, as in basically it can cut into two parts from any different angle out there. This is super important. Whereas when I talk about the next example of binary fission, which is leishmania, this is not the case. In the case of leishmania, my dear children, they have a particular fission, that is longitudinal fission. They will only cut in one particular direction. But before all of that happening, you should know one very important thing, that before a leishmania does binary fission, there is one very important thing. Here the cilia which is there, it is going to duplicate. Okay, there's a new cilia that forms first. Then, my dear children, if at all you see over here in the nucleus is going to divide. By that particular time, the cilia has also developed, the nucleus has also divided. Finally, it will slowly start dividing in one particular, direction. That is longitudinal fission. This is the case of leishmania. Both of them are showing binary fission, but not the same. And leishmania is the organism that causes the disease that is known as Kala Azar. It is causing the disease that is known as Kala Azar. Fine. Cool. Now there is transverse binary fission. Transverse binary fission, as in basically from the middle it cuts. That is found in the case of paramecium. Now everything else is not given in NCERT, so we should not keep in mind. Anyways, Okay. So whenever we say that an organism is undergoing binary fission, one thing that you need to understand is that it is immortal. An organism is there, it divides into two. Is it dying over here? No, it is just passing on the things to the next organism out there. So I'll say basically what it is going to be: immortal. Now what do we have? We have multiple fission. Multiple fission example, there is only one given in the NCERT, and that is what? Plasmodium. Plasmodium. Okay, before I go ahead with that, everyone tell me, what is that organism that causes malaria? The name of the organism that causes malaria. What is that organism that causes malaria? Plasmodium? Or is it the mosquito? Is it the mosquito or the Plasmodium? What causes malaria? Plasmodium, exactly right. So Plasmodium is the one that causes malaria, and how does it do that? Basically, it is going to form a cyst around it, right? And it is going to divide its nucleus. Later, cell wall formation happens, or basically, wall formation happens. Finally, there will be little Plasmodium being formed. So if at all you see, the cyst, when it breaks, there are multiple copies of this particular organism out there, which is why we say it is multiple fission that is being seen in the case of Plasmodium. This is important. Okay, just know about it. Now what do we have? We have fragmentation. Fragmentation is something that you see in Spirogyra. Is seen in Spirogyra. Spirogyra is basically a simple plant. You also call this as algae sometimes, right? And what is exactly going to happen over here? The Spirogyra which is there, it is going to fragment itself, and then from each of the fragment, new organisms are going to be formed. That is what you mean by fragmentation. So it is basically a process of breaking up the body of an organism into two or more parts called fragments, and then all of them, they are going to grow individually. They will be growing individually. Fragmentation is commonly observed in green filamentous algae, that is known as what? Spirogyra. Now we have one more process that is known as regeneration. It is what? Regeneration. Regeneration is basically when, it is basically when what is happening? Just a second. So a single part is there. Suppose I have a planaria over here. I cut it into multiple parts over there. This part is going to give rise to the whole planaria. Similarly, this part gives rise to the whole planaria. This part also gives rise to the whole planaria. So what do I get to understand? That a new organism is growing as such from the primitive organism, or the primitive part of the organism which is there. And this is not just seen in a planaria, but also it can be seen in the case of Hydra. Exactly, Neetu Negi. It is also seen in the case of Hydra. This thing is also seen in the case of Hydra along with planaria. But in Hydra, there is another technique which is mostly being used. Regeneration is famous for planaria. In Hydra, Yashikop, exactly. In Hydra, there is another technique which is known as, where is it? Budding. It is known as budding. So Hydra is something that forms new buds. So over here you can see clearly a bud is being formed. Later it forms a new baby Hydra out there, and then it will dissociate. Okay, so few multicellular animals, example Hydra, produce small buds. Remember, this is a multicellular organism out there, and it is going to form what? Small buds out there. These buds develop into tiny individuals, and when they fully mature, they detach from the body. Organisms such as Hydra uses regenerative cells. So over here, what do they have? They have some regenerative cells. They have some regenerative cells which have the ability to regenerate all the total organism out there. Got it? Yes. Next thing that we have is budding. Budding is seen in the case of the next organism which is known as yeast. So over here I have a picture. I do not know if at all this GIF would be clear, but yes. If at all you see this, they are growing. What is happening over here? They are forming buddies, and this is known as budding. So, here also, just like how you have in Hydra, here also you can see a budding, and this is commonly found in unicellular organism, that is yeast. So that was an example of multicellular organism. This is an example of what? Unicellular organism that you have. Okay, so budding is also observed in yeast. Yeast is a unicellular organism. A small protuberance appears on the upper part of the adult cell, and also remember, they form a chain of cells out there. Later on, it gets dissociated. From this newly budded cell, another bud appears at the tip. This process continues 3 to 4 times, resulting in what? A chain of cells out there. Okay? Guys, are you getting? There is only one more thing that is left, and that is spore formation. So basically, fission is done. and then we spoke about fragmentation in Spirogyra, we spoke about regeneration in Planaria and Hydra, we spoke about budding in the case of Hydra and also yeast, and now we have spore formation. Is this clear? Sandhya, thank you so much. Okay. Exactly, Neetu Negi. Perfect. So listen to me. Okay, perfect. Listen to me. Over here, in this particular case, in the case of spore formation, what is happening is that, first of all, these things that you see is known as mycelium. And mycelium is made up of hyphae. It is made up of what? Hyphae. Fine. So, there's a thing that is written over here. Let's read it out one by one. Spore formation is common method of asexual reproduction which occurs in Rhizopus. Rhizopus is what? The bread mold. It is what? The bread mold out there, right? Now, bread mold is also the organism that does what? Saprophytic type of nutrition, right? Remember? Yes. Now, spores are minute, single-celled, thin or thick-walled propagules. They can be thin-walled or can be thick-walled propagules are there, released from the parent body from the tiny blob on a stick-like structure known as sporangium. So, blob on a stick means like this. This is known as sporangium. Inside that, what do you have? You have so many spores. Present at the top of the stalk-like structure is called mycelium. So, this thing that you have over here, what do you call this as? Mycelium. Mycelium, on the other hand, is made up of what? Small hyphae. So basically lots of hyphae comes over here to form a mycelium. Generally, spores are dispersive in nature and are able to withstand unfavorable conditions. That is why spores is important. So if at all you have seen, no, if at all when we go to some fridge and all, even though we keep things in the fridge, sometimes we can see that a bread mold, a bread is getting bad because the mold is being developing. Why? From where did this mold come from? Fridge is a closed setup. Always remember, basically over here the spores of the organism might already be there. Now whenever it got a correct atmosphere, correct conditions to grow, it grew up there. So spores is something that can withstand any environmental condition, extreme conditions out there, since they are thin and thick-walled propagules out there. Got it? So please know that. And here is the actual picture of the organism. Okay, in a bread mold, the structure is labeled as A and B. Can you tell me the name of the structures labeled as A and B? Anyone? So if at all you're able to see, I think you will be able to say also. This is A and this is going to be B. What is A and B? Here you have the options. You have the options like this. This is sporangium, okay? This A, is it A or is it C? Is it A or it is C? Ma'am, should we take a little break? I will definitely give you a break. So definitely soon I'll be giving you a break and I'll be giving over the mic to ma'am, physics ma'am. Okay, it is going to be C. Why C, Baba? Over here, listen, it's a fungi. It does not have root. It has root-like structures. All of it is made up of what? Hyphae. So basically, either you call them as rhizoids or basically you can call them as hyphae. So answer for this is A is what? Basically, A is going to be hyphae for sure. What about B? B is sporangium. Inside the sporangium, what do you have? You have spores. So, yeah. Now, those of you confused between this and this, since they have no, I mean, it can be spores also, but then you have to be safe. So, which is why you mentioned sporangium. Okay? Got it? Let's go ahead. Now, we have vegetative propagation in the case of plants. So, in the case of plants, you do not call it as asexual reproduction, rather you call this as vegetative propagation. Vegetative propagation is basically when the development of a plant occurs by asexual means from the other plant parts. For example, somatic plants, these are not something that forms the gametes and things like that. For example, what do you have? You have stem, you have leaf, you have root and stuff like that. Stem, leaf, root, all of it. They can be giving, what do you call? The branch of potato bryophyllum, exactly. They can give rise to a whole plant. So there is no involvement of any seeds. Please remember, in vegetative reproduction, there is no involvement of seeds over here. Very, very important thing. So there are two types of vegetative reproduction, natural and artificial. Let's talk about natural first. So what is the use of vegetative propagation? First of all, even seedless plants can produce viable things out there, right? Even seedless plants can go ahead and produce, and plants that produce seeds can also reproduce and give rise to clones. So plants which can produce seeds, they can also rely on asexual method and basically can make exact similar plants. They can make clones. So in asexual reproduction, basically there is no involvement of two parents, which is why it will be exactly similar, right? And then this mode of reproduction is definitely faster. And over here you have natural vegetative propagation. The first one that you have is bryophyllum. Okay, at the tips of it, the notches of it, what do you have? You have some buds. These buds will be falling down and giving rise to the whole new plant. Similarly, over here in the case of potato also, you have some buds, right? This is the root. So this thing that you see over here is nothing but a root. A root is just modified, and on this root also you have structures like this, which can give rise to what? Will give rise to whole new plants. This is sweet potato. So potato, sweet potato, everything is an example for this. Now, artificial vegetative propagation is basically when you have humans being involved in the process of vegetative propagation. That is what you mean by artificial vegetative propagation. And that is being seen over here, for example, cutting. Okay, you might have seen that in the case of rose and sugarcane, these examples are very important. Okay, in the case of rose and sugarcane, what are you going to do? You are going to cut, okay, newer growth from plant below the growth node. Okay, so basically you are going to cut it, and then you are going to put it some planting hormone, and then you are going to put it in the in the soil out there. What is going to happen? Basically, the cut part should be having some buds, such that these buds can grow into a whole new plant out there. So the part which is used in cutting has nodes which have axillary buds which will help in propagation. So nodes is super important. If at all that is not there, then obviously nothing is going to happen. So that is cutting. Now we have grafting. Grafting is basically when, again, you make a cut over here. You have two different type of plants. You make a cut like this there, and you make a cut like this in between there, such that two different plants can be sorted and they can be taped together. This is known as grafting method. Since you're putting it on something, you call this as scion, and the portion which is down there, it is known as the stalk. The stalk is there, scion is there. What do you do over here? Grafting is the act of placing a portion of one plant, it can be bud or scion, on the top of a stem, root, branch of another plant which is there. The part of the combination that provides the root is called the stalk, and the added piece is known as a scion, and both of them together. So for example, in down there can be another variety of mango, in the top another variety of mango. So basically I get two things all at once. I get two of them all at once. Okay, now you have one more technique that is known as what? Layering. Layering is found in jasmine plants. My name is Jasmine. Similarly over here also, in jasmine plants, layering is being done. Well, what do you do is that, suppose you have a bud over here. Okay, you have a bud over here. You take this plant and you put it inside the soil like this. From this bud, new roots will be growing, and here a new plant will also be growing. So layering is a method of asexual propagation in which a stem is made to produce roots while still attached to the parent plant. The parent plant provides a new plant with water and nutrients while the roots are forming. Done. Children, and last one that we have is tissue culture. Tissue culture is a very, very, very easy technique that is there. Tissue culture is when, what are you going to do? Suppose you have a plant over here. You are going to take the tip of the plant because it has meristematic cells. Okay, meristematic cells are the ones that can keep on dividing. So you take this particular part, okay, you call this particular part as X plant, because it's now not a part of the plant, it is X, right? So this is known as X plant. Now this X plant which is there, the X plant which is there, it is put inside a medium. It is put inside a medium where it can grow. It can grow into what? Into multiple cells out there. These cells which are going to be formed over here are known as callus. This is a group of cells which is going to be formed, and this is what you call as callus. Now this callus which is there over here, okay, it is put in a rooting hormone such that the callus which is there, it can give rise to what? Root. Later it will be giving rise to shoot, and that's how you get a whole new plant. That is tissue culture. In tissue culture you have to make sure that you only take the meristematic cells. Got it? Yes, Vishal, tell me, what is the doubt? Tell me, what is it out? I can take it up. Oh, yeah. Ma'am, once more, I can definitely tell that. Okay, listen to me. What do you take is that you take the tip of the plant, or you take any bud portion wherever you have meristematic cells. Since it is not a part of the plant, you will call this as explant, right? Now this explant you are going to grow in a medium such that the cells over here can grow and divide and become a group of cells. This group of cells is known as what? It is known as callus. Now this callus, I can put it in a rooting hormone medium such that it can form root. Similarly, I can put it in another medium that has shooting hormones. It will form shoot. So shoot and root is ready. Now I can put it in some soil medium, and basically this can give rise to a whole new plant out there. Did you get it? Okay, did you get it? Dead short. Physics class is going to start by 6 o'clock. Ma'am, by the way, I am from UP board. Wow, good. Okay, perfect. So yes, is this done? Dwarfism, Baba. Ma'am, you're explaining so good. I wish you could be my bio teacher. Thank you so much, Santya. That means a lot. Okay, Vishal, ma'am, dwarfism means, dwarfism is a condition where in your body the growth hormone is produced less. You might have seen dwarfs out there, right? It's a condition that occurs when in your body the growth hormone is being produced less. Similarly, if at all it is produced more, you will have gigantism. Okay? Okay. Perfect. Now, now we go to sexual reproduction in the case of flowering plants. So here also I would not, okay. Guys, in sexual reproduction in flowering plants, what are the doubts that you are having? I'll take that up. I think that will be more easy. What is the doubt that you are having in sexual reproduction of flowering plants? Okay, you guys are super busy. Fine, I'll explain myself then. Ma'am, is it live? Yes, Shrikar, it is live. Okay, chalo, I am telling. So here, when you talk about the plant, you have a female reproductive part which is known as gynoecium. It is known as gynoecium. You have the stigma, you have the style, and you have the ovary. Similarly, there is a male part which is having filament, and there will be anther over here. There is what? Anther over here. This is the male part. Fine. Now listen to me very carefully. The anther which is there, if not any, we will move on to control and coordination. Yes. Exactly, we can. Ma'am, only functions and parts of reproductive organs. Okay, fine. Okay, let's deal with that first. Listen to me carefully. So over here, one very important thing which is there is that anther produces what? Anther produces the pollen grains. Anther produces pollen grains, right? Now the pollen grains which is there, suppose this is a pollen grain. A pollen grain always have 2 male gametes. How many male gametes? 2 male gametes. Always remember that. And the ovary will be having what? Ovule. Inside the ovule, what do you have? You have the embryo sac that has the female gamete. It has the female gamete. Remember that. So basically, the pollen grains, when it lands on this, it is going to form a pollen tube, and this pollen tube is going to get entry into the ovary, and basically what get entry into the ovule, and then basically the male gamete, one of the male gamete is going to fuse over here to produce what? To produce the zygote. This zygote later forms the embryo. But whenever fertilization takes place over here, I'll say that the ovule is not known as ovule anymore. It will be known as seed. Similarly, ovary will not be known as ovary anymore. It will be known as a fruit. Similarly, you have one more male gamete out there. What happens to that male gamete? That male gamete, my dear children, the second male gamete which is there, fuses with another cell over here. Fuses with another cell. So another male gamete which is there, it fuses with a cell which you call as central cell and produce one very important thing which is known as primary endosperm cell. which is going to later form what? Endosperm. And this endosperm is actually very important for conversion of zygote to an embryo, for providing nutrition to the zygote such that it will be forming the embryo. Since fertilization is occurring twice, I'll call this as double fertilization. Why do you say fertilization is occurring twice? Because one male gamete fused over here. First fertilization, this is known as syngamy. You get zygote over here. Second fertilization, one male gamete, the second male gamete fused with central cell, forming what? Primary endosperm cell, later forming what? Endosperm, which provides nourishment out there. Get it? Okay? Got it? Ma'am, can you teach me offline? Oh my god. Ma'am, वो तो stamen और pistil होते हैं. So listen, this is stamen. It is also known as androecium. In other terms, this is pistil or carpel. You also call this as gynoecium. Okay? Dead short, I am coming to that question. Okay, baby, I am coming to that question. Just wait for some time. Okay. Now, this is one very important thing. The second thing that you have is basically the male and the female reproductive system. We'll talk about that also in the case of human. Oh, by the way, there are some flowers. No, there are some flowers where you have both the parts. What do you call these flowers as? You call this as bisexual flowers. Examples of bisexual flowers, H&M. H&M you might have visited. H&M is a dress store, right? So over here, H stands for hibiscus and N stands for mustard. N stands for mustard. Similarly, my dear children, you have unisexual flowers, such that you have only one sex in one particular flower. These are found in PW. PW stands not for physics wala. Here P stands for, Phi stands for papaya, and W stands for watermelon. W stands for watermelon. Please remember this. Please remember this. Okay? Ma'am, is diagram, it is good. Please make the diagram. Yes. Ma'am, what do you mean by post-fertilization? In the case of flowers, post-fertilization means once, basically, when I say that a zygote is being formed. Zygote is being formed at the end of fertilization, right? So what happens after the zygote is being formed over here? So what is the thing that happens? The zygote will transform into an embryo, right? The zygote, so listen, pre-fertilization, ovule was ovule and ovary was ovary, but after fertilization, ovule becomes a seed and ovary becomes a fruit. Apart from that, my dear children, there is embryo formation happening up over here. Embryo is being formed over here, right? And this embryo will give rise to a whole new plant. If at all you have seen, there is a structure like this given in your NCERT. These are basically cotyledons. Cotyledons are something that is going to provide nourishment to the embryo, parts of the embryo. These are all parts of the embryo only. This is plumule. This is going to be plumule, which forms the future shoot, that is the stem, leaf and everything. This is radicle, which forms the future root. And these cotyledons are going to provide nourishment for it to grow like that. Okay, so these are the few things that happens in post-fertilization. First thing, endosperm is being formed. I told you. Zygote is being formed and zygote transforms into an embryo. Apart from that, one more thing is formed, that is known as endosperm. This endosperm is something that provides nourishment to the embryo. This is something that provides nourishment to the embryo. Now, once an embryo is being formed, it can have endosperm or it will make its own nutritional thing that is known as cotyledons. Done. These are few things that you should know. Okay, ma'am, doubt. Yes, Stroller, tell me. This is one very important thing. Now, cross-pollination and self-pollination you should be knowing. And yeah, guys, if at all, do you have any doubt in the reproduction of human beings as well? Otherwise, I'll go with control and coordination chapter. If at all you do not have any doubts in this chapter anymore, as in case of human reproduction, I will be going. Agents of pollination by Baba, it can be biotic agents or abiotic agents. Abiotic agents, for example, you are talking about living organisms such as bees, honeybees, flies, anything like that. They are biotic agents. Abiotic agents such as you have wind, water, everything, air. Okay? Okay. Guys, ma'am, continue. Okay, so continue as in I'll be going to the next chapter, or do you want the... Okay, fine. Listen. Over here we come. Where is it? We'll come to the female part, okay? In the female, my dear children, this is the reproductive system. Over here you have 2 ovary, right? Then you have this thing that is known as fallopian tube. Also you call this as oviduct. And then you have something like this, which is known as what? The uterus. The uterus which is there, it will be having a region like this, which is known as what? The cervix. And lastly over here you have the opening to the reproductive system, which is known as the vagina. These are the few things that you should be knowing. Where is the ovum going to be formed? The ovum is going to be formed over here inside the ovary. Okay. Where does it go? The ovary is going to release the ovum, and basically the ovum is going to be transported over here, and it stays at this particular position. It stays up at this particular position, and then it waits for the sperm to come. The sperm is being released in the vagina. The sperm travels down, and basically if at all the sperm comes over here and I say fertilization has taken place, if I say fertilization has taken place, I get to understand that there is a formation of zygote. Always remember your gametes, whether it be sperm, whether it be ovum, always remember both of them are going to be haploid in nature. They are going to be haploid in nature. That means they will have only half the number of chromosomes. Haploid number of chromosomes comes together to form what? A diploid zygote. It will be forming a diploid zygote. This is super important. Got it? It forms a diploid zygote. Now basically what, my dear children, also understand, when I say talk about the uterus, when I say zygote is being formed, the zygote is a single cell, but it will later divide and form an embryo. And this embryo needs to have nourishment, right? This embryo which is there, it needs to have nourishment. How will it get that? The embryo which is there, it will roll down over here and get implanted into the innermost layer of the uterus. The innermost layer of the uterus which is there, it is known as endometrium. Endometrium is the innermost layer where the embryo will come and get implanted. It will get settled up there. This endometrium is going to provide the initial nourishment to the embryo. Later on, both the embryo as well as the mother's tissue is going to form something else which is known as placenta. And this placenta will be later providing nourishment. So placenta will be looking something like this, it will be connected. It will be connected to the fetus with the help of umbilical cord. So this particular placenta is being formed with the help of the cells of the embryo, also from the maternal tissue out there. And this placenta is going to help in the exchange of important gases, removal of waste substances out there. Okay? Is this clear? This is the case in the case of female reproductive system. Doubt on barriers and how size population depends on. Okay. We'll come to that, okay? Now, listen to me. You have the male reproductive system as well. We'll just study about that also. So, by the way, this is the placenta, yeah? And where is the male reproductive system that is given? Here, the picture, yes. Okay, anyways. You are talking about the barrier. Guys, do you need an understanding about male reproductive system, or shall I go ahead? Please know about it. It's important. Okay, ma'am, clear. Perfect. Listen, these are certain barrier methods. So there are contraceptive methods that you should be knowing, and the first method is what? Barrier. Barrier method is something that will not be allowing the male and the female gametes to come together. It is a physical barrier, as like a curtain in between. Okay, it's a curtain like in between. Also remember, barrier method, especially in barrier method, one such thing is condom, and that is the only thing that can prevent sexually transmitted diseases. Why? Because it does not allow genital fluids to mix up. It does not allow genital fluids to mix up. That is why it is like a barrier. Always remember, this is the only thing that is also act like a contraceptive method, and also something that prevents STDs. Over here you have barriers. Male condom is there. Female condoms are there, which has to be inserted until the cervix. There will be a closure over here. There will be opening over here. Right. Similarly, you have diaphragms and lot of other things. Now you have intrauterine contraceptive methods. These are something that you put inside the uterus. Okay. You put it inside the uterus, and what do? Basically, they they can be releasing some copper ions. Copper ions does not allow the sperm to move around. It does not allow the fertilizing, it does not allow the sperm to fertilize as well. So that is the utility of the copper ions out there. Apart from that, there can be IUDs which will be releasing some hormones, and these hormones will not allow the endometrium to thicken up. If endometrium is not thickening up, do you think the embryo can get implanted out there? No. So again, it is a contraceptive device, that is intrauterine contraceptive devices. Second, you have surgical method or sterilization is what you call them. What do you do over here? You are going to cut the fallopian tube in the case of females, or you can cut the vas deferens in the case of males. Both of them are the places through which the sperm and the egg is going to travel. If at all you're cutting it, transportation does not occur. Please remember, a person who has undergone the surgical method, as in when you cut this vas deferens over here, still sperms are going to be produced, but these sperms cannot travel beyond. Okay, spermatogenesis happens over here, sperm formation happens, but it cannot travel beyond. Similarly over here also. Okay, similarly over here also, the egg is being released, endometrium is being formed also every single time menstruation happens, but the egg cannot travel through. That is surgical method. So please know about this method. Last is oral pills. Oral pills is also when again you are giving hormones, progesterone, estrogen out there. These hormones creates imbalance. Usually in our body we need it, but whenever it is not required at this particular point of time, we need it generally, but if at all it is given in extra amount, it is going to create an imbalance in our body. It will not allow ovulation, that is release of egg, to happen. It does not allow the endometrium to be thickening up. That is how it is going to prevent conception. Yes, fine. So yeah, okay. And Tamil konjam. Okay, I do not know it too much, but I definitely can understand it a bit. Okay, so let's go. Ma'am, break. I'll just complete this, then I'll go only, dear. Okay. Yashikor, I know you guys need a break. So let me complete control and coordination, and then I'll give you a break. Will that work? Okay, in control and coordination, the most, so someone was asking me about one very important thing, that is how is the neuron getting to transport things. So let's go ahead. Let's see that. Okay, I will okay, listen to me very, very carefully. Okay, listen to me very, very carefully. This is how things happen in this particular case. Ma'am, I asked for control and coordination. Yes, dear, we are going to do that. Santhya. Okay? Fine. Listen to me. You have the neuron. It looks like this. Okay? This is known as the cell body. You also call this as cyton. You also call this as soma. Okay? Here you will be having the nucleus and all the important organelles are there. Apart from that, you would be having the dendrites. Okay. Then you have something which is the extended part of the neuron, which is known as an axon. An axon is going to terminate. It will be having some terminals up there, which is going to be known as what? The axon terminals. Right? Over here, you have some knobs. What do you call these knobs as? Usually we call these knobs as presynaptic knobs. Why presynaptic? Because the space between one neuron and the next neuron out there is actually known as synapse. It is known as generally a synapse. Suppose a muscle is there, the next one is a muscle and not neuron. You will have a specialized name for the synapse. If at all there is a muscle, you will call this as neuromuscular junction. You will call this as a neuromuscular junction. Cool? Okay, now listen to me very, very carefully. Over here, in this particular condition, one very important thing happens. when I say that from here, suppose, and also one more thing, in this particular knobs, you have some neurotransmitters. What do you have, Baba? You have some neurotransmitters being released, some chemicals which are there. So suppose these neurotransmitters are released over here. Supposing, I'm just supposing. These neurotransmitters are going to go and attach on the receptors of the dendrites. What do I call them? Receptors of the dendrites. This is a chemical. Okay, these chemicals are going to go and act on the receptors of the dendrites of the next neuron, right? What is going to happen over here? Let's suppose it was this particular neuron. Let's see what is going to happen on this particular neuron if the neurotransmitter is coming and attaching. When it attaches, my dear children, some ion channels over here are going to open up. So listen to me. There was axon terminals first. From the axon terminals, you have got some chemicals released into what? The synapse. And these chemicals, my dear children, are now going to act on what? The next neuron's dendrites. Now, in the next neuron's dendrite, what is going to happen? The chemicals which is there, the chemical signal is going to transform into something else, which is known as an electrical impulse. Why an electrical impulse? That is a question. So when I say these ion channels are opened up, some of the ions comes inside, some of them are going to move outside, which is going to change the membrane potential over here. There's a potential over here. That membrane potential is going to be changed. Okay, this particular membrane potential is going to be changed. So many ions are going to be opened up, will be closed up, and things like that. So it keeps on going. When I say it keeps on going, I mean that ion channels are opening. The backside is closing. An electrical impulse is being created. It is created why? Because the membrane potential is being disturbed. Okay, the resting membrane potential is now changed, which is why this is happening. And it keeps on until this particular point where finally they are going to release some neurotransmitters out there. So if at all you are asked about the flow of this, please know this is the flow. From the axon terminals, some chemicals are released in the synapse to dendrites. From the dendrites, the chemical signal transform into electrical impulse. They travel through the axon. Again, they will be making it release. If at all this is muscle, it will be known as a neuromuscular junction. Otherwise, it will be known as a synapse. Done. Is this clear to you? Drink water. Thank you so much. Is this clear to you, every one of you? Sandhya, what do we mean by myelin sheath? These are extra insulation which are being provided over here. These are actually made up of cells. But in your NCRT, happily they have not mentioned much thing about myelin sheath. So myelin sheaths, whenever they are there, they help in basically increasing the speed of the whole thing. It helps in increasing the speed of the whole thing. Why? Because ion channels will be opened up here, next one will be here, next one will be here. So basically the impulses can jump. We say impulses jump. It's not actually jumping. Basically we mean that it is going in high speed. Okay, whenever myelinated sheaths are there, it will be high speed thing that is going to be happening. Okay? Does this work? Now, the next thing which is important in this particular chapter, control and coordination, is about the reflex arc. The reflex arc. Reflex arc is also super important. Please know about that. Can I remove this if it is okay? Can I remove this if at all it's okay? Just give me a thumbs up if it's fine. I'll remove this and I'll go ahead with the next one. Yes, perfect. Motor neuron means, yes, I'm going to come with that. Come on, let's see. So, okay, so what is happening is that, suppose I have some hot thing over here and I touch it. Basically, with my fingers, I touch it. What is going to happen? When it is something hot, my receptors over here, what are these receptors known as? Sensory receptors. They are going to become super active. Okay, and basically, what should be my next step? My next step should be to take away my hand from here. But for that, a signal has to go. Will it go to the brain or to the spinal cord? First of all, you need to remember that who is going to take the signal? It is going to be a sensory neuron. Sensory receptors have linked with sensory neurons. The sensory neurons will be having link with what? Basically your spinal cord. your spinal cord. In the spinal cord, my dear children, you have a neuron that is known as relay neuron. You also call this as interneuron. You also call this as interneuron. Now this relay neuron, interneuron, gives signal to the next neuron out there, that is known as motor neuron, and the motor neuron will carry this signal until the effector organ out there, which is usually a muscle. Now the muscle is going to contract, and that is how we are going to pick up our hand. Suppose this whole thing happened including your brain. Okay, there was brain also being included over here. What do you think what is going to happen? My dear children, if brain is involved, we'll think about it and then only we'll move our hand. We do not want the thinking action to be done, which is why directly goes to spinal cord. But also remember, information travels to the brain also. Information is stored, which is why we remember something bad. If at all it has happened with us, we remember it. Why? Because something has gone to the brain also, some information. Now listen to me carefully. Sensory neuron has another name to it. Please remember it. It's important. It is also known as efferent neuron. It is known as efferent neuron. Similarly, the motor neuron which is there, it is also having another name which is known as efferent neuron. E for exit. And here relay neuron or interneuron. Got it? This whole thing which is there, it is known as a reflex arc. Is this clear? Is this clear to everyone out there? If it is clear, just let me know. Just give me a thumbs up, everyone who thinks that it is absolutely clear to you. By the way, children, the complete notes, you can download it. Okay, the question bank PDF is here. You can download it. Click on the link and go get yourself downloaded. Go get it downloaded. Okay, thank you, Sandhya. Thank you, Vishal. Okay, I'll go ahead with the next thing. Thank you, Neetu Negi. Okay, fine. Perfect. Let's go ahead with the next thing. Over here, listen, I told about sensory receptors, right? We have multiple receptors out there. The receptors on our tongue, this is for tasting. On our tongue, we have receptors. What are these receptors used for? This is gustatory receptors. So I remember it like gustatory, okay, gustatory, but it's not actually tastery, it is just statory. It is gustatory receptors. Similarly, over here, apart from the tongue, you have multiple other regions. For example, you have nose. In the nose, you have receptors. You know, you get a different smell of oil, so you can remember like olfactory receptors. Olfactory receptors. So that is for sensing the smell of oil. Okay? Got it? Got it? Similarly, you have multiple other receptors. For example, in ear, you have phonoreceptors. Phonoreceptors. In your eyes, you have other receptors which are known as photoreceptors. So multiple receptors are there. Please know about that as well. Okay? Done? Respiration doubt, ma'am. Please ask me, dear. I have already explained that if at all you can, just go back and see. Otherwise, I'll be missing on this particular thing. Right, Roller? Okay, perfect. Now we have different parts of the brain. I'll explain that also. So my dear children, we have the forebrain, okay, listen to me carefully. First is your forebrain. In forebrain, you have three very important things. One thing that you have is your cerebrum. Cerebrum. Now, cerebrum, why it is important? It is the one that controls all your voluntary actions. For example, when I say that as of now, I am picking up a pen. I am picking up a pen. So this is a voluntary action, right? So this is the one that controls your voluntary action. Suppose you're reading, you're writing, everything, listening, whatever you're doing, your cerebrum is being involved, and this is the largest part of your brain. Similarly, suppose you're feeling hungry, you're thirsty, you have another part of your brain which is known as hypothalamus. Hypothalamus is the one that is responsible for all your physiological functions. For example, you feel thirsty, you feel hungry. It's because of the hypothalamus. So H and T, you can remember like that. Hungry, thirst. Okay, you can remember it like that. This becomes a part of what? This becomes a part of your forebrain. Is this clear? Please remember, cerebrum is the largest part, and basically cerebrum is responsible for your voluntary actions, such as I told, talking, listening, picking a pen, I'm so sorry, things like that. Okay, the next thing that we have is your midbrain. So midbrain, a very common function is not being given about midbrain. It's just said that basically all the receptors, or basically all the news which is there, it is being transferred. It acts like a relay point. It acts like a relay point such that everything goes off. Also, one more very important thing, forebrain is the place where you have all the different places. For example, olfactory lobes, that is responsible for your smelling. Okay, olfactory lobes, this lobe, that lobe, tasting lobe, everything which is there, it is there in your forebrain. So all your information, suppose you are basically getting a smell, it goes to your forebrain, and that is how you will be recollecting about it and coming in back. Okay, so please remember that. Please remember that as well. Now what do you have? You have the hindbrain. You have the hindbrain. And how does the hindbrain work? Hindbrain has multiple parts. One part is going to be the cerebellum. It is going to be the cerebellum. The second part that you have, okay, we'll go one by one. Okay, cerebellum is something that is responsible for posture and balance. Suppose you might have seen people who drink, they cannot walk peacefully. Okay, they walk like this. Why do you think they walk like this? Because their cerebellum is being affected. So your posture and balance is being maintained by what? Cerebellum. And how do you remember it? L, which is there, it's like this, straight, right? So for us to be straight, it is cerebellum, not cerebrum. Do not go and write cerebrum and come over here. Okay, this is very, very important. Now, yes, exactly, pons, medulla, cerebellum. Now what do we have? You have the next part, which is pons and also medulla oblongata. Pons and medulla oblongata. Listen to me very carefully. Medulla oblongata is one of the most important thing. Why? Because it is responsible for all your involuntary function. Involuntary function. What do you mean by involuntary function? For example, breathing. For example, your blood pressure. For example, vomiting. Everything which is involuntary is being controlled by medulla oblongata. Your breathing rate, your each and every part which is there is being controlled by this. So make sure you keep it safe. This is about your hindbrain, and this is what you need to know about your brain as well. Cool. Does that work? Okay, guys, is there anything else which you need from me to make you understand? There are hormones. Please know about the hormones as well. Okay, if not, I will be ending up this particular live, because otherwise it will go up too late. Physics ma'am also has to take up, right? If you have any doubts, please ask me those doubts now. I'll take up the doubts, and please make sure you go through anything. Sandhya, you are most welcome, dear. Please go through the entire chapter. Okay, I've just explained you this, but there are hormones, there is planned phototropism, this tropism, that tropism. So please, genotypic ratio, how do we find that? Depending on, ma'am, hormones. Okay. Okay, genotypic ratio, how do we find that? I have explained it to you, dear. You just go back a bit and see for heredity chapter. In heredity chapter, I have made the whole thing and I explained you. If at all you can, please go back. Okay. And someone was asking me about hormones. Yes, I can talk about hormones. So let's talk about hormones. Where is it? Okay. So first thing is dictatorship. So over here, my dear children, hypothalamus is the pardada of the grandfather of the hormonal system out there. Okay. So first thing that we have is It says that, hey pituitary bro, do what I say, is what hypothalamus say. And pituitary, what does it do? Do I have a choice over here? It says no. Why? Because whatever hypothalamus say, it has to be followed by the pituitary gland. Pituitary gland, my dear children, both of them, pituitary and hypothalamus, they are there in our brain. They are there in our brain. Suppose hypothalamus releases releasing hormones. So then pituitary is going to release those hormones which are being asked to release. Suppose it releases inhibiting hormones. Then some hormones are going to be inhibited, they are not going to be released. That is how things are going to work. Okay, so over here, yes, Dadaji hormones, exactly. So over here, generally if at all you talk, pituitary hormones, there are two type of pituitary lobes, okay. So two parts of pituitary, that is, one is anterior lobe and one is posterior lobe. Anterior pituitary, which is there, it is going to release some growth hormones. Growth hormones are the one that promotes and regulates your growth. For example, if at all you're deficient in it, you will have dwarfism. If at all there is more secretion, you will have gigantism. Okay, similarly, thyroid stimulating hormone. Listen, this is not thyroid hormone, this is thyroid stimulating hormone. You also call it as TSH. This TSH is going to act on thyroid such that the thyroid gland is going to release thyroid. Okay, thyroid hormones. So thyroid stimulating hormones, it controls the functioning of the thyroid glands. That is another hormone that is being secreted from the pituitary gland. Next thing is follicle stimulating hormone and luteinizing hormone, FSH and LH. FSH and LH, they are similarly very much involved in the case of males as well as the females. Cool. So you have growth hormones, you have thyroid stimulating hormones, and you have follicle stimulating hormone and also luteinizing hormone released by the anterior pituitary gland. Now you have posterior pituitary gland and you have vasopressin. That is the first hormone, which is also known as antidiuretic hormone. Why do you call it antidiuretic? Because vasopressin does not allow too much amount of water loss. It basically makes the kidney reabsorb water. Whenever we feel that our body does not have enough amount of water, basically vasopressin hormone is being released, and that's when it will be allowing in reabsorption of water. Apart from that, there's a hormone that is known as oxytocin. Oxytocin is super important for the uterine contraction. For example, the baby wants to move out. At this particular point, the uterus has to be contracted again and again, right? Who does that? Basically, it is oxytocin who does that. Okay, so you have hypothalamus, you have pituitary gland, one is posterior pituitary gland, and the other one that you have is anterior pituitary gland. These hormones are super important, especially what you call as what? You have growth hormones. Yeah. The next thing that you have is pineal gland, which is up there. It is basically responsible for your biological clock and everything. Does not been explained much in your NCERT, so it's okay. Next thing is thyroid gland, and thyroid gland is super important. Thyroid gland, what does it release? It releases what? Thyroxine. It can release thyroxine or triiodothyronine. Thyroxine is basically nothing but T4, and triiodothyronine is nothing but T3. So there is T3 and T4 right over here. There is T3 and T4 right over here. And what are they going to do? They are going to help in metabolism regulation. All your metabolic activities, as in if you want to make something, if you want to break something, my dear children, you need thyroid hormones in your body. Yeah, it is also there for growth and development. And one very important part, as it is seen over here, it is made up of triiodothyronine. That means 3 iodine molecules are all involved over here, which is why we say that formation of thyroid hormone will require what? A lot of iodine. It will be requiring what? A lot of iodine. Okay, and if at all we are having iodine deficiency, do you think thyroid hormone will be formed? No. In this condition, whenever there is deficiency of iodine, we say there is insufficient thyroid hormone being produced, and this leads to what? Goiter. There will be swelling up over here. This leads to goiter. Why it is happening? Because we are not having sufficient amount of iodine, and when sufficient amount of iodine is not there, sufficient amount of thyroid hormones are not being produced, and that's when you will be having the disease. Got it? Very, very, very important. And the next thing that we have over here is adrenal hormone. Adrenal gland or adrenal glands are present where, my dear children? Above each of our kidneys, we have a pair of adrenal glands. Above each of them, a pair is there. Okay, one pair, whole pair. It will be producing the major hormone that is there, which you should not be forgetting, is what? Adrenaline and noradrenaline. Adrenaline or noradrenaline, you also call this as epinephrine or norepinephrine. These two hormones are fight or flight hormones. Basically, it gives you energy to fight or it gives you energy to run away. Okay, so this increases your blood pressure. It is the one that makes sure, listen to me very carefully, while you see a bear or tiger in front of you, okay, while you see a tiger in front of you, obviously you need more energy to run. That means you need more energy towards your muscles, not in your stomach, right? So in the stomach, whatever blood vessels are going, they are going to get constricted. They get narrowed down. Okay, vasoconstriction is what you call them. And the blood vessels which goes to your legs and all, they get dilated. They are going to get dilated such that more amount of blood will go to the muscles and it can provide immediate amount of energy as well. So your blood pressure is increased, your breathing rate is going to be increased. Why? Because you need too much amount of oxygen. Oxygen production is needed for ATP production, right? So that for that only all this thing is being done. So that is the role of adrenal glands. Now the last one which we have is pancreas. Pancreas is super important, it releases two things. One is going to be insulin and the other one is going to be glucagon. Okay, glucagon. Insulin does what? Whatever, how much ever glucose is there in our blood. Okay, it can cause problems. If at all the glucose level is too high, it can lead to what? Diabetes. Which is why we need someone to trap all those glucose and convert into something else which is known as glycogen. Which is known as what? Glycogen. Who does that? It is the insulin who does that. It is the insulin who does that. Fine. What about the next thing that is there? Glucagon, which is there, it will be converting the glycogen up over here and it is breaking down the glycogen to what? Glucose. It will be breaking down the glycogen to what? Glucose. That is the function of glucagon. Okay, that will be the function of glucagon. Whatever glycogen is there, it will break down to glucose. Suppose we are in fasting mode, okay, we do not have much energy at the, for example, as of now when I'm talking to you, suppose I do not have much energy, what is going to happen? Basically whatever glycogen is there in my body which is stored in the liver, it is going to be broken down back into the glucose. Works? This is the general thing which is there. Master gland is the one that is going to control a lot of other glands function. So pituitary gland is known as the master gland. Vishal. Okay? Perfect. So please know about that. And okay. Apart from that, you have ovary and testosterone basically. So ovary and testis that releases hormones. Okay? Shama, I'm so sorry dear, I did not know Telugu. Yes. Okay guys, so I think I will end up the live right over here. Do you have any other doubts which is there? Or shall I end up? And now physics ma'am will be taking up the class. Okay, physics ma'am will be taking up the class. I think all of your doubts are being cleared. If you have any doubts, you can put it down in the comment section. Ma'am, 1 minute. Yes dear, tell me. Ma'am, your efforts take me center, ma'am. I hope you do that. Please, ma'am, you explain in English only, right? Exactly, dear. So, yes, guys, all the best for your examination, which is tomorrow. If at all you have any doubts, do not forget to put it down. And also, make sure you download the PDF if at all you feel it's necessary. Do not forget to hit the subscribe button as well. I'll give you a break for the another 6 minutes and then ma'am will be taking up the next class. Okay, physics ma'am. So, I'm just writing it over here. I'll just ask her also. Just give me a second, okay? Okay, children, physics class is going to be there at 6 p.m., 6:10 p.m. So please be back by that time. Wishing you all the best. Bye, JJ ma'am. Oh, that's so sweet. You know my name. Okay. Bye-bye. Wishing you all the best. Bye-bye. Take care.
हाँ हो गया okay. Hello everyone. Hello, can you all hear me loud and clear? Just a second. Can you all hear me loud and clear? Yes, ma'am. Great. And can you guys see me now? Okay, how are you all doing? How is your preparation going? I see from the morning you all are being very consistent. I do remember you. Jack, how are you? Hi Akshay, hi everyone. How are you all doing? How is your preparation going? Tomorrow is your science exam. How is the Josh? Physics revision, one last time. I know you guys are a little bit fed up about the exams at this point, but this is one last time you have to study science. Just one last time. Hi Rudra, how are you? Hi Shikha. Hello everyone. Hi Shanku. Great. Very good. That shot is saying very good, ma'am. Great. So, can we start? Okay, I have one question for you guys before we start the live. What are we expecting in this live? Should you do all the important questions? Should we do all the important questions? PYQ is most repeated. Or you want to study the core physics, like all the concepts, you want to revise all the concepts again? What do you want to do? Or I'll go with by my mind if you don't reply. Let me know fast. If you want a proper revision of all the chapters, lesson wise, Nisha is saying all the concepts. Okay. Important question type. Okay, great. Okay, done. Then we'll start with chapter wise, and in between we'll see some questions as well. Okay, yes, we'll do. Let me go to the chapter section then. Chapter section. We'll see all the, and we'll see it in a quick manner, okay, because this is the last time and we don't want to go into so much depth, right? Okay, let's start with the very first, that is our chapter light. Why do we always start with the chapter light, ma'am? Because chapter light has the highest weightage, right? Chapter light has the highest weightage among your physics syllabus. Okay, so let's start with light. What is light? It's just a plain form of energy which enables us to see this beautiful world around us, and it has dual nature. It acts as a particle as well as it acts as a wave. Very basic. Let's come. Particle looks something like this. Wave looks something like this. Done. Next is, why do we see, what is actually the, okay, we went to laws of reflection of light. Okay, why do we see things? Yes, we'll do electricity, we'll do all the chapters, don't worry. I know a lot of you guys are a little bit skeptical about the chapter electricity, but in the time of seeing the electricity, don't forget about all other chapters as well. Okay, so we'll do everything, don't worry, we'll do everything. Done? Okay. Then why do we see light? Because of reflection. What is reflection? Bending of light when it strikes a surface. Light came, it hit me and it went straight into your eyes. So that bending of light is called reflection. Now what are the laws of reflection? Very important, they can directly ask you. First law is angle of incidence is always equal to angle of reflection. Very simple, very basic. The incident ray, the normal to the mirror, the incident ray, the normal to the mirror, and the reflected ray all lies in the same plane. You don't see that the reflection ray is coming out of the board, right? So all lies in the same plane. Very good, that shot. Great. Okay. Next we have Plane mirrors. Plane mirrors is a topic that we really oversee, but what are two things that you need to remember about plane mirrors are something like this. Plane mirrors are, first of all, they form the image of same size as that of object, same size image, right? Second, the image is laterally inverted. The image is laterally inverted. That means my left hand will look like my right hand in the mirror. Done? Everyone, anything else that I left? Anything else that I left? I left that the plane mirror always forms a virtual image. It always forms a virtual image, and the distance of image from mirror is equal to the distance of object, right? Done? Great. Next we have spherical mirrors. Now spherical mirrors are a little bit different than plane mirrors. Their size is not same, the image is not always virtual, the image is not always diminished or enlarged or of the same size. Yes, Nisha, what do you want me to explain? Plane mirror. This is the basic explanation of plane mirror, Nisha. Plane mirror is basically just a screen that reflects your light, and it forms the image of same size. It is laterally inverted. It is always virtual image, and the distance of image from the plane mirror is equal to the distance of object, right? Hi Khushi, how are you? Done. Now moving on to spherical mirrors. Again, all these properties will change in case of spherical mirrors. Now we have two kinds of spherical mirrors. First is concave mirror. Which looks something like this, where this part is the reflected part. The second is convex mirror. Which looks something like this, and this bulged part is my reflecting part. Done? Okay, let's move on to the next. We have all the cases of concave mirror. We'll do it quickly because we have done it, right? Lots of the time we have done it, so we'll do it quickly. Okay, image formation by concave mirror. So we have 6 cases. Let's see, we have 6 cases in the case of concave mirror, and let's just quickly see the trick that we all know, but let's just see it. This is my focus and this is my center of curvature. This is the reflecting part. So 1, 2, 3, 4, 5 and 6. So 1, this means 1, 2, 3, 4, 5. That means object at infinity, image at focus, object beyond C, image between C and F, object at C, image at C, object between C and F, image beyond C, object at focus, image at infinity, object between focus and pole, that will be, the image will be behind the mirror, BTM. Okay, done. I know a little bit of Tamil, kunjam Tamil, I know. Okay, done everybody? Okay, now these 6 cases that we just studied about. The first case we have the object is at infinity, right? And the image will be formed at focus. The image is formed at focus, right? Then the second case, the object is beyond C. The object is beyond, it's beyond C, right? And the image is between C and F. Between C and F is our image, right? Yes, that's short. Ask your doubts. Okay, done. Now in this first case, all the cases of concave mirror, one thing remains same, that the image will always be, in case of concave mirror, for 1 to 5 cases. Okay, let's just study first. Okay, in this we have real and inverted image. In the second case, we also have real and inverted image. In the third case, when the image is at C, right? Jai Shri Krishna Solo, how are you? We are going chapter wise. Okay, we are just starting with light chapter. Done. So the object is at C, the image is again at C. Done. And the image is of same size and the image is real and inverted. Here the image is diminished. We can clearly see the image is diminished. Done. Okay. Okay, how to find real and inverted? How to find real and inverted? Yes, Nisha. Okay, how to find real and inverted? See, what we do is, this is not a question someone will ask you, object at F and image formed at infinity or not formed. You can write anything, but it is, according to the new NCERT dead short, it is not formed. Not at infinity, it's basically not formed. Okay? Okay, talking about Nisha's answer, see, when look at this case or any case you look at, the real and inverted ones. So what is happening? A ray is going, it is getting reflected back, and then another ray is going, it is getting reflected back. So the actual ray is meeting, right? See, let me just finish all this and I'll tell you the difference between real and inverted and virtual and direct. Okay? Yes, we will write new NCERT one. You can write the value as not formed. The image is not formed. Okay. Third case clear. Fourth case we have the image is, the object is between C and F. That means the image will be beyond, it will be beyond C, right? Everyone tell me where this image, what are the properties of this image? Until then I explain the last part. Let me know the important properties of the sixth case formed by concave mirrors. Hi Divyanshu. Okay, yes, fast, okay, fast. Okay, now the object is at focus, right? So the image will be not formed. According to new NCERT, you have to write the image will not be formed, and then it gives out the thing that the image is real and inverted or virtual and direct. Yes, Nisha, it is virtual and direct in the sixth case. Shaving mirror. What is shaving mirror? Okay, done. Sixth case. Now, Nisha, look carefully. The object, okay, the little bit mistake. The focus is actually here. This is not the focus. The object is between focus and pole, right? So one ray goes and it reflects back, and another ray goes and reflects back, passing exactly from center of curvature. Now listen carefully. These rays are not meeting. What do you mean? The actual rays are not meeting, right? The actual rays are not meeting. We are extending the rays from where they look like they are coming from. So these are virtual. Virtual means not real. Okay? Virtual means not real. So here real rays are not meeting, so the image will be actually virtual and erect. Now look at this carefully. In all other cases, real rays are meeting, right? Real ray came and this real ray and this image is formed. So a real image is formed. Done, Nisha? Done? You had a doubt. Is it clear now? Okay? Good doubt. Great. Good question. Yes, Divyanshu. Manifestation is very important. Tomorrow's paper will be good. Okay, done. This trick we studied, and we studied that in concave mirror, first 5 cases always form real and inverted images, right? And the last sixth case, it always forms virtual and erect. It always forms virtual and erect image, but it is enlarged. It is enlarged. After doing the convex mirror, I have a question for you guys. Okay, so be prepared. Dead short, dentist mirror and shaving mirror. Yes. Okay, dentists do use concave mirror. Which mirror dentists use? They use concave mirror. Which mirrors are used in parlors or your saloons? They use concave mirrors as well. Okay? Okay, done. Then another, moving on to moving on to convex mirror. Now convex mirror just has two parts. Which kind of images are formed by convex mirror? Let me know fast. Which kind of image is being formed by a convex mirror? Until then I explain the two parts. Now in here the object is at any point between focus, between infinity and pole of the mirror. This is pole and this is somewhere infinity. So it is anywhere between that. So what will happen? One ray go, it reflects back. Since it's a diverging mirror, it won't come like this. It will go on the other side. It will get reflected something like this. And when we extend back, we see this is coming from focus. And another ray goes, it reflects back in the same direction. So we saw that it is passing from center of curvature. So where these two rays meet, this is a image. And the image will always be formed between pole and focus. Between pole and focus. Right? Okay, what kind of image is formed in this case? What kind of image is formed in this case, everyone? Then the object is at infinity. The object is at infinity. Again, rays will be parallel, right? Rays will be parallel. They come back like this, and they are diverging like this. They are diverging like this. So when we extend back, we see they are passing from focus. Now, what is the, what do you say? Highly diminished. Divyanshu is saying highly diminished. Okay. What is the nature of image? I asked people. What is the nature of image? The nature of image is actually, in this case, the image is highly diminished. That is right. The image is highly diminished. And you can say the image is virtual and erect. Virtual and erect. Then in this case, again, the image is just point sized. The image is point sized and it is virtual and erect. Virtual and erect. Then, great. Yes, Solo is saying, why are you talking about yourself as if you are a third person? Used in a rear view mirror. Yes, great. Yes, Solo, I am looking at Solo's answers. Don't worry. Okay, so in case of convex mirror, we just have two cases. In first case, the image is virtual and erect. Second case, the image is virtual and erect, and the image will be diminished. The image will be diminished. Now, I have a very important question for you. The question says, very important question for you everyone, very important question for you. The question says that a virtual image is formed, a virtual image is being formed, and its size is large. Its size is large. Now, what kind of mirror is this? What kind of mirror will form a virtual and enlarged image? Yes, Nisha. I accidentally skipped your doubt in the chat. Can you write it again? Concave mirror, Divyanshu is saying. Nisha is saying concave mirror. Okay, anyone else with the answer as convex? Sorry. The answer as convex. Everyone is saying concave? Great. Everyone is saying concave mirror. Very, very good. This is exactly concave. Solo is also saying concave mirror. I saw your answer, Solo. Good. Dead shot. Great. So, this mirror is concave mirror. So, virtual image is formed by both concave and convex mirror, but real image is only formed by concave mirror. And convex mirror forms virtual image as well, but it is formed diminished. Yes, convex mirror never forms large image. Great. Anil also said concave. Is in exam, is concave or convex are important? is what you are meant. What is import? Okay, let's move on. See, sign conventions very important for your numericals. Left hand side, this is concave mirror, right? And this is convex mirror. The focal length of convex mirror is on, the focus is on this side, that means positive side. The focal length, the focus is on this side, that means negative, right? Hi Mohinder, welcome back. I am great, Mohinder. How are you? Done. So left hand side of the pole, this is left hand side, all the distances will be negative. Left hand side, all the distances will be negative. Same. Right hand side positive, right hand side positive. If object distance is always negative. Object distance is always negative irrespective of the mirror. Great. Then we know you great. Okay. Okay. Done. Then V, image distance for real. See, in case of mirrors and in case of lenses, real and inverted and virtual and erect will have different signs. In mirrors, real and inverted will be negative. Why? Because the image is being formed in this side, right? So real and inverted will be negative. In convex, real and inverted does not form. So this is simply I wrote it just for sign convention. Okay. Now virtual and erect. We know the image is formed on this side of concave mirror when virtual and erect, sixth case, and in here the image also forms on this side, virtual and erect, right? So for virtual and erect, the image distance is positive. Focal length of concave mirror is always negative. Focal length of concave mirror is always negative. Sorry, radius of curvature is negative. But for convex mirror, the virtual and erect image will always be formed, so this is positive, but focal length for convex mirror will be positive, hence radius of curvature will also be positive. Ma'am, distance can't be negative. Achha ji, so you can say that look, when you study about distance it can't be negative, but when you study distance on a scale, on a graph, we take x as negative, right? So it is that. Yes, Nisha. Okay, I'll give you 2 minutes to go about this. Go through all of this. Just remember 2 or 3 things. Let me write down it again. You go through this one more time and I'll write it down in a proper manner again. Okay? Okay, let me just write it down. See, for concave mirror, this is my concave mirror, right? What do you know? 3 things that you have to know? Focal length is always negative. From first to 5 cases, the image formed is real and inverted. That means V, image distance is negative. In the 6th case, the image formed is virtual and erect, so V will be positive. Done. Then in case of convex mirror, this is my convex mirror, focal length is always positive, and V, since it always forms real, virtual and erect images, that means V is always positive, and U in all cases is negative. Object distance in all cases is negative. This is what you have to remember. Done? This is what you have to remember. Everyone? Okay. Great. Then move on to mirror formula and magnification. Now mirror formula, we all know. What is the mirror formula, everyone? Okay, well, tell me the magnification for a mirror. Write it down very, very carefully. For mirror. Mirror formula is 1 by F equals to 1 by V minus 1 by U. Then what is the magnification for mirrors? What is the magnification formula for mirrors? So for mirrors, my friend, magnification is minus V by U, or height of image divided by height of object. Done. Minus V by U. Great, Nisha. Okay, then next we have for concave mirror. See, now coming on to magnification. If magnification is negative, see, these are fine. Magnification greater than 1, obviously it's magnified, less than 1 diminished. See, this is very carefully. See very carefully. Magnification is positive. That means the image is virtual and erect. Magnification negative, that means the image is real and inverted. So for concave mirror, we have all kinds of magnification. We have negative magnification for 1 to 5 cases, right? Because the image formed is real and inverted. Right? And in the 6th case, magnification is positive. In the 6th case, magnification is positive because the image formed is virtual and erect. Okay, imposter. Done? Done, everyone? Okay. Now, similarly for convex mirror, we see that we always form virtual and erect images. Now, for virtual and erect images, magnification is always positive. So, for convex mirror, magnification will always be positive. And one more thing, for convex mirror, yes, I know Shrey from Dubai. I have actually one more student from Dubai. I guess he was from Dubai, so I know. How did your exams go? Okay, so now in convex mirror, we never form a large image. Right? It's always diminished. So magnification will be always less than 1 as well. Done? Done. So if you see magnification more than 1, it will never be of convex mirror. It will never be of convex mirror. Done? Okay, let's move on to the next. For you guys, we have created one PDF which has almost 100 questions of bio, 70-80 questions of physics, and lots of questions of chemistry as well. There is a link down in the description. Go click on that link and you'll get those questions. And very important part, those questions are solved. All the numericals are solved by me. Okay, so you can go get those questions. Those are with the answers. Okay, complete calculation, complete answers. So go check that out. There is a link. You can go check that out. Okay. Next, refraction of light. Reflection is finished. We have refraction of light. Now, bending of light when it passes from one medium to another of different density. Bending of light when it passes from one medium to another having different densities is called refraction. Done. Now, what are the refractions? Just like reflection, we have laws of refraction as well. Done. What are the laws of refraction? Ma'am, laws of refraction says, first is same. The incident ray, the refracted ray in this case, the refracted ray and the normal on the normal to the interface. Interface is what? This is air, this is water. So this boundary that is separating these two medias is called an interface. The interface of two transparent media at the point of incidence all lie in the same plane. Okay? Done? Sorry. Okay, now next part, this is done. Next law is very important. Everyone listen to me very carefully. What is this? The ratio of sine of angle I. Okay, this is refraction. A light goes, this we draw normal. When it goes from rarer to denser, it bends towards the normal. When it goes from denser to rarer, it bends away from the normal. Rarer to denser, it bends towards the normal. Bends towards the normal, and denser to rarer, it bends away from the normal. Away from normal. Right? Done. Now, the second law says the angle of incidence. This is angle of incidence, this is angle of refraction. So the ratio of sine of angle of incidence to the angle of refraction is always constant for the light of a given color and for the given pair of media. This law is also called Snell's law. Oh, great imposter. One day before science exam. That is questionable. Okay, done? Okay, great. Let's move on to the next. We have a refractive index, a very important topic that a lot of you guys do fear from. So let us see what is refractive index. So refractive index is actually the extent. See, we know light bends, but how much this light bends? How much this light bends is given by refractive index. Right? So the extent of change in direction of the ray of light that takes place in a given pair of media may be expressed in the terms of refractive index. Done? Now, a very important formula of refractive index we have, everyone, N21. That means refractive index of second medium with respect to first medium. This will be equal to velocity in first medium divided by velocity in second medium. This will be equal to wavelength in first medium divided by wavelength in second medium. This will be equal to sine of angle I divided by sine of angle R. Big formula, but very important one. Done? Done, everyone? This is a very important formula. Now coming back to refractive index, this is the same. Okay, N21 be the refractive index of medium 2 with respect to medium 1. V1 be the speed of light in medium 1. V2 is the speed of light in medium 2. Okay, Mahinder. All the best. Done? Okay, let's move on to the next. We have refraction from a glass slab. Again, very important topic. Why? Because in this, refraction is happening twice. Alright, it's fine, Mohinder, go. You think you need to study chemistry? Go study chemistry. Right? So in glass slab, refraction is happening twice. How twice? One at this media, this point, and second at this point. How? In this, the light is going from air into the water. So technically, if there was no, not into the water, into the glass. So technically, if there was no glass here, it will go straight. But there is some glass here, so it is bending towards the normal. So now this is the refracted ray. Now it is going from glass into the air. That means denser to rarer medium. It will bend away from the normal. Right? Hi, Shah. Welcome. If you are a new student, this session is for AP or TS. What is AP or TS? Do I not know all these stuff? What is AP or TS? Shah. Right. Done. So in here, instead of going straight like this, it bends away from the normal. Now this is angle of incidence, we all know that. This is angle of refraction with the normal, we all know that. And this, my friend, is the angle of emergence. 2 things that you need to keep be very clear in glass lab is angle of incidence will be equal to angle of emergence, and incident ray will be parallel to emergent ray. And this distance, the perpendicular distance between incident ray, between the extended incident ray and the emergent ray, it will be called lateral displacement. It will be called lateral displacement. Done? Okay. Next we have image formation by, this is not concave mirror, this is convex lens. Sorry, my bad. This is convex lens. Let me clear it. This is convex lens. By convex lens. Done? Now, again we have 6 cases, Andhra Pradesh and Telangana. This is for basically everything, every board, but the concepts are there in every board, but this particular is for CBSE, okay? Okay, I sometimes get distracted by your conversation. You guys do have some really great gossips. Yeah? Okay. Next time when I come to the live I'll come one time live after the exam and you do all the gossips and I'll also take part in the gossips. Okay? Then? Okay. Now, the first case is object is at infinity, image is at focus. But in this case, very carefully listen to me. Okay? Okay, Shah. So, in mirrors, the rays usually reflects back. But in this case, the rays refracts. So, they pass through the lens, meet on the other side, which is called F2, focus number 2. Now, on the left hand side, this is F1, 2F1, this is F2, 2F2. Done? The cases are same. Now the object is beyond C and the image will be made between F2 and 2F2. The image will be diminished. The image will be diminished and it will be real and inverted because real rays are meeting. Right? In first case of convex mirror, image is at F2. Convex mirror. Yes, Prakash, you can say that. Okay. Tina, voice is not okay. Everyone else, is the voice is not audible? The nature and size of the image is really inverted and extremely diminished. Very good, Prakash. Yes, very good. We are live. Okay. Let's go with the third case. Now at third case, the object is at F1. So the image will be again at F1, similar to concave mirror where the image was at center of curvature. The image is real and inverted and it is of same size. Right? One ray goes parallel, passes from the focus, another ray passes from the optical center, passes straight. Right? Meet us at a point that is exactly at F2. Done? Okay, Rudra, voice is okay. Okay. Done. Okay. Okay, then on to the fourth case. Now the object is between 2F1 and F1. So one ray goes parallel, passes from the focus, another ray goes direct to the optical center, meet at a point that is beyond 2F2. Beyond 2F2. Again, the image is real and inverted and it is enlarged in this case. The image is enlarged in this case. Now, Aizen, this is a chemistry question. I'm so sorry, I won't be able to solve this. ऑब्जेक्ट मूविंग दिखाई देते हैं तो इस केस को क्या कहते हैं? स्किज़ोफ्रेनिया? ओके. हाय देसी भाई, हाउ आर यू देसी भाई? ओके. Exactly, Rudra, that is what I was saying. Questions type, ma'am, please. Dude, I asked you in the starting if you want questions or if you want lesson-wise explanation. You all said you want lesson-wise explanation. Can you please explain once again, ma'am? Which Puneet, what do you want me to explain? Exactly, imposter. Do that and let me know if you are successful or not. Okay? Don't do that. Okay. Okay, let's move on. See, if you are asking me to explain this case again, in this case, the object is between, where is the object? Yes, the object is between F2F1, 2F1 and F1. This is 2F1 and this is F1. So it is a similar case of concave mirror, right? Where the object was between center of curvature and focus. It is the same case. So one ray goes parallel, passes through F2, another ray goes into the optical center, and the point where it meets, it is beyond 2F2. So in this case, the image is real and inverted and it is enlarged. Right? Done? Okay. Okay, Ayush. Physics wali ma'am aa gayi. Yes. Okay. Now, in the fifth case, the object is at F1. The object is at F1. Hey, what am I doing? The object is at F1. So one ray goes parallel, passes through focus, another ray goes into the optical center. They are parallel to each other. So image will be not formed. Image will be not formed. Right? In the sixth case, my dear friends, this is optical center, this is F1. So the object is between F1 and optical center. So the image, one ray goes parallel, passes through focus, another ray goes through optical center, but they are drifting away from each other. So we extend them backwards and we see a virtual image that is formed beyond or to F1, beyond to F1. It is a virtual and erect image, and it is enlarged image as well. Okay, everyone, done? Done. We are done with all the cases of convex lens. Anju is saying you got time out. Okay. Nahi Ayush, no Ashu. Ashu was not here. So sorry. Okay. Next, yes. Hanji. Okay. Next we have concave. Again concave mirror. That's my bad. This is actually concave lens. Okay. This is now concave lens. Okay, now again this has only two cases. The first case, when the object is at infinity, so parallel rays come, and in this case they diverge, they do not converge here, right? They diverge away. So we extend them back and we see that they are actually meeting at the point, they appear to be meeting at F1. So image is at F1, it is virtual and erect in this case, and in this case it is point sized. Another, the object is anywhere between infinity and optical center. So this is my object. A ray goes parallel, passes, and it diverges. Extend them back, passes through F1. Another ray goes through optical center. So these two rays, where they meet, this is my image. It is always formed between F1 and optical center, virtual and erect, and it is diminished. Done. All of you. Any doubt? Okay, great. Now, next what we have? Next we have sign conventions of concave and convex lens. Done? What? Okay. We have sign conventions. See, everything is same. This is concave lens and this is convex lens, right? Everything is same. Left hand side negative, right hand side positive, U is negative. But in this case, concave lens we know always forms virtual and erect images. And see, virtual and erect images are being formed on the same side of lens, on the left side of the lens. So virtual and erect image will have a sign negative. We will have a negative sign. Focal length of concave. Anywhere you see concave, either it is lens or mirror, focal length is always negative. Height above positive, below negative. Okay? Done. Class will be till night, maybe 9. Okay? Okay, so for convex lens, we know for convex lens both real and inverted and virtual and erect images are formed. So for real and inverted, they were formed on this side, right? On this side, that is right hand side. So for real and inverted, in case of lenses, we have positive V. For virtual and erect, we have negative V because they were formed on same side of the lens. But real and inverted were formed on the right side of the lens. So real and inverted will be positive, virtual and erect will be negative. And for convex mirror, for convex lens, the focal length is always positive. Done? Okay, let's move on to the next. We have lens formula. What is the magnification formula for lenses now? Everyone, let me know in the chat. What is the lens formula? What is the magnification formula for the lenses? Mirror formula, lens formula is 1 by f equals to 1 by v minus 1 by u. Make sure when you are writing the examination, you write that in the just back the video a few seconds. Okay. So when you are writing answers, when you are writing numericals, make sure that while writing you write big that this is a lens, so that you don't forget that you have to use the lens formula. Okay, now moving on to magnification of lenses, it is magnification for lenses is simply positive V by U. Right? Now concave lens always forms virtual and erect image. It always forms virtual, and we know magnification is a negative for real and inverted images. It is positive for virtual and erect images. Concave lens always forms virtual and erect images. That means magnification is positive, always positive, and it is less than 1 since it always forms diminished images. Done. Then convex lens magnification is negative as well as positive for 6th case. For 6th case, the magnification will be positive and it will be greater than 1, less than 1 and equal to 1 as well. Done? Done everyone, done. Any doubt? Magnification is positive when image formed is virtual and erect, and magnification is negative when image formed is real. Very good, Seema. Okay. Let's move on to the next chapter, that is my electricity. Who of you all were waiting for electricity chapter? Oh, Ayush, that is so bad. Okay, done. Everyone, any doubt in the chapter light? In the chapter light, if you have any doubt, answer, ask away right now, because after that we will be moving to the chapter light. We will be moving to the chapter electricity. Done? Okay, let's move on to the next chapter. Then next chapter, my friend, is okay, question for light. Questions for light. Sarji, we did questions for light yesterday, right? Let me see if I have some good questions for light. Okay, I have a question for refractive index for light. We will look at it very quickly, right? There are not much questions on light because we already did it yesterday. Okay, what do you mean by relative refractive index? Relative refractive index is, see, if my ray is going from water to the glass, what if my ray is going from water into the glass, then the refractive index of glass with respect to water will be called relative refractive index of glass with respect to water. Okay? Okay, so a refractive index of medium Y with respect to X is given. Refractive index of medium Y with respect to X is given as 3.2, and the refractive index of medium Y with respect to Z is given as 3.4. We have to find the refractive index. We have to find the refractive index of medium Z with respect to X. Now, how do you solve these kind of questions? How do you solve these kind of questions? These kind of questions you just have to either multiply these or divide this. We'll see what to do, because this is what? Ny divided by Nx, and this is what? Ny divided by Nz. I need Nz by Nx. So if I multiply these, that will be N square Y divided by Nx into Nz. That won't make any sense. So we will divide this. We will divide this and we'll get Ny divided by Nx divided by Nz. Ny divided by Nz. Right? And this will give me what? This Nz goes up and Ny goes here. Nz into Ny divided by Nx into Ny. So this cancels out. We get Nz divided by Nx, which is Nzx. Right? So can I solve? If I solved this, I'll get the answer as Nzx. Right? That is 3.2 divided by 3.4. If you solve this, you will get answer of Nzx. Done. Next, we have speed of light in medium X is given. Calculate the speed of light in medium Y. This is simply Nyx is given, right? 3.2. And we studied that Nyx will be Ny by Nx. That will be Vx by Vy. Now, Vx is given 3 into 10 raised to power 8. And Vy we have to find. Ny by Nx is 3.2. This is 3.2. Right? So this will be 3.2 divided by 3. This will be Vy comes here. Vy comes here. So that will be 3 into 10 raised to power 8 divided by 3.2. If you solve this, you will get a value of velocity in the medium Y. Done? Done. Next we have some other question of... Okay, we did all the questions of light, everyone, yesterday. So if you want, you can go watch that video. Okay? Okay, let's move on to the next chapter, that is electricity. If you have any doubt of the chapter light, ask right now. Okay, done. Let's move on to the chapter light, to the chapter electricity. Now, to the chapter electricity, the very first topic, refraction. Well, I just did a refraction question. Come on, Ayush. Okay, imposter, what happened? Okay, let's move on to the next question. We have next chapter. We have electricity. Okay. Okay, Ayush, let's just go through all the chapters once. Then we'll come back to the refraction questions. Okay, done. Okay, so first is charge. It's just a property of matter. We have two charges, that is positive and negative. Like charges repel each other, unlike charges, repel each other, unlike charges attract each other, right? Its SI unit is coulomb. What is the SI unit of current? What is the SI unit of current? Let me know fast. Okay, so current is, on the other hand, rate of flow of positive charges. Rate of flow of positive charges. Great, Nisha, very good. So rate of flow of positive charges is called current. Direction of current is opposite to the direction of electrons and it is measured by ammeter. Remember, it is measured by ammeter, and ammeter is always connected in series with the circuit. Ammeter is always connected in series. Okay, so SI unit is ampere, and there is a very important formula, Q equals to IT. Q is charge, I is current, T is time. Done. Now next we have a little bit of question, that is an electric current of 2 ampere. We have an electric current of 2 ampere that flows for 5 minutes. Flows for 5 minutes. What is the charge? So you just have to convert this time into seconds. Convert it into seconds, which is equal to 5 into 60 seconds. That will be 300 seconds. Now using this formula, we'll have Q equals to I into T. I is 2, T is 300. That is 600 coulomb. Done. Okay, imposter. Okay, let's move on to the next. We have a very important topic, that is potential difference. Potential difference is basically the amount of work done to bring a charge, to bring a test charge from one place, one point to another, right? One point to another. Great. Now it is measured by voltmeter. Its SI unit is volt, and again a very important formula, V equals to work done divided by charge. V equals to work done divided by charge. Done. Now this current, a very important thing is, this is high potential. The positive part is called high potential, the negative is called low potential. We know current goes from positive potential to negative potential. Electrons go from negative potential to positive potential, right? Next we have Ohm's law, a very important, very good law, easy law. So it says that potential difference across a conductor, between the two ends of a conductor, is directly proportional to the current flowing through that conductor. Yes, resistance. Okay. No, Aditya. What? Okay, now the V is directly proportional to I, and if you take out the proportionality constant, we get a constant, that is resistance. That is resistance. Now this graph, my friend, is very important. You will, at least you should get one question from this graph. This is very important. Okay. Yes, great, Seema. Now let us do one question. Okay, not one question right now. We'll study a bit more. Now, resistance and resistivity. Resistance is a property of conductor that opposes the flow of charges through it. That opposes the flow of charges through it. Resistivity, on the other hand, it is the property of a material. It varies from one material to another. It is the property of conductor that determines how strongly that charge is getting opposed, right? Now, SI unit of resistance is ohm, SI unit of resistivity is ohm meter. The derivation of SI units of resistivity is important. It can come in your examinations. Okay. Now, formula is resistance equals to rho L by A, and if you rearrange this, resistivity will be R A by L. Resistance of a conductor is given by V by T, V by I, Seema it is. Yes, rho equals to R A by L. Very good, very good. Irfan, great. Done? Okay, now where length is, L is length and A is area of cross section, not just area. So good conductors have low resistivity, and bad conductors, that is insulators, have high resistivity. Good conductors like copper, aluminium, insulators are rubber and plastic. Okay, next we have the factors on which resistance of the conductor depends. So resistance is rho L divided by A, right? Now rho is resistivity, so it depends on nature of material. L is length, right? A is area of cross section. Now resistance also depends on temperature, but how this depends on temperature. See, for conductors or for metals, resistance is directly proportional to temperature. As the temperature increases, free electrons increases, resistance also increases. For semiconductors and insulators, resistance is inversely proportional to temperature. As the temperature increases, resistance decreases. Done? Okay, let's move on to the next. We have a question. Everyone. A wire of given material having length L, okay, length of a wire is L and area of cross section is A. Resistance is 4 ohm. Okay, find the resistance of another wire of same material, having the length as, let's say this is L1, this is A1, R1. L2 is L by 2, area of cross section is 2A. Now we have to find R2. I can easily do that, right? This is a very easy question, So R1 is rho L by A. L2, A2. Now this is rho 2, but they have written same material. So rho 1 will be equal to rho 2 will be equal to rho, right? So this is rho L1 by A1. Oh, this is rho 1 L1 A1. Right? So this is rho, L1 is simply L and A is simply A. Now resistance is actually 4. So rho L by A comes out to be 4. Rho L by A is equal to 4. Done? Now let's solve the second part. R2 is rho 2 L2 by A2. Right? So rho 2 is simply rho, L2 is L by 2, A2 is 2A. So this 2 goes into the denominator. This becomes rho L by 4A. 2 into 2 is 4. So this becomes what? Rho L by A 1 by 4. Now we just saw rho L by A is 4. Rho L by A is 4. Right? So can I put that here? Rho L by A is 4. And R2 comes out to be rho L by A into 1 by 4. Now rho L by A will be put in here, right? So R2 becomes 1 by 4, rho L by A is simply 4, so this cancels out. R2 becomes 1 ohm. Clear everyone? Any doubt? Any doubt, anyone? Parallel current, total current. 1 is the sum through current through each resistor. What are you trying to answer, Irfan? That's short. 1. Yes, great. Okay. Let's move on to the next part. We have combination of resistors. Very. How do you like do you like this topic or do you hate this topic? Combination of resistors. 1. Yes, dead short. I saw your answer. Do you like this topic or do you hate this topic? Combination of resistors. Okay, so we have 2 types of combination of resistors. Combination first is series, when between 2 points a lot of resistors are connected. No, when that is parallel. Between 2 points only one resistance is connected. between 2 points, one resistance is connected, one resistance is connected. That is series. In series, current remains the same, but voltage is different. Voltage is different. Correct? Like, that short likes this topic. Okay, and in second, in between these 2 points, lots of resistors are connected. Lots of resistors are connected. So that is my parallel combination. I is different in case of parallel combination. V on the other hand is the same in case of parallel combination. Done? Okay, then moving on, we have advantages of series combination, advantages of parallel combination over series, or disadvantages of series combination. That says, yes, we'll do heating effect of electric current in just 2 minutes. Okay. Okay, if one device in series fails, all the whole circuit fails, right? So it is of no use. If one device fails, everyone fails, right? Ma'am, please do same type of questions. What type of questions, Ayush? We'll do questions, don't worry. But before that, you have to let me complete the whole syllabus of physics fully. Okay? Okay, so these are Dihybrid lights. Different device needs different amount of current, but we just saw that in series the current is same, but different devices need different amount of current. That only happens in parallel combination. So those are preferred, fridge or adapter. The previous one, which one, Ayush? Achha, this one we will do, don't worry. Okay, let's move on. Let's complete this chapter first. Okay, electric power and electric energy. Power is just the rate of doing work. Power is rate of doing work. Okay, that means work done per unit time, and that goes to power equals to V into I, a very important formula. Okay, Ayush, okay, I'll do those questions, don't worry. Okay, done. Power is V equals to I. It also have a different formula, I square into R and V square divided by R. Done. A rate of consumption of energy. Its SI unit is what? Its SI unit is watt, and 1 watt is equal to 1 volt into 1 ampere. Done. Now electrical energy on the other hand is simply power into time. We studied power. Now electrical energy is power into time. Done. Power into time. So power into time, that means V into I into T. I square R into T. V square into R divided by T. Oh, sorry. V square into T divided by R. Done. Now listen to me very carefully. This part is very important. They will ask you to show the relationship between commercial unit of electricity and SI unit of electricity. Okay, okay, so you have to see the SI unit is watt hour. It is kilowatt hour. No, it is kilowatt hour. So 1 kilowatt hour equals to 1000 watt into 3600 seconds, because 1 hour equals to 3600 seconds. That means 3.6 10 raised to power 6. This is 3.6 into 10 raised to power 6 joules. That is 1 kilowatt hour. Done. And 1 kilowatt hour is often taken as 1 unit. Done, everyone? Okay, next we have a question. An electric refrigerator rated 400 watt. Power of a refrigerator is given as 400 watt and operates 8 hours per day. It operates 8 hours in a single day. Okay, and they asked us what is the cost of the energy to operate for 30 days. For 30 days we have to find the energy. We have to find the energy for 30 days. If 30 days at 3 per kilowatt hour. So cost is also given. Cost is given as 3 rupees per kilowatt hour. Okay, so let's calculate this. Let us calculate this. Who can do faster, me or you? Let us calculate the cost of operating the refrigerator for 30 days. Everyone, tell me the answers now. You have to be very fast in your exams. Okay. So energy, my friend, is nothing but power into time. Right? Now power is 400 watt. It is 400 watt into time. Time is 8 hours per day for 30 days. So that will be 8 into 30. Right? That will be 240 hours. Now 240 hours. But you have to be very careful about one thing here. 0.4 kilowatt ho gaya. Yes, exactly, Neetu. That was what I was going to tell you. This 400 watt is in watt. You have to convert it into kilowatt first, right? Because in the question they have asked us in kilowatts, right? So 400 watt will be equal to what? 400 watt will be 0.4 kilowatt. Done? So here we'll write 0.4 kilowatt, right? So energy will come out to be what? 0.4 into 240 kilowatt hours. That will be what? 0.6, and that will be 960, and this will be here kilowatt hour. So energy here, my friend, is 96 kilowatt hour. Done? For 30 days. Now what is the cost? So for 1 kilowatt hour, the cost is rupees 3, right? So for 96 kilowatt hour, the cost will be what? 3 into 96, right? So that will be 18, 3 6 are 18, 1 27, 288 rupees. Done, everyone? Done. Hi Ram, how are you? Done. So these kind of questions, especially of electrical energy, calculating its cost, these kind of questions are very important. Okay, these kind of questions are very important. Make sure that you calculate. Before calculating, you are converting the units into kilowatt and you are converting the time into hours. Okay, done. Great, everyone. Okay, next we have heating effect of electric current or Joule's law of heating. Yes, that's 288. Now the heating effect of electric current says when an electric current passes through a conductor, or a device, the conductor gets heated up. Its temperature rises, it becomes hot, raising the temperature of the conductor. Now example is bulb, fan, your electric heater, your electric iron, geyser. In case of 4 hours or 7 days, the resistance will be maximum if the diameter length of R. Can you write it again? It went up. I just read half of it. Okay, done? Now, the formula here is H equals to I square R into T, which is always equal to V square into R divided by T. Done? Okay? Okay, let me know the question again. Irfan? Okay, now while using these heating effect of electric current application, we use kettle, we use toasters, we use all kind of geysers, right? So in that we use alloys. First of all, its unit is joule, very important. Now we use alloys. Why we use alloys? Because see, in iron we need it to get hot, right? We need the geyser to get hot. Right? Okay, Irfan. So we prefer to use alloys because it has high resistivity. High resistivity means it will cause more hindrance to the flow of charges. When it causes more hindrance, it will produce more heat, and that is what we want. So alloys, because it has high resistivity and high melting point. What will you do if your iron one day melted on your clothes? You don't want that, right? Then we need high melting point so that it burns but it doesn't melt. Okay, Next we have applications, that is my electric bulb. So the filament of the bulb is made up of tungsten. It has high melting point of 3380 degrees Celsius. Filament gets heated up, emits light. The bulbs are usually filled with chemically inert gas, that is nitrogen or argon gases, to prolong the life of this filament. As it provides inert environment, they do not react with air, or they are like kind of in an inert environment that is not touched by the outer world, so they last longer. Okay. Next we have applications of heating effect of electric current. We have fuse. Now fuse basically is a protector, it's a bodyguard of our household circuit. So what does fuse does? It protects circuits and appliances by stopping the flow of high electric current that is trying to enter into our appliances. Right? Then it prevents short circuiting. It has low melting point. See, in iron we wanted high melting point, but in fuse we want low melting point. Very important point. In iron, in geysers, in heaters we want high melting point, but in here, in case of fuse, we want low melting point. We'll do numericals. We'll do numericals, don't worry. We're trying to complete the syllabus fast. Okay, so fuse we want low melting point. That's why this is made up of alloys like aluminium, copper, lead. Okay, done, or iron. So these have low melting point. These are placed in series. Very important. Fuses are placed in series with the rest of the circuit. So large current flows. When lots of current flows, what happens? The temperature of fuse increases, it melts, it breaks down the circuit, and hence it protects our household appliances. Okay, in case of 4 wires of same material, the resistance will be maximum of the diameter and length of the wire respectively are D2 and 1L by 4, D by 4, 4L, 2DL. Wait. Let me write your question down. Let me read it from here. Okay, done with this. Let us solve Irfan's question. In case of 4 wires, we have 4 wires. The first rule of solving numericals, Irfan, here is wait, give me one question at a time. Okay, the first rule is we write as we read. So we have 4 wires, same material, that means row is same. Now resistance is maximum in which case? The first case is when the diameter is D by 2 and the length is L by 4. Right, and in second case diameter is D by 4 and length is 4L. In third case diameter is 2D, length is L. In fourth case diameter is 4D and length is 2L. See, Irfan, right? So what I want you to do when these type of questions come, you can solve them simultaneously. What I mean by that, see, wait for a second. Wait for a second. Let me just. Okay, now first case, let us see first case, right? In first case, your diameter is D by 2. That means your radius will be D by 4, correct? And then area will be pi r square, which will be, let's not write here because we are going to solve it simultaneously. So area will be pi r square, which will be pi d square, and 4 square is 16. Right? Now R1 is rho L by A, right? Length was what? L by 4. Length was L by 4. Correct? So this is rho, length is L by 4, area is pi d square divided by 16. Now this 16 goes into the numerator and this 4 comes in the denominator. Look at this, rho into L, this 16 goes in the numerator and this 4 comes in the denominator. This is pi d square. So this is 4, right? Rho L by pi d square is your R1. Right? is your R1. Second case, let's see, second case is, now in second case D is D by 4, so D is D by 4, length is 4L. So R2 will be what? Rho L by A. So area will be what? Okay, let's calculate area. Radius will be D by 8, right? And area will be pi into D square. 8 square is 64, right? Are you understanding this or not? Okay, now you just calculate R2. Now we can do all this stuff. We can do all this stuff if it's a question for 3 to 4 marks, right? But if you have this question for, let's say, 1 marker only, for 1 marker only, then what you need to do? Now, resistance formula is rho L by A, right? So for maximum resistance, L should be maximum and area, that means your diameter should be minimum, right? So out of these 4, we can just see maximum length, minimum area. Maximum length is what? L by 4, 4L, L or 2L. So maximum length is L2, right? L2 is maximum with value 4L, and diameter is minimum, so D by 2, D by 4, 2D, 4D, so D2 is also minimum, D2 is also minimum, right? D by 4. So instead of solving all this, you can do this just like I solved this one. You can solve for everything, but instead of doing that, you can do this formula. You can use your brain as well, as we say. So in the second case, by just looking at the values, in the second case R will be maximum. Done? Irfan? Okay, let's move on to the next question. Next thing we have, oh, we are done with the whole chapter. Okay, we are done with the electricity chapter. Anyone has any doubt? Let me see what questions do I have for electricity chapter. I have this question. Okay, solve this question. Bulbs in the figure, Irfan, and is D. What are you saying? R equals to PL by L by R square. What are you writing, Irfan? I can't understand. Answer is D. Dead short. 1 is 61, 64.5, 0.125. Okay, dead short. Great. Dead short has given us the answer. Okay, now solve this. You don't need to solve the answer if the question is just for 1 or 2 marker. Understood? Or if it's an MCQs, you don't need to solve everything. That's where we lose our time, kids. That's where we lose our time. You don't have to solve everything. Just use that formula and you will be okay. How many 176 ohm resistors line parallel are required to carry a 224 lines? Okay. You solve this question. Resistance, we have 176 ohm and voltage is how much? Voltage was how much? 220. Is that it? In parallel. How many 160 ohm resistor line parallel are required to carry 5 ampere? Yes, we have current as well. Current is 5 ampere. Can anyone solve this question? Let's see who can solve this question. We are given that resistance is 176 and voltage is also given and current is also given in the whole circuit, right? They are asking how many resistors should be connected in parallel. The total resistance is 176, right? Let me see. Arey Irfan, it is 76. It is 76. Okay, so they are asking, we have, let's say, 3 resistors. right? We have 3 resistors. So each will be getting 220 volt, 220 volt, 220 volt, right? But each won't be getting 5 ampere. They won't be getting, each won't be getting 5 ampere. So this is I1, I2, I3, right? But the current will be equally distributed because the resistance is same, right? In current, I1 will be equal to I2 will be equal to I3, or how many resistances are there? IN, let's say. In all of these, the value of current will not be 5, but it will be same, right? But voltage will be oops, okay, done. Oh. So voltage will be same, current will be different, but resistances will be same as well. Done. So who can solve this question now? Come on, I'm waiting for your answers. Come on, come on. Anyone who's solving this question? Ma'am, I didn't block any of your IDs, guys. Okay, so that is on you. You shouldn't have done what you did. Now solve this question. Very easy, nothing. Wait. Dun, 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 dun. 1.727, dead short. How did you do that? Okay, let's see what my answer is. How I am trying to do is, see, V is given, I is given, R is given, so we can use Ohm's law, right? So V is 220 volt, I is simply 5 ampere. Now R is 76, but for one resistor. So can I write 76 into N? 76 into N. Very easy, right? So you just solve this. 220 divided by 5 into 76. We have N left here. 5 will be what? 444. So N will be 44 divided by 76. Mine is something like this. This is a weird answer. Done. But this is the answer. What can we do? 44 by 76, you solve it. 0 point something. You don't even need one resistor for this. Okay, Irfan? Yes, ma'am. 1.727. How did you get 1.727 dead short? How is what I'm asking. This is how I solved it. Total voltage is 220. So the whole is getting 220. Right? Now, in the whole, if resistance, so you must have done anything bad, unknown. Okay, so the total resistance is 76 by N. Oh, wait. Okay, great. So, in parallel, the actual formula, the equivalent resistance will be R divided by N, right? Correct. So, that will be 76 divided by N. Correct. So this here is 76 divided by N. Okay, let me solve this again. 76 divided by N. Because this is in parallel. If it was in series, then we would have written 76 into N. Right? So this is this. So this will be 5 into 76 divided by 220, and this will be N. So now you solve it. 44 will be, what is the answer? 44 divided by 76. That will be what? I am not going to solve that. That is why I hate these divide questions. 76 divided by 4 is 1.727. Great, very good. Dead short. 1.727 was it? And that is resistors. So 1.7 resistor you need. Ma'am, will you now explain refraction of light through a prism topic? I can't understand. Okay, Malathi. I will. We are going to go to the chapter human eye. I'll explain it there. Okay, dead shot. My mistake, sorry for that. Okay, in parallel you should be using that formula, 76 divided by n. Okay, great. Let's move on to the next question now. Okay, I gave you one question, guys. I gave you this question. Did you do it or not? Okay. Bulbs in figure given below are identical. Which bulb lights most brightly? That means which bulb is getting most power? Which bulb should be getting more power? Right? Now see, in this the bulb current is passing, let's say I. Okay, let's say I current is passing through this, but here it will divide I1 and I2. Again in here they will be getting I. So in this current is less. I1 and I2 are less than I1 and I2 are less than I, right? So in this the power is more. So power in one bulb and in fifth bulb will be more than power in third and fourth bulb and power in second bulb. So first and fifth lights up most brightly. N equals to 4. How are you getting n equals to 4, Irfan? If these are the given values, then your n will be 1.727. Okay. What is ROND, Irfan? This is how you can solve it. We used simple V equals to IR formula. Now you gave 76 ohm resistors. 76 divided by N were in parallel, right? 76 by N will be the equivalent resistance of all the resistors connected in parallel. So this is your answer. Okay, let's move on to the next question we have. Okay, this is from a different chapter. Now let's move on to the next chapter. The next chapter, everyone, we have next chapter as, where is the next chapter? Magnetic effects of electric current. So we all know Hans Christian Ørsted, right? N equals to 4. How, Irfan? Let me know how. Okay, you let me know how answer is n equals to 4. Until then I'll explain magnetic effects of electric current. Okay, so when Hans Christian Ørsted once was doing some experiment and he placed his compass needle near the experiment, so it is getting deflected. From there we saw that what did he prove? That electricity and magnetism are related phenomena. This research later created technologies like radio, television, fiber optics. Now let's move on to the magnet and its poles. We know magnet is a material, or magnet is an object that attract materials like iron, nickel, cobalt due to the presence of a magnetic field around it. No, R equivalent will not be n into 1 into 76, Irfan. Why? Because you written in your question, it was written they are connected in parallel. And when they are connected in parallel, the equivalent resistance is not n into 176. It is 176 divided by n. Okay. So either they are connected in series, then it is 176 into n. But if they are connected in parallel, that will be 176 divided by n. Okay. Okay, let's move on to the next chapter. We have very less time, everyone. Okay, every magnet has two poles, north pole, south pole. Like poles attract each other, unlike poles repel each other, and magnetic monopoles does not exist. Magnetic monopoles does not exist, right? Next we have magnetic field and field lines. So what is a magnetic field? The region around a magnet, the area around a magnet in which a current carrying conductor or a magnet feels its magnetic influence. If we feel its magnetic influence, then that region is called magnetic field. And its SI unit is on a very great scientist, that is Tesla G. So its SI unit is Tesla. And magnetic field lines will be imaginary lines that represent the direction and strength of the magnetic field. Imaginary lines that represent the strength as well as the direction of magnetic field is called magnetic field lines. Next we have properties of magnetic field line, a very important topic. They can ask you in the question directly. They emerge from north outside the magnet, and inside they goes from south to north. Closer the lines, strong magnetic field; wider lines, weak magnetic field. Direction at any point will be given by the tangent at that point. Direction of magnetic field will be given by tangent at that point. Right? Then we have the magnetic field lines never intersect each other. If two magnetic field lines intersect at a point, then there will be two tangents at that point. And we know, we studied in maths, a very difficult exam that CBSE gave you. We studied that no two tangents at one point, two tangents cannot exist, because that means at that point the compass needle will be pointed in two different directions. That is not possible. So that means at one single point, that means magnetic fields cannot intersect each other. Done. Next we have magnetic field. So when we place a compass needle over or under a wire and a current is passed through that wire, we saw that the compass needle is getting deflected, and that is what we called magnetic field due to a current carrying conductor. Now, if the polarity of the battery reverses, see, there is positive, negative. Now, positive is here, negative. So, this is pointing in north. Now, it is pointing in a different direction. Done. So, if the current direction is changed, then if the direction of current changes, then the direction of magnetic field also changes. Okay. Then we have magnetic field due to a current through a straight conductor. So we took a battery, we took a wire, and the current is going from X to Y. So we saw, if it is a wire, if it is a straight current carrying conductor, then the magnetic field line will be in concentric circles around that straight conductor. Okay, now we know that magnetic field line is directly proportional to the current. It is inversely proportional to the distance. As we go away from the conductor, the magnetic field decreases, and change in direction of current changes the direction of magnetic field but does not change the strength of magnetic field. I got one question from Irfan. Wait, everyone. Hey, everyone who's here, go like the session fast. Hey, Vinay again. Every time Vinay is saying good morning now. Go like the session fast. An electron moving in a circular orbit of radius this around nucleus at a frequency of this to the power this, estimate the magnet. Arey, which class question you are trying to do, huh? Don't go into this question. This is not important. Even though if you read this question, frequency has no use. This question will not come in your exam. Okay, Irfan? So we are not wasting our time on this now. Now, right hand thumb rule, we know when the thumb of my right hand points in the direction of current, the curling of fingers will give the direction of magnetic field. Next, we have magnetic field due to a current through a circular loop. Now, here we will use the right hand thumb rule. See, current is in upward direction, so it goes in direction of field, it goes in, comes out. So, here it goes in, it comes out. So, for clockwise current inside the circular loop, the direction of magnetic field line is inwards, and this pole will be south pole. Right? If it is anti-clockwise, the current is downwards and it is coming out from here and going in from here. So this is outwards. And for anti-clockwise, this face will be north pole. Right? Understood? Great. Next we have factors affecting magnetic field. Again, it is directly proportional to current, inversely proportional to radius of the loop, and inversely proportional to distance from the loop as well. Next, we have from a solenoid. Now, what is a solenoid? It is a coil of many circular tones of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. It has same kind of magnetic field as that of bar magnet. Inside the solenoid, the field lines is uniform. Outside, it is non-uniform. Understood, everyone? Okay, next we have the factors affecting. It is directly proportional to current. It is directly proportional to the number of turns. It is directly proportional to number of turns. Inversely proportional to 1 by distance from the solenoid. Okay. Okay. Next we have electromagnet. Electromagnet, when you insert a soft iron core inside the solenoid, then that soft iron core becomes a temporary magnet which is called electromagnet. The magnet so formed is called electromagnet. One more thing you have to take care of, like this is the battery. Okay, so the north pole of the battery will be, the negative side of the battery will cause a north pole on the solenoid, and positive side will cause a south pole. So magnetic field lines will be somewhat like this: outside north to south, inside south to north. Done? Okay, next we have difference between permanent and electromagnet. Permanent magnet is permanent, fixed strength, fixed polarity, but electromagnet is temporary. If we increase the current, strength increases. If we change the polarity of the battery, the polarity of the magnetic field also changes. Next we have force on a current carrying conductor. So whenever a conductor is placed in an external magnetic field, that external magnetic field produces a force. Right? The current carrying conductor experiences a force whenever it is kept in external magnetic field. The direction of force can be reversed when the direction of current through the conductor or magnetic field is reversed. So example is electric motor, generator, loudspeakers and microphones. Very easy. Now the most important part of this whole chapter, that is Fleming left hand rule. They can directly ask you to state Fleming left hand rule. Right? So what does Fleming left hand rule says? That if you stretch your forefinger, middle finger and thumb in a perpendicular direction, then forefinger in the direction of magnetic field, middle finger in the direction of current, then thumb will give you the direction of force. Ma'am, dispersion में हूँ, dispersion में हूँ या depression में हूँ? Huh? Okay. Next we have earth wires, household wires. We have 3: live wire, neutral wire and earth wire. Live wire carries the electric current from electric pole to home. Neutral wire carries the excess current. It completes the circuit and carries the excess current back to that pole. Then third, green wire carries the excess current on the metallic body, pass it down to the earth. 2 long parallel wires are hanging freely. If they are connected to a battery initially and in parallel, what will be the effect in their position? Initially and in parallel. Okay, let me correct the question. If 2 wires are suspended parallelly, the current will be either in same direction or the current will either be in the opposite direction. So will they repel or will they attract? If the current is in same direction, so you will see the current is in this direction, it's going in the below wire. This is a parallel wire, current is in this direction, so it is going in the same direction, going in, coming out, so they will repel each other. Okay, if the current is in same direction in both the wires that are suspended parallel to each other, the current will be in the same direction, then they will repel each other. If the current is in different direction, then both those wires will attract each other. Done? That is your question actually. Now, moving on, we have AC and DC comparison. AC changes its direction periodically. AC changes its direction periodically. DC has fixed direction. It has different magnitude, increases, decreases, negative. It has fixed magnitude. Household circuit, AC current comes 220 volt. Direct current comes in battery or cells. And less power loss over long transmission, more power loss over transmission. That's why we say AC is better than DC, because over long transmission less power loss happens in AC. Done. Next we have Fleming left hand rule, a very important numerical on this. See, an electron enters a magnetic field at right angles to it, the direction of force acting on the electron. We have to find the direction of force, so we will be using Fleming left hand rule. समझ आई? Okay. Okay, now Fleming left hand rule says you have to point your forefinger in the direction of magnetic field, that is this. Now middle finger in the direction of current, but this is the direction of electron. Now current is in opposite direction of the electron, right? So middle finger is upwards. So thumb is inwards, right? So this is into the page is the correct answer. नहीं बना तो ऑप्शन भी. Okay, done everyone. Prime Fleming के पास right hand नहीं था चला. Okay, solo. That is something to be worried about. Okay. Next we have short circuit and overloading. Again, a very important topic. We all know short circuit. A short circuit happens when live wire comes in direct contact to the neutral wire, and it comes in direct contact, allowed a large current to flow without any resistance. Overloading, if you connect lots of appliances on a single plug, on a single wire, that is called overloading, connected to a single circuit, drawing more current than the circuit's safe limit. Then it results in power shortage or fires, burns, right? The live wire and neutral wire comes in contact either directly or by conducting wire, then it is called short circuit. Yes. Correct, Prakash. Okay. Next we have a household circuit. You should, I don't think they ask this now. Because that is the whole phenomena, right? When we place a current carrying conductor inside a magnetic field, it experiences a force, and that force makes it to move, right? Now we have earth wire, live wire, neutral wire. All they are going through fuse first. It is connected in series, then meter, then a distribution box. It distributes the live wire, the neutral wire, and then the earth wire in the upper plug, in the third pin plug, right? Now earth wire connects all the charge, passes down to the earth so that we don't get any shocks. Done? Okay, next we are done. Again, there is a PDF in the description. You can click that link and you will be taken to a PDF where we have given you a question bank of all the solved questions of physics, chemistry and biology. All the solved numericals, all the solved MCQs, all the solved reactions of chemistry. So go check that link out right now and like the session as well. Okay, subscribe the channel as well. Next we have human eye. So all the questions of your dispersion, of your whatever the questions were, will be answered in this. Now everyone, we always play a game. We will play a game right now. Who of you can tell? Now I'll ask you a question about, I'll give you a question about the function of a particular part of the human eye, and you have to guess what part is it, right? So the first, which part of human eye is responsible for maximum refraction? Which part of human eye is responsible for the maximum refraction? Irfan, AC generator is not in your syllabus for CBSE right now, so we will not be studying about that right now. After that we will, okay? Done. Now let me know which part of the human eye is responsible for maximum refraction. Cornea. Very good, very good. Cornea is responsible for maximum refraction of the human eye. Next question. Which part is responsible for the color of your human eye? Which part is cornea? Very good, very good. Which part is responsible for the color of your eye? That is most refraction of light rays entering into the eye occurs at the outer surface of the cornea. Very good, Prakash. Next question, which part? Yes, iris. Iris is responsible for the color of your eye. I'll be quickly reading the first answer, okay? So you have to be fast. Now, which part acts like a shutter of the eye? It controls the amount of light that is entering into your eye. The amount of light that is entering into your eyes. Oh, Sharma ji is here. It says pupil. Vedang says pupil. Great. Pupil acts like a shutter of your eye. Number of will be connected to a single source will provide more illumination if connected in parallel. They will provide more illumination when they are connected in parallel, Irfan, because in parallel the resistance decreases, current increases, and hence they illuminate more. Okay. Next, what is the part between your cornea and lens which maintains the pressure on your lens? Arey chup. Done. Yes. Okay. Let me know the answer. The part between Keshav, it's not enough to get a centum, but it's enough to pass, I'll say, or get decent marks. Huh? That I don't know, Irfan, to be honest. Why the spark is of white color? Hi. Okay, let me know. Which is the part? Yes, aqueous humor, Vedang. Very good. Sharma ji, aqueous humor. Who said aqueous humor? Great. So the part is aqueous humor, dead shot. How is that ciliary muscles? Aqueous humor. Now, which part of the eye is responsible to focus the rays on the retina? Focus the rays on the retina. Paper is tomorrow, science. Yes, then? Which part of the human eye is responsible to focus all the rays on the retina? Cornea. Focus all the rays on the retina. Science? What are you guys doing? Tomorrow is your exam. Ciliary muscles. Don't give me a heart attack. The part of the human eye which focuses all the rays. Yes, Vedang. Crystalline lens. Very good. Crystalline lens. Lens is used to focus all the rays on the retina. Everyone, crystalline lens. Focus rays on retina. Okay, next we have the part of the eye which controls the focal length, which will help to change the focal length of your eye lens. Hi Rajput. Hi Manish. Hi Shravan. How are you? Let me know. Ciliary muscles. Very good. Ciliary muscles actually controls the size of your lens, or you can say changes the focal length of lens. Dead short, ciliary muscles. Great. Yes, they will. They will give numericals on corrective lens. I have few numericals on corrective lens. So make sure you answer very quickly so that we can move on to those numericals. Hanji Zeba. Yes, I remember you. You came before as well. Okay, next we have a retina, simply a screen on which the image is formed, and an optic nerve which transfer all the electrical signals from eye to the brain, and vitreous humor. Vitreous humor is a fluid between your eye lens and retina that keeps the eye in its shape. Right? That keeps the eye in its shape. Next we have power of accommodation. Power of accommodation is the ability of eye lens, to change its focal length to see nearby or far objects clearly. Then, okay Zeba, we are leaking the paper here as well. Done. Now, if muscles relax, if ciliary muscles relax, that means the eye lens becomes thin. If eye lens becomes thin, its focal length increases and it can easily see distant objects clearly. Right? Now, yes, very good Irfan, great. Now, second, if muscles contract, eye lens becomes thick. If eye lens becomes thick, the focal length decreases. If focal length decreases, it can see nearby objects clearly. Okay, Sharma ji, you are taking science in 11th. I'll meet you there. Okay, next we have two kinds of very important defect. One is myopia, one is hypermetropia. Myopia is nearsightedness, where you cannot see far by objects clearly but nearby objects very clearly. In this, the image is actually formed in front of the retina. And what are the causes? The causes are elongation of the eyeball, or yeah, of course Sharma ji. And if image is formed in front of retina, what are the causes? Elongation of eyeball, or excessive curvature of the eye lens, or a decreased focal length of the eye lens. Then next we have hypermetropia, farsightedness, where you can see far by objects clearly but not the near ones clearly. Oi Bhagwan. And the image is formed in behind the retina. What are the causes? Less curvature of the eye lens, increased focal length of the eye lens, or decrease in size of the eyeball. For myopia, the corrective lens is used as concave lens. For hypermetropia, the corrective lens is used as convex lens. Okay, done. Yes, a key concave lens. Oi hoy. Okay. Then we are almost completing our whole physics. Everyone, clapping for all of you. We are about to complete the whole physics. Now, in almost 2 hours. Done? Okay, next we have presbyopia. A person who cannot see nearby objects as well as far objects clearly has presbyopia. Okay, Irfan, I'll answer that in just a minute. Now, why presbyopia happens? Why presbyopia happens? With the old age, all your muscles gets weak. So similarly, eye muscles, ciliary muscles also gets weak, so they cannot change the focal length of eye lens very easily. Weakening of ciliary muscles to anyone curvature of lens. So it decreases the elasticity of the eye lens. Because of that, presbyopia happens. What is the what do you say? Correction, we use bifocal lens. Bifocal lens is something like this. The upper part is concave lens. The upper part is concave lens. The lower part is convex lens. The lower part is convex lens. And we all know you can definitely, anyone can definitely donate their eyes after their death. Okay, Manshvi. Okay, great. If you have already completed the whole physics, that is great. We'll see solo edits. We'll see something about that. Okay? Okay, Hari. Yeah, so when we enter from sun into the direct room, why does it take so much time to see that room? Because in that room there is like complete dark. So our pupil that adjusts the brightness of light entering into our eye, that takes time to get enlarged. When you are in sun, pupil is small, so that not lots of light can enter your eyes to protect your eyes from more light. But as you go in, pupil has to expand so as to collect all the light that is there, small light that is there in the room. So that is why it takes some time to expand, and hence we take that little bit time to see the objects clearly. Next we have a rainbow. Who asked for rainbow? Now inside rainbow, not rainbow, okay, first do the refraction through prism. Now refraction through prism, a light ray comes, you draw a normal on the surface. First of all, this is angle of prism A. Now it this is air, this is glass, this is air, so it will bend towards the normal. Now this is refracted angle, this is incident angle. Now again this is a normal. Now it will bend away from the normal, so this is the normal now. This is the normal now, so it will bend away from the normal. This is emergent ray, incident ray, refracted ray. If you extend this and extend emergent ray back, this angle, the angle between incident ray and emergent ray is called angle of deviation. This is angle of emergence, angle of refraction this, angle of prism this, angle of incidence this. Done? Quick revision. Range of vision is infinity to 25 centimeter. Near point is 25 centimeter, far point is infinity. हाँ शर्मा जी, एग्जाम खत्म होने के बाद you will sleep. I always sleep after exam, and I sleep till the next day till 12, till 1. Okay, now dispersion of light. When white light enters into a prism, all the components of white light has different wavelengths, so they bend at different angles inside the prism. That is why I also told you about the cause of dispersion. Why the cause of dispersion is because all the 7 components of light have different wavelengths, so they bend at different angle. Right, so this is the color. In the lower one is violet, and as you go up the color is red. Now Newton ji said, I want to increase the syllabus. Okay, solo edits, we see. I want to increase the syllabus of my kids, so let us place an inverted prism in front of these 7 colors. So what did he saw? The white light got dispersed into 7 colors, but if I place an inverted prism in front of those 7 colors, it merges back and comes out as a single white light. Okay? Lo, Neetu will teach you IT. Solved. Sharma ji, I don't teach on any channel in 11th. Okay, next, formation of a rainbow when the light enters in a water droplet. When the light enters in a water droplet, what happens? It refracts and it acts like a water droplet is also has different medium, so the light gets dispersed, then total internal reflection happens, then again refraction. So it goes in, refraction happens and dispersion happens, then total internal reflection happens, then all the 7 colors come out and we see a beautiful rainbow. Then rainbow formation, refraction, dispersion, internal reflection and refraction. Very good. A key. Okay. Next we have scattering of light. Scattering of light, the ray actually moves straight, but if there is an obstacle like tiny particles like dust, like gas, like rain, like water droplets, so what happens? The light ray gets deviated. It gets deviated from its path, and hence that is called scattering of light. Tyndall effect, when a beam of light strikes very fine particles. Scattering is the light is colliding with big particles, but Tyndall effect is light is interacting with or striking fine particles in the atmosphere, and that makes the beam of light appear visible. It makes the beam of light visible. Done. And these are some of the questions. Miss Goika, what is that solo? Okay, so well-labeled diagram of human eye, you should know that. Stars twinkle but planets do not, because planets are very close to us, so they don't act as an point object. They act as a bigger object, so all the rays coming from that, even after the refraction, it got cancels out, the net averages out. Yes, FF Gamer, I remember you. You said you were in 11th. What are you doing here? Next, but stars are very far away from each other, so they act as a point object. So from there the rays come and it shows that it is refracted. No, right hand thumb rule is not deleted. No. Right hand thumb rule is not deleted. Fleming right hand rule is deleted. Fleming left hand rule is there, right hand thumb rule is there. Fleming right hand rule is deleted. Okay, Fleming right hand rule is deleted. You said you are in 11th FF gamer. No? Okay, sorry then study. Okay, so why is this color of the sky blue? See, we just studied about scattering of light. So the light that is coming from sun has wavelength equal to blue color, the smaller wavelength. So the light wavelength and the scattering particle wavelength should be equal, so they scatter. So they scatter when the wavelength of light coming from sun and the wavelength of particle is equal. Irfan, I missed your question, please write it again. Okay, so because blue color wavelength is equal to the wavelength of particles in the sky, it scatters the most. That is why blue color scatters the most, and that is why sky appears blue. Why danger signal is red? Because the scattering color is blue, so all other colors almost scatter, but blue does not, red does not. And as red does not scatter, it goes till larger distances. As it goes till larger distances, we can see the color very clearly from a large distance. Okay, no Vedang, I saw you very first time in the chat today. Done. And everyone, hands down and clapping for all of you. We are done with whole physics, and from today morning you all are there in the session, so you have completed the whole science. The whole science is completed. Solenoid does not behave like a bar magnet. You cannot say that solenoid behaves like a bar magnet, but solenoid, okay, you can say that, but see, this is negative part, so this is north pole, positive part, south pole. So it is just says that it behaves like a bar magnet because the magnetic field lines of solenoid and bar magnet are similar. Like this, outside they go from north to south, and inside they go from south to north, north to south outside. And bar magnet is the same. Bar magnet is the same, right? This is north pole, this is south pole, and these are the magnetic field lines of a bar magnet. So these are similar to the solenoid. Make sure they don't intersect. North to south outside, north to south outside, inside south to north. Done? So we can say it acts like a... What is the difference between them? Yes, that's a good question. What is the difference between them is that this is a permanent magnet. This is a permanent magnet, whereas this is a temporary magnet. If you stop providing the current, this will not be a magnet anymore, right? Now, its polarity can change. Polarity can change, right? If I switch the polarity of the battery, this will become north pole, this will become south pole. But this, you cannot switch the poles, right? So polarity is same. Polarity is always same. Its strength can be changed. If I increase the current in the solenoid, it will be a bigger magnet. Its strength is fixed. Done. Its strength is fixed. Solenoid is a temporary magnet, bar magnet is a permanent magnet. Very good, Vedang. Done. Any more questions? Let's look at my questions then. The questions I got you. Questions. Okay, let's start with this one. Wait. Let's start with where did the question go? Everyone do subscribe the channel as well, because we will be bringing all other chapters, all other subjects as well, SST, Hindi, everything, okay? So go subscribe the channel. Now, the first question, very important question, because this has been asked, okay? And if not, they can ask this. CBSE has gone a little bit this. Okay, so the values of absolute refractive indices of kerosene and water are 1.44 and 1.43. Refractive index of kerosene is 1.44. Refractive index of water is 1.33. 3. So compare the two media on the basis of their optical density. Which will have more optical density, water or kerosene? Which will have more optical density? Water or kerosene has more optical density. No, Vedang. We have Tanvi ma'am for SST. She'll be taking all your lectures of SST, okay? Oof. So, everyone, go subscribe the channel then. Hello, Solo is back. Okay. Done. So optical density of kerosene will be more. Kerosene will be more than water because refractive index of kerosene is more than refractive index of water. What about mass density? Everyone, what about mass density? Hari is saying water. Water? What about water, Hari? Okay, okay. Great, great. Subscribe the channel fast, everyone. So, listen to me very carefully. Optical density we can see based on refractive indexes, but mass density you cannot infer from the no, FF gamer, listen to me very carefully. Mass density you cannot see from mass density cannot be inferred from refractive indices. Acha Solo, okay. So mass density, you won't be able to tell mass density from refractive index. Let me see. So N12 is N1 by N2, V2 by V1. That will be just wavelength and frequency. So mass density, you won't be able to tell mass density from this what do you say information, but we know that mass density of kerosene is generally more than water, definitely, right? Kerosene is heavier, so mass density of kerosene is more than mass density of water. Then relative speed of propagation of light. Where will the light travel faster, in water or in kerosene? Where will the speed of light be more, in water or in kerosene? Yes, Vedang, give me 1 minute, I'll repeat. Water, yes. So in water, the relative speed of light will be more. See, Vedang, refractive index of kerosene is more than refractive index of water, right? That means optical density of kerosene will be more than optical density of water. For now, take optical density is how much you can see. You can see more in water but less in kerosene, right? So in which you can see less, its density will be more. That's why you can't see through it, right? Right? So optical density of kerosene is more. Mass density of kerosene is again more than mass density of water, right? Because water is definitely light, right? Now speed of light in water, will be more than speed of light in kerosene because the refractive index of water is less than refractive index of kerosene. Done. So that means water is rarer and kerosene is a denser medium. These all are important topics, my friend. This refractive index is a very important topic. Then, okay, let me tell you what are the important topics. First, refractive index, very important topic. The formula N1, this formula. Make sure you have crammed this formula to your core. This formula is very important. Okay, then all the ray diagrams are very important. Ray diagrams, their sign conventions are important. Glass slab is very important. Okay, and you'll say, ma'am, so everything you said is important, but these are important. Then from human eye, defects, the correction of these defects, corrective lens, which lens is used to correct which defect, that is very important. Numericals are very important. Numericals of human eye chapter, near point, far point, very important. In this also numericals are very important. That's why I said sign conventions are important. And then in human eye, that is it. And in electricity, power is important, electrical energy is very important, its unit is in kilowatt hours. And then combination of resistors is very important. And then in magnetic effects of electric current, solenoid is a very important topic. Fleming left hand rule and right hand thumb rule, these are very important topics. Done. Those are actually questions. So atmosphere, I did explain you all the questions, right? See, sunrise and sunset, the color at sunrise and sunrise are not in the your syllabus. Frequency of AC current is 50 Hertz. So I don't know banking and insurance, I'm so sorry. Of course, Divyanshu, you come to Bangalore anytime, I'll meet you. Okay? We will definitely have a meetup with all of you guys, or whoever of you can come, we'll definitely meet with you. Done. And then what else is left? Scattering of light I told you, twinkling of stars I told you. Twinkling of stars is because there are so many refracting layers, there are so many layers of atmosphere from the star till our eyes. So because of all the different densities of those layers, we see refraction a lot. Okay? Yes, we'll discuss the paper tomorrow, Divyanshu, will definitely. My name is Aditi. Okay? Okay, any more questions? Banking and insurance. When is your exam of banking and insurance, my friend? Me too, FF Gamer. Okay, next, what were we doing? Let's see what else numerical. Oh, this numerical is very important. One portion of a convex lens is covered as shown. Will the lens produce a complete image of the object? Will the lens produce complete image of the object? Yes, Hari, we are doing questions for you. Hanji, Bhavya. Will the lens produce proper image? Yes, the lens will produce whole image, but the brightness of the image, will be very less. Brightness will be very less. Done. This live will be maximum for half an hour, and tomorrow there will be a 4 AM session where we'll be looking again all the important revisions. And then tomorrow we will also have a live of paper discussion. Okay, ma'am? Yes, Divyanshu, if you have any question, please ask. Then next we have next question. Right. When a beam of white light passes through a region of very fine dust particles, the color of light that scatters the most in that region is what? Red, orange, blue or yellow? Give me the answer. First. I am from Punjab, Irfan. Let me know the answer first. Red, orange, blue or yellow, which color scatters the most? A, B, C, D. Question on your screen. Arey, Hari is saying A. Scatters the most, Hari. Scatters the most. Okay, FF Gamer, done. Scatters the most, guys. Vedang, yes. Vedang to the rescue. Bhavya, yes. Blue scatters the most, everyone. Blue scatters the most, yes. So option is C. C is the correct answer. Blue color scatters the most. Yes, very good, Hari. Now you're right. Okay, next we have a question. Oh, this is a good question. Good question. A, B, two VI graphs A and B for series and parallel combination of two resistors as shown. State which graph shows series and parallel combination of the resistors. Now, let me know the answer. I want you guys to answer this. Take out your pen and copy if you want. Answer me this question. V equals to IR. Answer me if A is for series or B is for series. Fast, fast, fast. Fast, 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 fast. B, A parallel, B series. Okay, okay, okay. B, 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 B. Let's see, let's see. So, every time we are doing these questions, first is you have to calculate the slope. Now, slope is what? Y component divided by X component. Y component is what? Y component is I and X component is R. So, slope is equal to, not R, sorry, V. This is V. So, slope is equal to I divided by V. Now, second step is to calculate a value of R from Ohm's law, right? So, that is V equals to IR. So, R equals to V by I. Oh, what happened? This what happened? B, you are saying B. B to what? B is what? Why is everyone answering B? State which graph shows A, series, B, parallel combination. B shows series. You are saying. Okay, now this is V by I, but this is I by V. So, if I inverse this, if I do I by V, then this will be 1 by R, right? Now, I by V, I by V. So, slope is now 1 by R, right? So, if slope of A is definitely more than slope of B. So, slope of A is more than slope of B, but slope is inversely proportional to R this time. That means R of A will be less than R of B. Now, in which case resistance is more? In series. So, in series the resistance is more. So, B is in series. A resistance is parallel. So, A will be parallel and B will be series. In series, we have the answer as B. Parallel, we have the answer as A. Great. Very good. Next question. Where is the next question? Next question we have for you. In order to obtain large images of the teeth of patients, the dentist holds the concave mirror in such a manner that the teeth are positioned at where? At the focus of the mirror, between the pole and focus of the mirror, between focus and center of curvature of the mirror, or at the center of curvature of the mirror. Where will? No, FF gamer. I won't tell you even if I do. B, Sharmaji is saying B, Hari is also saying C, oh B, sorry. Okay. Done. So, you all are saying B. That is correct. Between pole and focus, because that will make a virtual image of the teeth, and we want the virtual image of the teeth for the dentist because they place it very near to our teeth, right? So, B is the right answer between pole and focus of the mirror, right? B is the right answer, everyone. B. Okay, B is the right answer. Next, we have the possible way to restore clear vision of those people whose eyeball has elongated is the use of which lens? Bifocal lens, converging lens, concave lens, convex lens. Let me know the answer. FF Gamer is saying C. Oi bhai. Sharmaji is saying C. Ayo, I'm standing for so much, my back pains. Hari Ji is also saying C. The Gorge 1 is also saying C. C. Hi guys and C. How are you? Sandhu is saying A. Everyone else is saying, Hari is saying C. Great, great. All of you. Anju is also saying C. Okay. Actually, it is what? C. The possible way to restore clear vision of those people whose eyeball has elongated. Eyeball has elongated means eyeball has become big. That means all the rays will converge before the retina, in front of the retina. Now that defect is what, my friend? That defect is myopia. And how do you correct myopia? By using concave lens. So C is actually the correct answer. Very good, everyone. All of you are prepared for tomorrow's exam. Why are you scared? Yes, we'll take the break in some time. Do you want some Diet Coke? No, my throat is very bad. Arey, I won't, Sharma ji. I will never. The ciliary muscles of a normal eye in their first most relaxed, second most contracted state. In which of the two cases the focal length of the eye lens is more? See, Irfan, I didn't understand your question. Your question is a little bit incomplete. But see, when your muscles, ciliary muscles are contracted, when your muscles are contracted, the eye lens becomes thick. That means the focal length is less. And when they are relaxed, when the eye muscles are relaxed, the lens becomes thin. That means focal length is more. Focal length is more. For less focal length, you can see nearby objects clearly, and for more focal length, you can see distant objects clearly. Right? Done, everyone? Okay, next we have another question for you. If the direction of current in the solenoid when viewed from a particular end is anti-clockwise, then this end of solenoid will be what? North pole, south pole, east pole, or west pole? Which will be this pole? If the current in that direction is anti-clockwise. A, B, C, D. Let me know the answer. Man, which defect do you have? Only tell the power of lens. I have, my power of lens is minus. It is negative, -2. Anti-clockwise north. Very good, Sharma ji. A is the correct answer. Anti-clockwise is north. Hari also said north. Great. Gosh, 1A. Very good, everyone. Great. Okay. Now, anyone has any doubt? Let me find if I have more questions for you. I got all the important ones for you. Oh, I have one question for you. Are you able to solve this? Will you be solving this? Or this gives you nightmares? Is this question be easily solved by you? Can you solve this question? Can you solve this question? Who can solve this question? Come on, guys. Ui ma, yes, ma'am, very easy. Okay, yes, then give me the answer. Okay, then a lot of you are saying you can solve this question. Give me the answer, then we'll solve the question together. Okay. Okay, समय लगा के. Done, Sharma ji. Wait. Okay. Okay, FF Gamer. Tell me the answer of this question. Yes, bhaiyo. All the best for tomorrow, everyone. These are some of the final moments of your science. Let me know the answer. Hello, Divyanshu. Solve these questions. Solve this question. Whoever is new, solve this question. I'm watching your answers. Come on, everyone. Easy question. 100 ohm. FF Gamer has given the answer, everyone. 100 ohm is our first option. Anyone has any other option? 100 ohm. FF Gamer has said 100 ohm. Anyone else? Yes, Chaudhary ji. $155.6653. Oh, we have another answer of Shashikala. Shashikala is saying 155.66. Oh, 155.66. Oh, Sharma ji is saying 102. We have lots of different answers. CBSE will be very happy to see this. You guys, come on. A lot of you, I see a lot of you students are from Tamil Nadu. Welcome, welcome everyone, all over India. 145, Hari is saying 145. Okay, now I am under a lot of pressure. Okay. Let me solve this question. Now. Okay, the first we are going to solve is 60, 80 and 20. These are in series. Let us name these resistances. This is 1, 2, 3, 4, 5, 6, 7, 8. Done. Now, first we will be solving 3, 4 and 5th resistor. First we will be solving R3, R4, R5 are in series, right? So we will just directly add them. We'll name it as RA, right? R3 plus R4 plus R5. That means these resistances are 60, 80, 20. 60 plus 80 plus 20. So that will be 120 ohm. So RA will be 120 ohm. Let me make the circuit again. 1, 2, 3, 4, 5. I don't remember. 1, 2, and this will be a single now. And this and this. And 1, 2. This is 1. And this is 2. Right? Now this is 160, 160, 20, 28. Hey Bhagwan, 20, 28. This is 120. This is 160. And this is 160, 160, 52. 52. I made something wrong. There is no resistance here, right? This is 52. Now this is my circuit, that is new one, right? So these two are in parallel, RA and this is R7, right? So these are in parallel. We'll solve this. 1 by R7 plus 1 by RA. So that will be 1 by 60 plus 1 by 120. What will be the LCM of 1 by 160 and 1 by 120? Yes, RA is 160. How is RA 160? 60 plus 80 plus 20. Oh, sorry. Yes. Correct. This is 160. Sorry. My mistake. This is also 160 now. That is simple then. Let's name it as 1 by RB. 1 by RB is equal to 1 by R7 plus 1 by RA is equal to 1 by 60, that is 2 by 160, that will be 1 by 80. So RB is 80 ohm. RB is 80 ohm. By solving these two we solved, that is RB. Let's make the diagram again. This, and this, and this, and this, right? Now 160, 28, 20, 20, 28, this is 160, and this is the rest of the circuit, right? And this comes out to be 80. This is 80 ohm, right? This is RB, and this is R what? 6218. 6218, right? Now 52, 28 and 80 are again in series, right? 52, 80 and 28 are again in series. Then we will just add them. 28 plus 80 plus 52, that will be 108 plus 52, right? That will be 160 ohm. This is now our C. So if I again make the circuit, what will be the circuit now? This, right? This is 160 and this is the circuit now. 160, 160 and 20. This is 1, this is 8 and this is a C, RC, right? Now these are in parallel. These are in parallel. So 1 by 8 and 1 by RC. 1 by R8 plus 1 by RC will give you 1 by RD. These two are in parallel, right? So 1 by 160 plus 1 by 160. That will be 2 by 160. That will be 1 by 80. So R of D will be 80 ohm. Done. R of D will be, galti ho gayi Malik. RD will be 80 ohm. So this whole will be 80 ohm, right? So now what the circuit is left? This circuit is left, right? This is 20, this is 80. So these are in series. We'll just add them. 80 plus 20, that is 100 ohm. And FF Gamer is our winner. Chicken dinner. Okay, Radhe Radhe Arav. Done. FF Gamer is the winner, everyone. Clapping for FF Gamer. Come on, great. Yes, Himanshi, whole syllabus is complete. Great. Then you can answer these questions. I am great, Divyanshu. How are you? Okay, let's see more questions. See, AC and DC we already explained. Let's just go through it again. It changes its direction periodically. It has fixed direction, direct current. It changes its magnitude. It increases, 0, decreases. Its magnitude is fixed. Household circuit, 220 volt. Battery, cell. Used in battery and cell. We have less power loss along long transmissions, more power loss. In our households, hi Yash, hello. In our households, we get 50 hertz of AC supply and DC doesn't have any value really. Yes, student, ask your doubt. Ma'am, my 7 crore, de do, UPI ID. Yes, UPI ID, I'll give me your UPI ID, FF Gamer. Ma'am, 2 ohm ka difference hai. Yes, Sharma ji, but CBSE won't see that if it's a difference of 2 ohm or 2000 ohm. Okay? Yes, Lakshay. How are you all? Yes, Chaudhary. What do I have to tell you, Chaudhary ji? Class will be over in just few minutes, Hari ji. Class will be over in few minutes. Done. Let's move on to the question. We have a question. Oh. State one advantage of AC over DC. Oh, your senior is in IIT Bombay working on batteries. That is flattering. Good morning, Chaudhary ji. Good morning. We all wake up. Harmful effects of electricity. You can say pollution. There are no such questions like harmful effects of electricity. Use of resources. Hanji Chaudhary ji, what do I have to tell you? Good morning. Okay, AC is for long distance, but DC is not for long distance. Okay, Irfan. One major advantage of AC over DC is easily and efficiently stepped up or down. Okay. Okay, done. So AC can be transmitted over long distances. AC can be transmitted over long distances without any power loss. Without any power loss. Done. And when a current flows through a straight conductor, a magnetic field is produced around it. How can the direction of this magnetic field be determined? How will we determine the direction of magnetic field? Using which rule? Which rule is used to find the direction of magnetic field? Hello, Chota Bheem. How are you? How is Chutki, Chota Bheem? How is Chutki? AC is air conditioner. Okay, FF gamer. Yes, Lakshay. Okay, great. Done. Everybody. Yes, bio. We did it in the afternoon. Okay? Okay. Next question, let's see. I have one question for you guys. Very important question. Oh, this is a very important question. A soft iron bar. Okay, Sangeeta. A soft iron bar is introduced inside a current carrying solenoid. The magnetic field inside the solenoid will decrease, will increase, will remain same, or will become zero. Ma'am, what is study? Bangan. It will increase. Shashikala is saying. Yes, Lakshay. Bio, we did it in the afternoon. B will increase. Okay. B will increase. Very good. Hariji is saying C will remain same. Sharmaji is saying increase, Malik. Okay, it is actually increase. Great. It will increase. B is the correct option. Right? See, soft iron core actually you'll study it later. So iron is a ferromagnetic substance. Ferromagnetic is, I don't want you to explain it here. I don't want to explain you here. But it's like domains are formed. What do you say? What is that word? Some sections are formed and they align in the direction of magnetic field. So electrons are aligned in the direction of magnetic field. So the magnetic field increases. Okay. The bulb will be more illuminated in parallel, Irfan, because the resistance will be less and current will be increasing. Right? That is why the current will be this illumination will be more. Okay? Then Gojo's domain explanation in JCK. What? Okay. Next question we have is we have one question. Oh, actually I have lots of questions for you. Let's do some numericals then. This you can do. Okay, this also you can do. Let's do this one. Yes, the near point, everyone be very careful. The numerical of human eye, the chapter you neglect all year. Okay. The near point of a person suffering from hypermetropia is 75. Hypermetropia, near point is 75. Calculate the focal length and power of the lens required to enable him to read the newspaper, which is kept at 25 centimeters. So, to solve this, be very careful. Okay? Okay, now whenever a near point or far point is given in the question, that near point or that far point will always be your image distance, that too in negative. So here hypermetropia, V is minus 75 centimeter. And since it is hypermetropia, hypermetropia means you cannot see nearby objects clearly. So actually the 25 centimeter is given, right? So 25 centimeter, this 25 centimeter is your, it is your U, object distance, right? So what they're trying to say, an object is placed at 25 centimeter, but you can't see it because you have hypermetropia. So the corrective lens will, okay Sharma ji, the corrective lens will form that image at 75 centimeter first, so that your eyes can see it clearly. Okay, now we just have to find the focal length, right? So we'll use lens formula. Make sure you use negative sign in this. Now this will be minus 1 by 75, minus of minus 1 by 25. That will be, LCM will be 75, minus 1 plus 25, 3. So 1 by F will be 2 by 75, that is 37.5 centimeter. So focal length is 37.5 centimeter. Since the focal length is positive, that means it is a convex lens. That means it is a convex lens. Good? Very good. FF Gamer, Shashikala. Great. Now power of the lens, you just have to inverse the focal length, right? Physics formula, please. Physics formula. Just wait for 2 seconds, okay? Wait for a few seconds. Okay, so for power, you just have to inverse the focal length. That means the focal length was what? Focal length was 75 by 2. So power will be 2 by 75. Focal length was 75 divided by 2, right? So here if you write 75 divided by 2, 2 goes in the numerator, 2 by 75. And you can just solve it. This will be, power is, okay, this is in centimeters. So you'll have to use 100 here. The focal length is in centimeters, so formula will be 100, right? So 100 divided by 75 by 2, so 200 divided by 75. That will be 2.67777. Okay, so power will be 2.67, or not 777, 2.666. Right? So on, and this will be diopter. Do not forget to write the units. Yes. Great. Everyone, very good. Next we have twinkling of stars in the night sky is attributed to a phenomena of light. Choose the correct option that explains this phenomena. Atmospheric reflection of starlight, atmospheric refraction of starlight, atmospheric scattering of starlight, or atmospheric dispersion of starlight. What is the exact answer? B. Okay, we got the answer as B. B is actually the correct answer, atmospheric refraction of starlight. Great. Go as one, FF Gamer, everyone. Great. Next, we have, this is, okay. A child is able to read his book comfortably, but is unable to read the matter written on the board. Book he can read, but the matter on the board he cannot. Okay, Then name the defect of vision he is suffering from. He can see nearby objects clearly but not the far away ones. Myopia. FF Gamer is saying myopia. मैम आज वो टफ क्वेश्चन नहीं है. Which tough question, शर्मा जी? We already did that yesterday, no? So the defect is actually myopia. Very good, everyone. Correction of the above mentioned defect. Which corrective lens will be used for the correction of? पंजाबी आ गए ओए. मैम वो वाला. Which one? Myopia eye, Hari ji, exactly. Nearsightedness, short-sightedness, concave. Very good, very good, very good. We use concave lens. We use concave lens for the correction of myopia. One more question and that will be it for today. One more question for you guys. A person can read the number plate of a distant bus clearly, but he finds difficulty in reading a book. What type of defect of vision is this? Concave lens. Concave lens, yes, concave lens. Which defect is this and which lens will be used to correct this defect, everyone? Hypermetropia. Very good, Sharma ji. This is hypermetropia. Hypermetropia. And the corrective lens for this? The gauge one is also saying hypermetropia. Okay, Ansh. Convex lens. Very good, very good. FF Gamer, Sharma ji, gauge one. Great. We have convex lens for the correction of this. Regarding your formula sheet I have to see. Formula sheet. Oi baba. Formula sheet. Yes, we have the formula sheet here. So anyone who wants to revise the formula, let's revise it very quickly. Alright. Yes. Okay, we have 4 chapters. Electricity. What happened? Did the live stop? What happened? Okay, nothing happened. Okay, so in here the network stopped, I guess. Just a second, guys. Just a second. Okay, let me just leave that. Okay, let me look here. No, Bikram, no, you won't. Okay, let's do the formulas quickly. See, important formulas of the chapter electricity. We have Ohm's law and 4 Ohm's law. For Ohm's law, we have first formula, very important, Q equals to IT, and then Ohm's law formula, that is V equals to IR. What is this? V equals to IR. Okay, Q equals to IT and V equals to IR. SI unit is coulomb and ampere, right? Then we have potential difference. Potential difference is equal to work done per unit charge, which is unit is volt. P equals to V square by R, I square into R, V into I, unit is watt. Electrical energy, power into time, that is kilowatt hour. Then heat is I square into T, V square into T divided by R. Okay, thank you FF Gamer. I'm so glad that it was useful for you. Okay. And we have the power the unit as joule. Then resistance rho L by A, rho is rho R A by L, ohm meter, ohm are their units. Okay, then we have next. अरे यार, okay, next we have combination, so you can just add, and for parallel this is the formula. In series current remains the same, in parallel current does not remain the same. Okay, then we have magnification formula, height of image by height of object, refractive index n2 by n1, which is equal to v1 by v2. Then mirror formula 1 by v plus 1 by u, lens formula 1 by v minus 1 by u. Then mirror formula, we have magnification minus v by u, lens formula plus v by u. If magnification is positive, it's virtual and erect. If magnification is negative, the image is real and inverted. Then we have all these nature and positions. You can take a screenshot and you can go through it. Okay, Sharma ji, done. Next, we again for convex mirror, for convex lens, all the topics are here. For concave lens, all the topics are here. Then for magnetic effects of electric current, straight conductor, current upward or downward, direction of magnetic field is concentric circles, and factors affecting a current and 1 by distance. Then inside the closed loop, if current is clockwise, the direction of magnetic field will be inwards inside the loop. Okay. No, Sharma ji, no. Don't send request to someone else. Then anti-clockwise we have outwards. Okay, factors affecting our current, 1 by radius of loop, 1 by distance from the loop. Then solenoid, inside the solenoid it's south to north, outside the solenoid north to south. Current, number of turns, and 1 by distance from solenoid. Okay, next topic, power of lens 1 by focal length when focal length is in meters. Okay, it is diopter. Positive power means it is a convex lens, negative power means it is a concave lens. And that is it, everyone. Okay, that is it, everyone. We have completed our live session for today for complete science. Started with chemistry, completed the bio, completed the physics, and I hope we all are ready for our exam tomorrow. Are you ready? Okay, great. Everyone, this is it for today's live. We will meet you tomorrow at 4 AM for live revision. Okay, we'll be just seeing all the important things that you need to remember, just going before into the examination, quick morning session. Okay. Divyanshu online, what do you want to do me? Okay. Yes, Chirag. Next class, Hari ji, will be tomorrow morning 4 AM. If you want to quickly revise the whole science, come in that session. Okay. That is it for today's class. All the best, everyone. You have studied the whole year. It will be very fine. Don't worry at all. Just calm down. Whenever you think like this question is very hard, just take a deep breath, calm down, start the question solving from the basics, then go upstairs. From the basic, then go upstairs. Okay? Any unexpected questions, don't feel bad at that moment. At that moment, focus on solving the questions you know, focus on solving the questions you know the concepts of, solve them completely, and make sure your answer presentation is good. Okay? Okay, that is it. Bye everyone. All the best for tomorrow's paper. Bye.